Hello everyone, in this video we're gonna dive into more than 200 multiple choice questions to prepare for the AP Calculus BC exam. We're gonna review the following concept. Number 1. The existence of a limit. A function f(s) has a limit L as s approaches c if and only if limit of the function f(s) when s approaches c minus equals limit of the function f(s) when s approaches c plus, right? Now, number 2, we're going to talk about the continuity. A function is continuous at a point s equals a if and only if f of a exists. Limit of f of s when s approaches a minus equals limit of f of s when s approaches a plus. Limit of f of s when s approaches a equals f of a. Number 3, we're going to talk about the limit definition of a derivative. So we have f prime of s equals limit of f of s plus h minus f of s over h when h approaches 0. Or we have another form, it's going to be f prime of a equals limit when s approaches a of f of s minus f of a over s minus a. Now number 4, we're going to talk about the continuity and differentiability. A function is differentiable at a point, then it is continuous at that point. If the function continuous, then it may not be differentiable. We're going to talk about the L'Hospital rule. If the limit of f of s over g of s when s approaches a has the indeterminate form 0 over 0, infinitive over infinitive, negative infinitive over infinitive, infinitive over negative infinitive, or negative infinitive over negative infinitive, then the limit when s approaches a of f of s over g of s equals limit when s approaches a, you're gonna take derivative of the numerator and derivative of denominator. Alright, now we're gonna go to the number 1. Calculator not allowed. We need to find the limit of 4n squared over n squared plus 10,000 n. Alright, so when n approaches infinity, we're going to use the relative growth rate. This guy right here grows faster than this guy, right? So we can ignore this guy, right? So this guy becomes limit when n approaches infinity of 4n squared over n squared, right? This guy cancel out. The answer is 4. The answer must be D. Now let's move on to question 2. The limit of tangent 3 times s plus h minus tangent 3s over h when h approaches 0 is what right here? So we look at the formula right here. It's actually this form right here, right? So we can identify the function f of s, right? So this guy and this guy match, right? So we can conclude that f of s equals tangent 3s, right? And remember, this guy right here actually f prime of s, right? Look at this one right here. So we're gonna take f prime of s equals, we're gonna use the formula tangent u prime. It's gonna be u prime secant square u, right? So this guy becomes 3 secant square 3s, right? So the answer must be B. Now question 3. We need to find the limit of 7s minus sine s over s squared plus sine 3s when s approaches 0, right? So we're going to substitute 0 for s to see what happens, right? So we have limit of 7s minus sine s when s approaches 0, right? So it could be 0. Limit of s squared plus sine 3s when s approaches 0 is still 0. So we have the indeterminate form 0 over 0, right? So we say the L'Hospital rule apply. So it's going to be limit when s approaches 0. Take the derivative of this one, it could be 7 minus cosine s over 2s. Sine u, it could be u prime times cosine u, right? So it could be plus 3 cosine 3s, right? Now substitute 0 for s, it could be 7 minus cosine 0, it could be 1 over 2 times 0 could be 0, and then it could be 3 cosine 0, it could be 1, right? So like that. So it could be 6 over 3, it could be 2. The answer must be B. Now question 4. We need to check to see if the function is continuous at s equals 3, right? So we have f of 3, right? So we see the equal sign right here, right? We need to use this one. So it could be 6 times 3 minus 9. It could be 9, right? Now we need to find the limit of the function f of s when s approaches 3 minus, which is this guy right here, right? So it could be 3 square, it could be 9. And limit of f of s when s approaches 3 plus, right? So it could be this guy right here. 6 times 3 minus 9. It's going to be 9, right? So we see that limit of f of s when s approaches 3 is it, right? Because the left and the right the same, right? And then we have the limit of f of s when s approaches 3 equals f of 3, and they both equals 9, right? So then the function is continuous at s equals 3, right? Now we're going to check to see if the function is differentiable, right? So we need to take the derivative of this one, right? So I have f prime of s equals derivative of this one could be 2s for s less than 3 and 6 for s greater than or equal to 3, right? Now in order to check for the differentiability, we need to find the limit of the function f prime of s when s approaches 3 minus, right? It's going to be this guy right here. 2 times 3 is going to be 6. And this guy actually equals the limit of f prime of s when s approaches 3 plus, which is this guy right here, equals 6, right? So then you can conclude that the function is differentiable. So the answer must be E. Question 5. The figure above shows the graph of a function f with the domain 0 to 4. Which of the following statements are true? Number 1. Limit of ls when s approaches 2 minus is this. Alright, so 2 minus, which means this guy right here. Right, so we're going to pick this guy right here. Yes. Right. Limit of ls when s approaches 2 plus, which means 2 to the right, which is we're going to pick this guy right here. Yes, right. Limit of ls is it when s approaches 2? No, right? Because this guy right here equals something right here. For example, I'm going to say 2. And this guy right here is going to be 1, right? So they're not the same. 2 and 1 not the same. So the limit of ls when s approaches 2 does not exist. So only C correct, right? Now let's move on to question 6. If the function ls equals 2s squared plus 1, then we need to find this limit, right? So this guy is the same thing as limit when s approaches 0. ls, I'm going to replace this one with 2s squared plus 1, right? And f of 0, substitute 0 for s over here, so it could be minus 1, right? Over s squared, right? So 1 minus 1 is going to be 0. So I'm going to end up with limit of 2s squared over s squared when s approaches 0, right? This guy cancel out. The answer is 2, right? The answer must be C. Now let's move on to question 7. If f prime of s equal cosine s and g prime of s equal 1 for all s, if f of 0 equals g of 0 equals 0, then we need to find this one, right? So, look, this is f of s, this is g of s, right? We don't have it, we need to find it, right? So we need to take entire derivative both sides, like that, right? So, you have f of s equals sine s plus c. So, we're going to use initial condition right here, right? To solve for c, right? So, we have f of 0 equals sine of 0 plus c, and this one actually 0 right here, right? So sine of 0 equals 0, so c equals 0. So then you have f of s equals sine s only, right? Now similarly, we're going to take entire derivative of this one, right? So we have g of s equals s plus c, right? And we use initial condition right here, right? So we have 0 plus c equals 0, right? Because g of 0 equals 0. So then c equals 0, right? And then you have g of s equals s only, right? So we have the limit right here equals limit when s approaches 0 of sine s over s. And this is the formula, actually 1, right? The answer must be B. Now we have another way to do this one. We can use the L'Hospital rule, right? So we have limit of f of s over g of s when s approaches 0. It's going to be limit of f prime of s over g prime of s when s approaches 0, right? And it's going to be f prime of 0 over g prime of 0, right? And f prime of 0, we have f prime of s equal cosine s, right? So it will be cosine of 0 over g prime of 0 equals 1, right? Right here. So cosine of 0 equals 1, so it will be 1 over 1, the answer must be 1, right? Now let's move on to question 8. Given the function f of s right here, let f be the function defined above. Which of the following statement about the function f true? Alright, limit of f of s when s approaches 2 minus equal limit of f of s when s approaches 2 plus. Alright, so we need to find limit of f of s when s approaches 2 minus, we're going to use this guy right here, right? So it could be limit of ln of 4s minus 7 when s approaches 2 minus, right? So we substitute over here, we have ln of 8 minus 7, and it's going to be ln of 1 is going to be 0, right? Limit of f of s when s approaches 2 plus, it's going to be this guy right here, right? So it could be limit of 4s minus 7 when s approaches 2 plus, and it's going to be 1, right? Now this guy and this guy are different, right? So the limit right here does not exist, right? So the answer is number 1 wrong. Now number 2, we're going to check the derivative of this one. So we have f prime of s equals derivative of ln u. It's going to be u prime over u, right? Where u equals 4s minus 7, right? So it could be 4 over 4s minus 7 for s less than 2. And the bottom one right here is going to be 4 for s greater than or equal to 2, right? So we need to find the limit of f prime of s when s approaches 2 minus, we're going to pick this guy right here, right? So it could be limit of 4 over 4s minus 7 when s approaches 2 minus, right? So it could be 4 over 1 is going to be 4, right? Limit of f prime of s when s approaches 2 plus is going to be limit of for when s approaches 2 plus, right, which is the bottom right here, and it's going to be 4, right? The left and the right the same, right? So number 2 is right? The function f is differentiable as s equal 2. This is not quite correct because the function is not continuous as s equal 2, right? Number 1 is wrong. So remember, if the function is not continuous at a point, it will not be differentiable at that point, right? So only 2 correct, which is B. Now let's move on to question 9. If the limit of the function f(s) when s approaches a equals L, where L is a real number, which of the following must be true? Alright, so for example, I'm going to let the function f(s) equals 3, right? And I'm going to sketch this one. So f(s) equals 3 is right here. Suppose the function f(s) has a hole right here, right? And the x-coordinate of the hole right here should be a, right? So the function is not differentiable at this point because it has a hole. A is wrong. The function f(s) is not continuous at this point. This is wrong. The function f(s) is not defined at this point, right? This is wrong. f(a) is not equal L, right? Because only limit, right? So this one wrong. So the answer must be E. Now let's move on to question 10. For s greater than or equal to 0, the horizontal line y equal to is an asymptote for the graph of the function f. Which of the following statement must be true? Just get the graph, you will see it. So y equal to is going to be right here. This is a horizontal asymptote. Alright, so suppose I have the rational function. It could be something like this. Now f of 0 equals 2. It's not correct, right? Question B. f(s) different from 2 for all s greater than or equal to 0. It's not correct, right? Question C. f of 2 is undefined. It's not necessarily true, right? Question D. Limit of the function f(s) when s approaches 2 is equal infinity. No. Limit of f(s) when s approaches infinity. Yes, infinity right here. Equals 2, right? This is horizontal asymptote, right? The answer must be E. Now let's move on to question 11. If the graph of y equal ax plus b over s plus c has a horizontal asymptote y equals 2 and a vertical asymptote s equals -3, we need to find the sum of a plus c. Alright, you know that the horizontal asymptote is the ratio of the leading coefficient of the numerator and denominator, right? So leading coefficient right here is 1. This is a, right? So you have a over 1 equals 2, and then a equals 2, right? Now we need to solve for c. We have the vertical asymptote right here, s equals -3. So we need to convert this one to factor, right? So s equals -3. Add 3 both sides, so s plus 3 equals 0, right? So this one is the factor, and you have the factor right here, s plus c, right? So we put s plus c right here. We just match this guy up, right? So c equals 3, right? And a equals 2. We add this guy up, it's going to be 5. The answer must be E. Now let's move on to question 12. We need to find the limit of this function when s approaches infinity. We can use the relative growth rate. When s approaches infinity, 2s grows faster than this one. We can ignore the constant right here, right? We can ignore 3 right here. We can ignore this guy, and we can ignore this guy, right? So it's going to be limit of 2s times negative s is going to be -2s squared. The bottom s times s is going to be s squared, right? When s approaches infinity, this guy cancel out. The answer is -2. The answer must be B. Now let's move on to question 13. Given the function f(s), now question 1 right here, the function f has a limit as equals 2, right? So limit, which means we're going to pick this one right here, right? So we need to find limit of the function f of s when s approaches 2. It's going to be limit of s squared minus 4 over s minus 2 when s approaches 2, right? And it's going to be limit when s approaches 2. Factor the numerator is going to be s minus 2 times s plus 2 over s minus 2, right? This guy cancel out. Substitute 2 for s is going to be 4, right? So, number 1, correct. Now, number 2, the function f is continuous at s equals 2. Now, in order for the function f to be continuous at s equals 2, we need the limit right here must be the same thing as f of 2, right? So f of 2, we're going to use the bottom one right here equals 1, right? This guy and this guy different. Number 2 is wrong, right? Now, number 2 is wrong, number 3 must be wrong because the function is not continuous, it's not going to be differentiable, right? So number 3 automatically wrong. So the answer must be A. Now let's move on to question number 14. Let f be the function given above. What are all values of a and b for which the function f is differentiable at s equals 2? Now, in order for the function to be differentiable, it must be continuous first, right? So, we need to find limit of the function f of s when s approaches 2 minus, right? It's going to be this guy right here. So, substitute 2 for s. So, it's going to be limit of s plus 2b when s approaches 2 minus, and it's going to be 2 plus 2b, right? Now, limit of the function f of s when s approaches 2 plus, we're going to use this one. So it could be limit of a s squared when s approaches 2 plus, substitute 2 for s, it could be 4a, right? So, we need the function to be continuous first, right? So, the function continuous, then we have 2 plus 2b equals 4a, leave it over there, right? We need the function to be differentiable at s equals 2. We need to take derivative of this one. So, f prime of s equals 1 if s less than or equal to 2. Be 2a s if s greater than 2, right? So in order for the function to be differentiable at s equals 2, we need limit of the function f prime of s when s approaches 2 minus equals limit of the function f prime of s when s approaches 2 plus, right? So it's going to be 1 equals 2as, right? But s equals 2, so we have 2a times 2. It's going to be 4a, right? So a equals 1 over 4, right? Substitute 1 over 4 over here. So we have 2 plus 2b equals 4 times 1 over 4 is going to be 1, right? So b equals negative 1 over 2, right? So the answer must be A. Now question 15. If the function f is continuous for all real numbers, and if f of s equals this one when s not equal to 2, then f of negative 2 equals. Now remember, if the function f of s is continuous, we have limit of the function f of s when s approaches c must be equal to f of c, right? Now we need to find the limit of this one. So limit of f of s when s approaches negative 2, right, equals limit of s squared minus 4 over s plus 2 when s approaches negative 2, right? So we factor the numerator is going to be limit when s approaches negative 2 of s minus 2 times s plus 2 over s plus 2, right? We cancel out, right? Substitute negative 2 for s, it could be negative 4, right? And then it's going to be f of negative 2. So the answer right here must be negative 4, right? The answer must be A. Now, number 16. The graph of the function f is shown above, at which value of s is the function f of s continuous, but not differentiable, right? So the function is continuous but not differentiable. Look at this one, the sharp turn right here. Whenever we see the sharp turn, the function is not differentiable, right? But the function is continuous as equal a, right? So the answer must be a right here. Now let's move on to question 17. For which of the following does the limit of ls when s approaches 4 exist? Right? So we look at the function right here, 4 here, 4 here, and 4 here, right? So we need limit of the function ls when s approaches 4 minus equals limit of the function f of s when s approaches 4 plus, right? So this one right here, 4 minus 4 plus, you have the same values right here. It's going to be 3, right? This one, same thing, same values, 4, right? 4 minus equals 4, right? And 4 plus equals 2, right? They are different, right? So number 3 is not the right answer, right? Only 1 and 2 correct, right? So the answer must be D. Now, number 18, limit of ln s minus 1 over s minus e when s approaches e is what, right? We substitute over here, we have limit of ln s minus 1 when s approaches e equals ln e minus 1 is going to be 1 minus 1 is going to be 0. Limit of s minus e when s approaches e equals 0, right? So we have indeterminate form, right? So the last filter rule apply. So now we're going to check the derivative of the numerator and denominator, right? So we have limit when s approaches e. ln s is going to be 1 over s. Derivative of 1 is going to be 0. Divide by 1, right? Substitute e for s, so it will be 1 over e, right? So the answer must be A. Now let's move on to question 19. The graphs of the function f and g shown above. The value of the limit of f of g of s when s approaches 1. Alright, so this one is the limit of composite function, right? So it's going to be the same thing as f of limit of g of s when s approaches 1, right? So look at the function g right here. When s approaches 1, you get 2 right here, right? So it will be f of 2. Look at the left ones right here. F of 2 equals 3, right? So the answer must be C. Now let's move on to question 1. The graph of y equals ls is shown in the figure above. On which of the following intervals dy over ds greater than 0. This one is the same thing as f prime of s greater than 0, right? And d squared y over ds squared less than 0. This guy is the same thing as f double prime of s less than 0, right? So this one greater than 0 tells us that the function f of s is increasing, right? And this guy tells us that the function f of s is concave down. So it could be something like this or like that, right? Now we explore the graph right here. The function is increasing, right? So it's going to be this interval only, right? Because this interval is decreasing, right? So you need to eliminate C and D right here, right? Now, f double prime of s is less than 0, which means the function is concave down, right? So concave down is right here, right? This guy is concave up, right? So the answer must be B to C. So it could be right here. So the answer must be B. Now let's move on to question 2. The graph of a choice differentiable function f is shown in the figure above. Which of the following is true? Alright, f1 less than f prime of 1 less than f double prime of 1. Or B, C, D, and E, right? So in order to do this one, we need to use the Christmas tree trick, right? If the graph's going up like this, the slope is positive, the function is increasing, right? If the graph's going down like this, the slope is negative, the function is decreasing, right? If the graph is horizontal, the slope is 0, right? If the graph is vertical, the slope is undefined, right? Now, we look at this one right here, we see that this is a function f of s, right? So f of 1 equals 0, we write over here f of 1 equals 0, right? Now, f prime of 1, we're going to draw the tangent line at 1, right? So it will be something like this, right? So the slope is positive, right? Right here. So we have f the program of 1 right here, positive, right? Now next one, right at 1, the function is concave down, look, right? So f the program of 1 right here must be less than 0, right? Now we're going to compare this one, of course, f the program of 1 less than f of 1 less than f prime of 1, right? Based on this guy right here, right? So the answer must be D, right? Now let's move on to question 3. The function f is given by ls equals s to the 4 plus s squared minus 2. On which of the following intervals is f increasing, right? So f increasing, which means f prime of s greater than 0, right? So we need to take the derivative of the function ls is to be 4s cubed plus 2s, right? We need to find the critical number, right? So we're gonna let f prime of s equal to 0. This guy is the same thing as 4s cubed plus 2s equals 0. Factor 2s out. So we have s squared plus 1 equal to 0. Now this one is the 0 product, right? So we have either 2s equals 0 and s squared plus 1 equals 0, right? So we solve for s, we only need s equal to 0, right? This one is undefined because this guy always greater than equal to 1, which is greater than 0, right? So we only have one critical number, right? We're going to use the side charts right here, right? So we put 0 right here, the left side is negative infinity, the right side is positive infinity because the domain of the polynomial function is real numbers, right? Now we're going to test value, right? So I'm going to pick 1 in this interval, right? I substitute 1 for s back to the function f prime of s right here, right? So I have 4 times 1 cubed plus 2 times 1, which is positive, right? So this interval positive, this guy automatically negative, right? So the function is decreasing and increasing right here, right? So we look at this one, we see that the function f is increasing on the interval 0 to infinity. The answer must be C. Now question 4. Given the function defined by ls equals 3s to the 5th minus 20s cubed, find all values of s for which the graph is concave up, right? So the function is concave up if f the program of s greater than 0, right? Now we're going to take the derivative of this one, so f prime of s equals 15 s to the 4 minus 60 s squared, right? And f the program of s equals 60 s cubed minus 120 s, right? We need to let f the program of s equals 0 to solve for s, right? So we have 60 s cubed minus 120 s equals 0. Factor 60 s out. So we have s squared minus 2 equals 0. And then we're going to use the 0 product, right? So 60s equals 0 and s squared equals 2, right? And then this guy becomes s equals 0 and s equals plus and minus root 2, right? So we're going to use the number line, right? So put these critical values on the number line. The first one is negative root 2. The second one is 0, the third one is root 2, right? The right side is positive infinity, the left side is negative infinity, right? Now we're going to test the number. So I'm going to pick the number 1 right here, right? Substitute 1 for s into the second derivative right here. Right? So we have 60 times 1 cubed minus 120 times 1, which is negative, right? So this interval is negative. This guy must be positive. This guy is positive and this guy is negative. You just keep changing sign, right? If you don't have the even multiplicity. But if you have even multiplicity, you need to be careful. The function passing the root that has even multiplicity, the sign does not change. So keep that in mind. Now, we need the function to be concave up, which is at the prime of s greater than 0, right? So the interval should be this guy right here. This guy right here, right? So we look at the answer choice. It's going to be negative root 2 to 0 and root 2 to infinity, right? It's going to be B right here. Now let's move on to question 5. What are all values of s for which the function f is divided by fs equals s squared minus 3 times e to the negative s is increasing, right? So we need a CRAM of s greater than 0, right? So we take the derivative of this one. We're going to use the product rule, right? So it's going to be 2s times e to the negative s, right? Minus e to the negative s times s squared minus 3, right? Now I want to factor e to the negative s out, right? So I have 2s, negative 1 times s squared could be negative s squared. Negative 1 times negative 3 could be positive 3, right? So I need to let f prime of s equals 0 is the same thing as this guy right here always positive, right? So I don't need to worry about this one, right? So it could be negative s squared plus 2s plus 3 equals 0, right? So I multiply both sides by negative 1, so it could be s squared minus 2s minus 3 equals 0, right? Factor this one, it could be s minus 3 times s plus 1 equals 0, right? So s equals 3 and s equals negative 1, right? So I'm going to use the number line, right? So I put negative 1 right here and 3 right here. The right hand side is positive, the left hand side is negative, right? Now I'm going to test one interval, right? So I'm going to put 0 right here, right? So I substitute 0 for s back to the f prime of s right here, right? So I have this one 0, right? This one becomes negative e to the 0, it will be 1 times 0 minus 3, right? So it will be 3, which is positive, right? This one positive, this one negative, and this one is negative, right? Now we need the function to be increasing, which is f prime of s greater than 0, right? So only this interval works, right? So the answer must be negative 1, 2, 3, right? So it will be D. Now let's move on to question 6. If f the prime of s equals s times s plus 1 times s minus 2 squared, then the graph of f has inflection points when s equals how much, right? So we need to find the critical numbers right here, right? So we have f the prime of s equals 0, right? So it could be s equals 0, right? And s plus 1 equals 0, s equals negative 1, right? S minus 2 equals 0, s equals 2. But this one is even multiplicity. Alright, so you need to be careful with this guy. Alright, so we're going to draw the number line right here. We're going to place negative 1, 0, and 2 on the number line, right? Now we're going to test the interval, right? So I'm going to pick 3 right here. So I substitute 3 for s back to the function right here, right? So I have 3 times 3 plus 1 times 3 minus 2 squared, always positive, right? So this interval is positive. Now write s equal 2. We have even multiplicity, which means the function bounces back. The sign does not change, right? So this guy positive, this guy must be positive. Keep that in mind. Now, right at 0 and negative 1, we don't have even multiplicity. So the size keeps changing, right? So this is positive, this guy must be negative, and this guy is positive, right? We need to find the inflection points, which means the sign of the second derivative changing, right? So the sign changes at this point and at this point. Look, positive to negative and negative to positive. At this point, the sign doesn't change, right? So the answer must be s equal -1 and 0 only, right? The answer must be C. Now let's move on to question 7. The derivative g prime of a function g is continuous and has exactly 2 zeros. Select the values of g prime are given in the table above. If the domain of g is a set of all real numbers, then the function g is decreasing on which of the following intervals? The function g is decreasing. It tells us that g prime of s must be less than or equal to 0, right? So we look at the table right here, g prime of s right here, right? So the values that less than or equal to 0 are -3, -2, -1, and 0, 0 right here. So the interval must be from here to here, right? -2 to 2, the answer must be A. Now, question 8. The function y equals fs is differentiable and decreasing for all real numbers. On what interval is y equals f of s squared minus 4s decreasing? This one is the composite function, right? We need to take the derivative of y. It's going to be s squared minus 4s prime times f prime of s squared minus 4s, right? So it's going to be 2s minus 4 times f prime of s squared minus 4s, right? Now we need to find the critical numbers for this one, right? So we left y prime equals 0 is the same thing as 2s minus 4 times f prime of s squared minus 4s equals 0, right? Now this guy is the same thing as 2s minus 4 equals 0 and f prime of s squared minus 4s equals 0, right? But this one cannot be equal to 0, right? Look at this one right here. The function y equal fs is decreasing for all real numbers, right? So which means this one right here always less than 0, right? So we only need this one right here equal 0. We solve for s, so s equals 2, right? So we set up the side charts, right? So we put 2 on the number line and then go from negative infinity to positive infinity, right? Now we need to test the interval, right? So suppose I'm going to pick 0 right here, right? So substitute 0 back over here, y prime right here, right? So I have -4 times a number right here less than 0, right? So it's going to be positive, right? So this interval has the positive side and then this interval has the negative side, right? So the function is increasing on this interval and decreasing on this interval, right? Now we need to find the interval where the function is decreasing, right? So the function is decreasing on the interval 2 to infinity, right? The answer must be C. Now let's move on to question 9. For all s in the closed interval 2 to 5, the function f has a positive first derivative. It tells us that f prime of s greater than 0, right? The function f of s is increasing, right? And a negative second derivative. It tells us that the function of the first derivative of s is decreasing, right? Now we're going to combine this guy and this guy. It tells us that the function is increasing at a decreasing rate. Alright, now we need to eliminate the answer choice C, D, and E because the function is decreasing. Look at the y value right here. It keeps decreasing, right? 16, 14, 11, 7, and 16, 13, 10, 7, right? Now, only the y values right here increasing, right? So it's match the first one right here. Now, we need to find the rate of change and make sure the rate of change is decreasing, right? So, now we need to find the change from 9 to 7 plus 2 plus 3, right? And this is plus 4. This one plus 4 plus 3 and plus 2, right? So the rate of change for the first table right here is going to be 2 divided by 1 and 3 divided by 1, right? Right here, 1. And 4 divided by 1. And you see that the rate of change is increasing, right? For this one right here, you have 4 divided by 1, right? 3 divided by 1 and 2 divided by 1, right? The rate of change is decreasing, right? So it matches this guy right here, decreasing, right? So the answer must be B. Now let's move on to question 10. Let f be the function defined by fs equals s cubed minus 3s squared, on which of the following intervals is f prime both positive and decreasing, right? So we need to find f prime of s equals 3s squared minus 6s, right? So we need to let f prime of s equals 0, right? So it could be 3s squared minus 6s equals 0, right? Factor 3s out, so it could be s minus 2 equals 0, right? So you have 3s equals 0 and s minus 2 equals 0. This guy is the same thing as s equals 0 and s equals 2, right? So we're going to draw the number line, place 0 and 2 here. The left side negative infinitive, the right side is positive infinitive, right? Now, I need to test an interval, right? So I pick one right here. Substitute 1 for s back to the f prime of s right here, right? So we have 3 times 1 minus 6 times 1, right? And it's going to be negative 3, which is less than 0, right? So this guy has a negative sign, right? We don't have even multiplicity, so the sign keeps changing, right? This one positive and this one's positive, right? Now, the function f prime is positive within this interval, right? Now, we need to find the interval where f prime is decreasing. F prime is decreasing. It tells us that f double prime of s must be less than 0, right? We need to find the second derivative of s, right? We're going to take the derivative of this one, right? So it will be 6s minus 6. We're going to let this one equal 0, right? So s equals 1, right? So we're going to draw the number line right here. Negative infinitive, positive infinitive, and 1 right here, right? This one is the critical number, right? So we're going to test the value. I'm going to pick 0 right here. I substitute 0 for s into the second derivative function right here, right? So I have 6 times 0 minus 6 is going to be negative 6 less than 0, right? So this interval has the negative sign. This interval has the positive sign, right? So we need to find the interval where double prime of s less than 0, right? Which is this guy right here. Finally, we need to find the intersection between this interval, and this interval, right? So the only intersection that satisfies this condition is negative infinitive to 0, right? So the answer must be A. Now let's move on to question 11. If fs equals s squared times e to the s, then the graph of f is decreasing for all s such that, right? So we need to find the first derivative, right? So f prime of s equals, use the product rule, right? So it will be 2s e to the s plus s squared e to the s, right? So we're going to factor e to the s out. So it will be 2s plus s squared, right? We're going to let the first derivative equals 0. So it's going to be 2s plus s squared equals 0, right? We don't need this one because it's all quite positive, right? So we're going to factor s out. So it could be 2 plus s equals 0, and then s equals 0 and s equals negative 2, right? Now we're going to draw the number line. Negative 2, 0, negative infinity, positive infinity, right? Now we're going to test the interval. So I'm going to pick one right here. So I substitute back to this one, right? So it's always positive, right? So this one positive, negative, and positive, right? Now we need to find the interval where the function f is decreasing, right? Which is f prime of s less than 0, right? So only interval that satisfies this condition is negative 2 to 0, right? So the answer must be B. Now let's move on to question 12. Three graphs labeled 1, 2, 3 shown above. One is the graph of f, one is the graph of f prime, and one is the graph of f double prime. Which of the following correctly identifies each of the three graphs, right? So we have f prime, f double prime, and the order right here, right? So let's review a little bit about the relationship between f prime, and f double prime, right? So we'll look at this one right here. Now remember the relative minimum or maximum of the function f of s will be the 0 of the function f prime of s. So we'll look at this one right here. Similarly, the relative extrema of the function f prime of s will be the zeros of the function f double prime of s. So keep that in mind, alright? One more thing you need to consider is the inflection point of the function f of s will be the relative minimum or relative maximum of the function f prime of s. So it can be like this, right? Alright, so keep that in mind. Now we're going to go back over here. Observe that this guy has the relative mass, right? When s equals 1 point something, suppose it was 1.3, right? And this one relative minimum, right? It's going to be 1, 2, 3, 4, 4.6 something, right? This guy right here must be the 0 of the function f prime of s, right? So suppose this one is the function f of s. Now we look at f prime. So we look at this one right here, the 0 right here. 1.3 something, right? This one right here, 1, 2, 3, 4, 4.6 something, right? So this one match f of s. This one f prime of s, right? Now we look at the maximum right here and minimum right here. So maximum is at s equals 0.5 and minimum is at s equals 1, 2, 3, right? These two guys right here becomes the 0 of the function f double prime, right? So 0 right here, right? 0.5 and this one 1, 2, 3, right? So this one is f double prime of s, right? So the answer must be 2, 3, and 1, right? 2, 3, 1, the answer must be C. Now let's move on to question 13. Let f be the function given by f of s equals cosine 2s plus ln 3s. What is the least value of s at which the graph of f changes concavity? Now, since this one is the calculator active problem, right? So we need to find the least value of s at which the graph of f changes concavity, right? So we need to find the first derivative of s. Right? It's going to be negative 2 sine 2s plus 3 over 3s, right? So we're going to simplify. It's going to be negative 2 sine 2s plus 1 over s, right? So we're going to print out the calculator. Now you either calculate derivative by hand, or you can use the calculator. Since the question allows you to use calculator, right? So I'm gonna add calculator, right? So I'm gonna hit F of S. Now I need to store the function, so I need to hit Control and the button right here, and I just input the function. It could be cosine 2s plus ln 3s. So I'm gonna hit trick right here, cosine 2s plus ln control ln 3s, and then press enter. Done, right? Now you need to find the first derivative, right? So you're gonna hit the button right here and find the first derivative. It's gonna be right here. Derivative of this function with respect to s, right? And then press enter. It's gonna be right here. Now you need to grab this one, right? So you're gonna go to home screen, hit graph right here, alright? F1 of S, which is hit graph. Now the question wants you to find the least value of S at which the graph of F changes concavitive. It's the same thing as finding the least value of S where f prime of S changes from increasing to decreasing or decreasing to increasing, which is we need to find the smallest value right here, right? So we need to hit menu, go to number, set, and find the minimum of this one, right? It's gonna be this guy right here. The answer is 0.93, right? So the answer must be B. Now let's move on to question 14. Let f be a function that is continuous on the closed interval -2 to 3, such that f prime of 0 does not exist. F prime of 2 equals 0, and f the program of s less than 0 for all s except s equals 0. Which of the following could be the graph of the function f, right? So we're going to look at this one right here. The function must be continuous, right? So we're going to eliminate answer choice D, right? Because the function is discontinuous at s equals 0, right? Next one, f prime of 0 does not exist. It tells us that the function f is not differentiable at s equals 0, right? So normally you're going to see the sharp turn like this. Oh, the function is discontinuous, right? So you're going to eliminate answer choice C, right? Because the function is differentiable right here, right? Now, f prime of 2 equals 0, s equals 2 is a critical number, right? So it's normally is where the function has the maximum or minimum. So we look at s equals 2, we have the minimum right here, maximum right here, maximum. Now lastly, f the program of s less than 0 for all s except s equals 0, right? It tells us that the function f of s is concave down, right? It's either this one or this one or this one like this, right? So we look at the answer choice right here, this one concave down, right? So the answer must be E, right? This one is concave up. This one is concave up, right? Now question 15. Let f be the function with derivative defined by f prime of s equals sine s cubed on the interval -1.8 to 1.8. How many points of inflection does the graph of f have on this interval? Now you have two different ways to do this problem. If you use the function f prime of s, and then you need to count to see how many times f prime of s changes from increasing to decreasing or decreasing to increasing, right? Or you can use the second derivative of s, and you need to count how many times the function f, the program of s, changes sign on the interval negative 1.8 to 1.8, right? So I'm going to use the second derivative of s to do this one, right? So I'm going to print up the calculator. Now I need to take derivative of this one, right? So I'm going to hit the button right here and derivative right here with respect to s, and then I'm going to input sine of s cubed, right? And then press enter. It could be 3s squared times cosine of s cubed, right? So I'm going to go to the graph. I'm going to input and then press enter. Now I need to restrict the domain from negative 1.8 to 1.8, right? So I'm going to hit menu number 4 right here, Windows Edit right here, negative 1.8 to 1.8. Okay, it's going to be right here. Now observe that the function at the program of s changes sign from positive to negative right here, right? And negative to positive, right? And positive to negative right here, and negative to positive right here. Totally, you have 4 times at the program of s changes signs on this interval, right? So we're going to go back over here. The answer must be C. Now let's move on to question 16. If the derivative of f is given by f prime of s equals e to the s minus 3s squared, ask which of the following values of s does the function f has a relative maximum value, right? So we're going to use the calculator, right? So in order for the function f to have a relative maximum, the function f prime of s must change sign from positive to negative, right? This one is mass. Now, if negative to positive, this one is minimum, right? So we don't need this one, right? We need this one right here. So we're going to print up the calculator. Alright, so it's going to be right here. The part of the function above the axis is positive, and the other part of the function below the axis is negative, right? So positive to negative. This one is the relative maximum. This one right here is the relative minimum. So keep that in mind, right? So we need to find the intersection right here, right? So we need to hit menu number 6 and hit zeros right here. Go to the left. Go to the right, the answer is 0.91, right? So the answer must be C. Now let's move on to question 17. If g is a differentiable function such that g of s less than 0 for all real numbers s, and if f prime of s equals s squared minus 4 times g of s, which of the following is true? Alright, so the question wants you to determine the relative minimum or relative maximum, right? So think about the first derivative, right? So we need to find the critical number, right? So we're going to let f prime of s equals 0 is the same thing as s squared minus 4 equals 0, and g of s equals 0, right? But g of s always less than 0, right? So we don't need to worry about this one, right? So we have s equals plus and minus 2, right? We're going to draw the number line. Put negative 2 here, positive 2 here, right? Negative infinity, positive infinity, right? Now we're going to test the number, right? We're going to pick 0, substitute here. It's going to be 0 minus 4, it's going to be negative 4 less than 0, right? So within this interval, the function f prime of s has the negative number, right? This one is positive, this one is positive, right? So this one is the side charge for s squared minus 4, right? Now we need to create a side charge for g of s, right? Now the function g of s is always less than 0 for all real numbers, right? So this one negative, 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 right? Now we need to find the side charge for f prime of s, right? So f prime of s, we need to multiply G of S and this guy, right? So positive times negative is going to be negative. Negative times negative is going to be positive. Positive times negative is going to be negative, right? And we have negative 2 right here and 2 right here. F prime of S is less than 0, the function is decreasing, right? This one increasing, this one decreasing, right? So this is relative minimum, and this one relative maximum. So the answer must be B. Now let's move on to question 18. The graph of the function h of s is shown above. Which of the following could be the graph of the function h prime of s, right? So we're gonna review this one right here. Remember, the relative minimum or relative maximum of the function f of s becomes the zero of the function f prime of s, right? So we're gonna go back over here. We need to eliminate the wrong answer, right? So we see the relative maximum right here and relative minimum right here, right? We need to eliminate A and B, right? Because there is no zero right here, right? And this guy, there's no zero right here, right? Within this interval, the function is increasing, right? So you just draw the tangent line. The slope of the tangent line is positive, right? Which means the function h prime of s is above the axis, right? Because the slope is positive, right? So you see that this one above the axis, right? Similarly, for this one right here, the function is increasing, right? The function f prime of s must be positive, right? And it's going to be above the axis right here, right? Now look at this one right here, this guy below the axis, so the answer C is wrong, right? Now only D and E could be the answer, right? Now we look at the interval right here. You see that the function is concave down within this interval, right? It tells us that f, the program of s, must be less than 0 on this interval, right? If f, the program of s, less than 0, the function f prime of s is decreasing on that interval, right? And when f prime of s decreasing on that interval, the slope of the tangent line must be negative, right? Remember the Christmas tree trick. This one positive, negative, 0, and undefined, right? So we draw the tangent line of the function f prime of s right here. We see that the slope is negative, right? Now we look at this one, we draw the tangent line right here, it's slope negative, right? But this interval right here, the slope is positive, right? So we're gonna rule out the answer choice D, only E correct, right? Now let's move on to question 19. The graph of the derivative of the function f is shown in the figure above. Which of the following could be the graph of the function f, right? So we look at this one, the shape of the function f prime of s is quadratic, right? So the original function must be cubic, right? So we need to eliminate the answer A and B, right? Because they are linear, right? Now only C, D, E could be correct, right? We look at this guy right here. The zero of the function f prime of s will be the relative extrema of the function f of s, right? So f were negative 2 and 2. We need to look for the relative extrema, right? So it could be right here and right here. This one is wrong, right? Because it's not negative 2 and 2, right? This one could be right? Negative 2 and 2 right here, right? Now, the last one. From negative infinity to negative 2, the function f prime of s is below the axis, right? So within this interval, f prime of s less than 0, right? It tells us that the function f of s is decreasing on this interval, which is negative infinity to negative 2, right? So the function is decreasing, which means the slope of the tangent line is negative, right? So we draw the tangent line right here. We see that the slope is negative within this interval, right? Remember the Christmas tree trick, positive, negative, 0, undefined, right? So the answer must be E. Now let's move on to question 20. The function f is given by ls equal s cubed plus 3s squared minus 9s minus 4. What is the absolute maximum value of the function f on the closed interval -4 to 2? Alright, so we need to use the candidate test, right? Check the first derivative of this one. So we have f prime of s equals 3s squared plus 6s minus 9. Let f prime of s equals 0, right? So we have 3s squared plus 6s minus 9 equals 0. Divide both sides by 3. So we have s squared plus 2s minus 3 equals 0. Factor this one out. It's going to be s plus 3 times s minus 1 equals 0. S equals -3 and s equals 1, right? Now I'm going to show you the shortcut to solve this one without factoring, right? So if you have as squared plus bs plus c equals 0. Now if a plus b plus c equals 0 and you have two solutions, s equals 1, s equals c over a. Now, if you have a minus b plus c equals 0, you have two solutions, s equals -1 and s equals -c over a, right? So I'm going to apply this shortcut, right? So I have a plus b plus c equals 1 plus 2 minus 3 equals 0, right? So I'm going to apply the first one right here. S equals 1. S equals c over a, which is -3 over 1 is going to be -3. So it's going to be right here, right? Now we're going to use the candidate test, right? So we need to calculate f of -3, f of 1. Now don't forget the endpoints right here. So f of -4 and f of 2. F of -3, substitute -3 for s back to the original function right here. So we have -3 cubed plus 3 times -3 squared minus 9 times -3 minus 4. It's going to be 23. Now f of 1, substitute 1 for s over here, -9, right? Now f of -4 is going to be 16, right? And the last one, f of 2, is going to be -2, right? Now the absolute maximum values of the function f on the closed interval is 23 right here, right? So the answer must be D. Now let's move on to question 1. If the function ls is given by this one, then we need to find f prime of 0, right? So we're going to use the chain rule, right? So we have u to the n prime is going to be n times u to the n minus 1 times u prime, right? U in this situation is going to be s squared minus 2s minus 1, right? So we have f prime of s first equals 2 over 3 times s squared minus 2s minus 1 raised to the 2 over 3 minus 1 is going to be -1 over 3, right? Times u prime, which means 2s minus 2, right? So we substitute 0 for s, so it will be f prime of 0 equal 2 over 3 times -1 raised to the -1/3, right? Times 0 minus 2, it will be -2, right? Now, -1 raised to the -1/3, you can rewrite this one as 1 over -1 raised to the power 1/3, right? And it's going to be 1 over cube root of -1, and it's going to be -1, right? So, -1 times -2, it could be 2, right? 2 times 2 over 3, it could be 4 over 3, right? So, the answer must be A. Now, question 2. If ls equals 2s plus 1 raised to the 4, then the fourth derivative of ls s equals 0 is. Alright, so we have the first derivative is 4 times 2s plus 1 raised to the 3rd, right? And then times 2, right? So it could be 8 times 2s plus 1 raised to the third. Now f double prime of s equals 3 times 8, it could be 24, right? Times derivative of 2s plus 1, it could be 2, right? Times 2s plus 1, 3 subtract 1, it could be 2. So it could be 48 times 2s plus 1 square, right? Now f triple prime of s is bring 2 to the front, it could be 96. And then derivative of 2s plus 1, it could be 2, right? Times 2s plus 1 power of 1, right? So it could be 96 times 2, it could be 192, right? Times 2s plus 1. Now, the fourth derivative of this one is going to be 192 times 2, right? So it could be 384, right? So the answer must be E. Now for question 325, the table below shows some of the values of two differentiable functions, f and g and their derivatives. Question 3. If h of s equals ls times g of s plus ls over g of s, then find the value of h prime of phi, right? So we just take the derivative of this one using the product rule and quotient rule, right? So we have h prime of s equals f prime of s times g of s plus g prime of s times f of s plus f prime of s times g of s subtract g prime of s times f of s over g of s squared, right? So we substitute phi for s, right? So we have f prime of phi. F prime of phi is going to be 4, right? G of phi could be negative 2 times negative 2 plus g prime of phi is going to be 5 right here. F of phi is going to be 3 plus f prime of phi is going to be 4, right? G of phi is going to be negative 2 minus g prime of phi is going to be 5, and f of phi is going to be 3 over g of phi square is going to be negative 2 squared is going to be 4, right? Now we're going to simplify this one. It's actually phi over 4. The answer must be A. Now question 4. If h of s equals f of g of 2s, then find the value of h prime of 2, right? So we're going to use the chain rule, right? So h prime of s equals f prime of g of 2s times g prime of 2s times derivative of the one inside here, 2, right? So we substitute 2 for s, so it will be h prime of 2 equals f prime of g of 4 times g prime of 4 times 2, right? Now g of 4 is 3 and g prime of 4 is 9, right? So we have f prime of 3 times 9 times 2, right? Now f prime of 3 is negative 5, right? So we have negative 5 times 9 times 2, right? So it could be negative 90. The answer must be A. Now question 5. If h of s equals g of s squared, then find the value of h prime of 3. So we have h prime of s equals, we're going to use the power rule, right? So it could be 2g of s times g prime of s, right? So we have h prime of 3 is 2 times g of 3 times g prime of 3, right? Now we look at g of 3 and g prime of 3 is going to be right here. G of 3 is 6, g prime of 3 equals 2, right? So we have 2 times 6 times 2, right? So it's going to be 24, right? The answer must be C. Question 6. If y equal to cosine s over 2, we need to find the second derivative of this one, right? So we have the first derivative is going to be 2 times cosine u prime is going to be negative u prime sine u, right? It's going to be negative 2, right? Sine of s over 2 times derivative of s over 2, which means 1/2, right? So we need to simplify this one. It's going to be negative sine s over 2, right? Now the second derivative is going to be negative cosine s over 2 times derivative of this one is going to be 1/2, right? So it will be negative 1/2 cosine s over 2. The answer must be E. Now let's move on to question 7. The cost in dollars to shred the confidential documents of a company is multiplied by C, a differential function of the weight of documents in pounds. Of the following, which is the best interpretation of C prime of 500 equals 80? We look at this one, C prime of 500. It tells us that this one is the rate of change, right? So rate of change will be increasing or decreasing. So keep that in mind, right? Now answer choice 8. The cost to shred 500 pounds of documents is $80. Is not the case, right? Because this is C prime, this is not C, right? Now answer choice B. The average cost to shred documents is 80 divided by $500 per pound. No. Answer choice C. Increasing the weight of the documents by 500 pounds will increase the cost to shred the document by approximately $80. No. And the last one, the cost to shred documents is increasing at a rate $80 per pound when the weight of the document is 500 pounds. This one is the correct answer. Now, question 8. What is the slope of the tangent line to the curve at the point 3, 2? So remember, the slope of the tangent line is going to be dy over ds, right? So we're going to take the derivative both sides with respect to s, right? So we have sec y times dy over ds, right? Minus 4s equals derivative of this one equals 0, right? Now for this one, we need to use the product rule, right? So I have negative 2 outside parentheses. Derivative of s with respect to s, it could be 1, right? So I have y only. Derivative of y with respect to s could be dy over ds, right? So I have plus s dy over ds, right? Now I'm going to substitute values, right? So x equals 3, y equals 2, right? So I have 12 dy over ds minus 4 times 3 equals 12, right? Equals negative 2 times 2 plus 3 dy over ds, right? Now I need to solve for dy over ds, right? So right here I just distribute negative 4 minus 6 dy over ds, right? I add 6 dy over ds both sides, so 6 plus 12 it could be 18 dy over ds, right? Equals add 12 both sides, so it could be 8, right? So dy over ds equals 8 divided by 18, right? Divide the top and bottom by 2, so it will be 4 over 9. The answer must be B. Now question 9. The temperatures in degrees Fahrenheit of water in a pond is modeled by the function h given by h of t equals 55 minus 9 cosine 2 pi over 365 times t plus 10, where t is the number of days since January. So right here t equals 0, right? What is the instantaneous rate of change of the temperature of the water at the time t equals 90 days? Alright. Another name of the instantaneous rate of change is derivative. Now since this one allows you to use the calculator, right? So we just print up the calculator. Alright, add calculator. Now we need to take the derivative of this one, and then we need to evaluate at t equals 90 days, right? So we're going to hit menu, calculus, derivative at points right here. Alright, so the variable should be s, right? I change this one into s. Now the value right here should be 90 days, right? So I put 90 here, first derivative, press OK. Alright, so I'm going to input the function, so it could be enter. It's going to give you 0.15317, right? So your answer must be B. Now question 10. If sine of s times y equals s, then dy over ds is. Alright, so we need to take the derivative both sides with respect to s, right? So we have d over ds of sine sy, right? Equals d over ds of s, right? Now for this guy, we need to use the formula sine u prime. This could be u prime cosine u, right? Now u in this situation is s times y, right? So if you take u prime, you need to use the product rule, right? So it could be s prime times y plus y prime times s, right? This guy becomes derivative with respect to s of s times y, right? Times cosine of s times y, right? Equals derivative of this one equals 1, right? Now derivative of this one, we use the product rule right here, right? So it could be derivative of s equal 1, so it could be y only, right? Plus derivative of y is going to be dy over ds times s right here, right? Times cosine s y equals 1, right? Now we're going to distribute this one, so we have y times cosine s y, right? Plus s times cosine s y dy over ds equals 1, right? So dy over ds equals, subtract this guy both sides, right? So 1 minus y cosine s y, right? Divide by this guy right here, s cosine s y, right? So the answer must be D. Now question 11. If f and g are twice differentiable and if h of s equals f of g of s, then h double prime of s is. Alright, so we need to find the first derivative first, right? So it could be f prime of g of s times g prime of s, right? Now the second derivative, we're going to use the product rule, right? So it could be f prime of g of s, right? Derivative of this one equal this one, and then times g prime of s, the one inside right here, right? And then times this one right here, g prime of s, right? Plus derivative of this one could be g double prime of s times this one right here, f prime of g of s, right? So we're going to simplify it, so it should be h double prime of s equals f double prime of g of s times g prime of s all together squared, right? Plus g double prime of s times f prime of g of s. So the answer must be A. Now question 12. If f of s equals inverse tangent of s, then f prime of square root of 3 is, right? So we need to find f prime of s first. It's going to be 1 over 1 plus s squared, right? So then f prime of square root of 3 equals 1 over 1 plus square root of 3 square, right? So give 1 over 4, right? So the answer must be A. Now question 13. Let f of s be square root of e to the s plus 3. What is the approximation for f of 0.5? Found by using the line tangent to the graph of fs equals 0, right? So we need to use the point slope formula, right? Y minus y1 equals m times s minus s1, right? Now we have s1 is right here, right? Substitute 0 for s over here to find y1, right? So we have 0, comma, e to the 0 is going to be 1. 1 plus 3 equals 4. Square root of 4 equals 2, right? So this is s1, y1, right? And the slope, take the derivative of this one. So we have f prime of s equals, remember, you can apply this formula, square root of u prime equals u prime over 2 square root of u. Or you can convert this one to u power 1/2, and then you're going to use the power rule, right? So u in this expression is e to the s plus 3. Take the derivative of this one, it could be e to the s over 2 square root of e to the s plus 3, right? And then I need to calculate f prime of 0, right? So substitute 0 for s, it could be 1 over 2 square root of 4, right? So it could be 1 over 4, right? So I have y equals the slope 1 over 4, right here, times s minus s1, which is 0, plus add y1 both sides, it could be 2, right? So y, I just replace this one with f of s equals 1 over 4 s, right? Because s subtract 0 equals s plus 2, right? Now I use this one to calculate this guy over here, right? So f of 0.5 equals 1 over 4 times 0.5, which means 1/2, right? Plus 2. So it could be 1 over 8 plus 2, right? So it's going to be 17 over 8. This guy actually 2.125, right? So the answer must be C. Question 14. If Ls equals Ln of s plus 4 plus e to the negative 3s, we need to find f prime of 0. Alright, so we're going to apply the formula natural log of u prime equals u prime over u, right? U in this expression is right here, right? So we have f prime of s equals, the derivative of this one is going to be 1 minus 3 e to the negative 3s, right? Over s plus 4 plus e to the negative 3s, right? So we have f prime of 0 is going to be 1 minus 3 times 1, right? Over 4 plus 1, right? So it could be 1 minus 3 could be negative 2 over 5, right? The answer must be A. Now question 15. If Ls equals this guy, we need to find f prime of s, right? So we're going to use the product rule and power rule and chain rule, right? So we have product rule first, right? So the derivative of this one is actually 1 times s squared plus 2 power of 3, right? Plus the derivative of this one, bring 3 to the front, s squared plus 2 power of 3 minus 1, it could be 2, right? Times the one inside the parenthesis, so it could be 2s, right? And then times s minus 1, right? Now we're going to simplify this one, it's going to be s squared plus 2 cubed plus 3 times s squared plus 2 squared, right? Now 3 times 2s is going to be 6s times s minus 1, right? Now I look at the answer choice right here, I don't see s squared plus 2 cubed, right? So which means I need to factor this guy out, right? So I have s squared plus 2 all together power of 2, right? Times s squared plus 2 left right here, right? Plus this one gone, right? Because you factor out. So you have 6s times s, it could be 6s squared, right? 6s times negative 1, it could be negative 6s, right? Now we just simplify, so it could be s squared plus 2 squared, right? Times s squared plus 6s squared, it could be 7s squared, right? Minus 6s plus 2, right? So the answer must be D. Now let's move on to question 16. Let f be a differentiable function such that f of 3 equals 15, f of 6 equals 3, f prime of 3 equals negative 8, and f prime of 6 equals negative 2. The function g is differentiable and g of s equals inverse f of s. For all s, what is the value of g prime of 3? Now remember, if f and g are inverse of each other, then a point A, B on F becomes B, A on G, right? So keep that in mind. Now we need to calculate g prime of 3, so we take the derivative of this one. So it could be g prime of s equals 1 over f prime of f inverse of s, right? So g prime of a equals 1 over f prime of inverse of f of a, right? Now inverse f of a is actually b, right? Look, because f and g are inverse of each other, right? So it can be 1 over f prime of b, right? This one right here, f of 6 equals 3. So it tells us that the coordinate 6 and 3 is on the function f of s, right? And because g and f are inverse of each other, right? And then the point 3 sit on the function g, right? So we calculate g prime of 3 equals 1 over f prime of b, which means 6 right here, right? So it could be f prime of 6 equals negative 2 right here, right? So it could be negative 1/2. The answer must be A. Now question 17. The function h of s equals s cubed plus ks squared, where k is a constant. If the tangent line to the graph of hs were negative 2 is parallel to the line that contains the point 1, 3, and 4, 15, what is the value of k, right? So, you know that two lines parallel to each other, they have the same slope, right? So the tangent line to the graph right here, we need to find the slope using the first derivative, right? So h prime of s equals 3s squared plus 2ks, right? So this guy right here must be equals the slope of this guy, right? So the slope of this guy, we just use the rise over run, right? Now rise 15 subtract 3 over run 4 subtract 1. So it could be 12 over 3, it could be 4, right? So we have 3s squared plus 2ks equals 4, right? But s equals negative 2 right here. So we have 3 times negative 2 squared, it could be 12 plus 2 times k times negative 2 equals 4, right? So k equals 4 minus 12 divided by negative 4, right? Because 2 times negative 2 equals negative 4. So it's going to be negative 8 divided by negative 4 is going to be 2. The answer must be D. Now question 18. The local linear approximation to the function g at s were 1/2 is y equals 4s plus 1. What is the value of g of 1/2 plus g prime of 1/2? Alright, so we have g of 1/2 plus g prime of 1/2. We're going to use this one, substitute 1/2 for s over here. It's actually g of 1/2, right? So we have 4 times 1/2 plus 1, right? Plus g prime of 1/2, take the derivative of this one, right? So it could be 4, right? So g prime of 1/2 equals 4. So if we simplify this one, 4 divided by 2, it could be 2, 2 plus 1, it could be 3, plus 4, it could be 7, right? So the answer must be D. Now let's move on to question 19. An ice sculpture in the form of a sphere melts in such a way that it maintains its spherical shape. The volume of the sphere is decreasing at a constant rate of 2 pi cubic meters per hour. at what rate in square meters per hour in the surface area of the surface decreasing at the moment when the radius is 5 meters. This one is the related rate problem. You given, look at this one right here. The volume of the surface is decreasing at a constant rate of 2 pi cubic meters per hour, right? So this one actually the rate of change of the volume, right? So we have dv over dt equals decreasing, which means negative 2 pi cubic meters per hour, right? Now what else you given? You given the radius is 5 meters. You given the surface area is 4 pi r squared right here, right? And you given the volume is 4 over 3 pi r cubed, right? Now, what you need to find? You need to find the rate of the surface area, right? So we need to find ds over dt equals how much, right? Now we're going to set up the equation, right? So we're going to start from the volume right here, right? Alright, so we have equation v equals 4 over 3 pi r cubed, right? Why do we have to use this formula? Because you given this one right here, right? So we need to make use of this information, right? So we're going to take the both sides with respect to t, right? So we have dv over dt equals, bring 3 to the front, it's going to be 4 pi r squared, right? Times dr over dt, right? Don't forget to use the implicit differentiation, right? Now, dv over dt equals negative 2 pi, right? So I substitute negative 2 pi equals 4 pi times r squared, but r equals 5 right here, so it will be 25 times dr over dt. I need to solve for dr over dt equals negative 2 pi divided by 4 pi times 25, right? So it could be negative 1 over 50, right? Now we need to focus on this one right here. So we have ds over dt equals, we're going to use the formula right here, right? Take the derivative both sides with respect to t, right? So we have 8 pi times r times dr over dt, but dr over dt is negative 1 over 50, right? So I substitute, it's going to be 8 pi times 5 times negative 1 over 50, right? So it could be, this guy is second, so you have 10 right here, right? 8 divided by 2, it could be 4, right? So it could be negative 4 pi over 5, right? So the answer must be A right here. Now remember, negative side right here tells us that the rate is decreasing, right? So we look at the question right here. It says the surface area of the surface decreasing, right? So we don't need to put the negative side right here, right? Now question 20. The graph of the function f(s) equals e to the sine s minus 1 crosses the x-axis at one point on the interval 1 to 4. What is the instantaneous rate of change of the function f(s) at this point? Now first you need to find the intersection between the function f(s) and the x-axis, right? The x-axis, which means y equals 0, right? So we have e to the sine s minus 1 equals 0, right? Is the same thing as e to the sine s equals 1, right? It's going to be the same thing as sine s equals 0, right? And then s equals pi, right? Because pi equals 3.14 is inside this interval, right? You could have s equals 0, you could have s equals 2 pi, something like that. But this guy right here is outside the domain, right? So we don't use this one, right? Now, instantaneous rate of change is the same thing as the first derivative of s, right? So we're going to use the formula e to the u, right? So u prime e to the u is going to be cosine s e to the sine s, right? And then you have f prime of pi, right? It's going to be cosine pi times e to the sine pi, right? So cosine pi equals -1, right? Times e to the sine pi equals 0, e to the 0 equals 1, right? So the answer is -1, right? The answer must be B. Question 21. In the xy plane, the line x plus y equals k, where k is a constant, is tangent to the graph of y equals x squared plus 3x plus 1. What is the value of k, right? So we just get the graph, this one right here. Suppose it could be something like this. Convert this one to slope-intercept form, so the big y equals -x plus k, right? So this is y equals -x plus k, right? Now remember that the tangent points right here is the point that on the graph y equals -x plus k and the parabola right here, right? So the slope of the tangent line of this one should be the slope of this guy, right? So we need to take the derivative of y prime equals 2s plus 3, right? And this guy actually equals -1 right here, right? Equals -1. And you solve for s, so s equals -2, right? Substitute -2 for s back to the function right here to solve for y, right? So we have y equals -2 squared plus 3 times -2 plus 1, right? So it's going to be -1, right? So you have the order pair -2 and -1, right? So this point is also on the tangent line right here, right? So substitute this point into this equation right here to solve for k. So you have -1 equals negative of -2 plus k. So k equals -3, right? The answer must be A. Now let's move on to question 22. If the base B of a triangle is increasing at a rate of 3 inches per minute, while its height is decreasing at a rate of 3 inches per minute, which of the following must be true about the area of the triangle, right? So you know that the area of the triangle is given by the formula 1/2 times B times H, right? Now let's take the derivative both sides with respect to t, right? So we have dA over dt equals 1/2. I'm going to use the product rule, right? So I have b times dh over dt, right? Plus h times db over dt, right? Now, the base is increasing at the rate of 3 inches. So you have dB over dt equals plus 3, right? And the height is decreasing at the rate of 3 inches. So you have dh over dt equals -3, right? Substitute these two guys over here. So we have dA over dt equals 1/2 times b times dh over dt is going to be -3, right? Plus h times dB over dt is going to be 3, right? So we have dA over dt equals 1/2. Now we're going to factor 3 out. So we have 3 times h minus b, right? Now we look at the answer choice right here. A is always increasing. We don't know it, right? We need to know the values of h and b, right? So this one wrong. Similarly, we don't know b, right? Now a is decreasing only when b less than h. Now b less than h tells us that b minus h less than 0, right? So I'm going to multiply both sides by -1. So I have h minus b greater than 0. So if this one greater than 0, the whole thing greater than 0. Right? So A must be increasing, so C is wrong, right? Similarly, D right here, B greater than H, So I subtract h both sides, so I have b minus h greater than 0, right? And then, because I have h minus b right here, so I need to multiply both sides by -1. So it will be h minus b less than 0. So this guy less than 0 right here, less than 0. It tells us that dA over dt less than 0. So it will be decreasing. The answer must be D. Now let's move on to question 23. An equation of the line tangent to the graph LS at the point 1 minus 1 is. This is a very simple question, right? We need to take derivative of this one, so we have f prime of s equal, use the product rule, right? Derivative of s equal 1, so we have 1 minus 2s cubed plus derivative of this one could be 3 times 1 minus 2s squared times the one inside right here, -2, right? And then times s right here, right? We calculate f prime of 1, right? So it could be 1 minus 2 cubed plus 3 times 1 minus 2 squared, right? Times -2. So it could be -1, right? Plus 3 times -2. So it could be -7, right? Now, we use the point slope formula, right? So y minus y1 is -1 right here. So it should be plus 1 equals the slope right here, -7 times s minus s1 right here. So y equals -7, distribute this one, -7s, right? Plus 7 subtract 1, so it could be -7s plus 6. The answer must be A. Now question 24. If LS equals this guy, we need to find f prime of s, right? So we need to apply the formula sin u prime equal u prime cosine u, right? And ln of u prime is to be u prime over u, right? So f prime of s equals, this one is u, right? So it could be ln of 2s prime cosine of ln of 2s, right? And then I apply this formula right here. So it could be 2 over 2s times cosine of ln of 2s, right? So it could be 1 over s cosine of ln of 2s, right? So the answer must be B. Now let's move on to question 25. What is the maximum area of the rectangle that can be inscribed into the region bounded by the graph LS equals 9 minus s squared and the x-axis? Alright, so we just get the graph to see what happens. Now the area of the rectangle is A equals length times width, right? The length is distance from here to here, right? And the width is from here to here, right? So the length is going to be, this is s, this should be s, right? So we have 2s times the width. The width is right here, right? It could be 9 minus s squared, right? We distribute this one, it could be 18s minus 2s cubed, right? So when it comes to maximum or minimum, we need to take the first derivative, right? So we have a prime of s equals 18 minus 6s squared, right? We need to find the critical number, right? So we need to let this one equals 0, and then you have s equals plus and minus square root of 3, right? Remember, the domain of s should be between 0 and 3, right? So we need to use the candidate test, right? So we have a of 0 equals a of root 3 equals and a of 3 equals, right? A of 0, substitute 0 for s into the equation right here, right? So we had 0. A of root 3 is going to be 18 times root 3 minus 2 times root 3 cubed, right? So this one turns out to be 12 root 3, right? A of 3 is going to be 18 times 3 minus 2 times 3 cubed, right? So it could be 54 minus 54, right? It's going to be 0, right? So the maximum is right here, 12 root 3. The answer must be D, right? You can use the second derivative test, right? You can have a double prime of root 3 right here less than 0. So the function has the maximum value, right? Now let's move on to question 26. Let f(s) be a choice differentiable function such that f of 3 equals 1, dy over dx equals y squared plus y. What is the value of this guy, right? So we need to take the second derivative of this one, right? So we have d squared y over ds squared equals 2y dy over ds plus dy over ds, right? Now we need to calculate dy over ds first, right? So we have dy over ds at y equals 1 right here, right? So it could be 1 plus 1, it could be 2, right? So we substitute over here, so it could be 2 times y equals 1. dy over ds is 2 plus 2, right? So it could be 6, the answer must be B. Now let's move on to question 1. If f is continuous for s greater than or equal to a less than or equal to b, and differentiable for s greater than a less than b, which of the following could be false? Answer choice A. F prime of c equals f of b minus f of a over b minus a for some c between a and b. This is true by the mean value theorem, right? Now, answer choice B, f prime of c equals 0 for some c such that c between a and b. This is false, right? Because f of a equals f of b is not given, right? Look, f prime of c equals 0 if f of b equals f of a, right? Since this one is not given, making this one false, right? Now, answer choice C. F has a minimum value on the closed interval a and b. This is true by EVT, right? Now, answer choice D. F has a maximum value on the closed interval a and b. This is true by EVT, right? Now, answer choice D. Interval from a to b of LS ds exists. This is true by definition of intervals, right? So, answer must be B. Now let's move on to question 2. The function f is defined on the closed interval 2, 4. If f of 2 equals f of 3 equals f of 4 on the open interval 2 to 4, and the function f is continuous and strictly decreasing. So we're going to sketch the graph to see what happens. So if this one happens, f of 2 could be right here. F of 3 could be right here, and f of 4 could be right here. So this guy right here should be horizontal, right? And the function becomes discontinuous. And then the extreme value theorem does not apply because the function is discontinuous, right? So the function does not have the maximum nor minimum value, right? So the answer must be A. Now question 3. Let f be a function with first derivative defined by this guy for s greater than 0. It's known that f of 1 equals 7, f of 5 equals 11. What value of s in the open interval 1 to 5 satisfy the conclusion of the mean value theorem for f on the closed interval 1 to 5? Alright, so we're going to use the mean value theorem, right? So we have f prime of c equals f of b minus f of a over b minus a, right? Now f prime of c is right here, right? So I just replace s with c, right? So I have 2c squared minus 5 over c squared equals f of b is right here, 11. F of a is 7, right? So 11 minus 7 over 5 minus 1, right? So I'm going to simplify this one. It's going to be 4 over 4, right? It's going to be 1, right? So I'm going to multiply both sides by c squared, right? So I have 2c squared minus 5 equals c squared, right? Subtract c squared both sides, so I have c squared, and then add 5 both sides, so it could be 5, right? Take square root both sides, so it could be c equals plus and minus square root of 5, right? But the domain is 1 to 5, right? So only c equals square root of 5 works, right? So the answer must be D. Now let's move on to question 4. The function f is continuous on a closed interval 0 to 2 and has values that's given in the table above. The equation fs equals 1 over 2 must have at least 2 solutions in the interval 0 to 2 if k equals how much, right? So basically, we're going to apply the IVT, right? Now this is the function fs, right? So we have the interval 0 to 2, right? We split this one into 2 intervals, right? The first one right here and the second one right here. So we need to find at least one solution in this interval, right? And another solution in this interval, so that we're going to have at least 2 solutions, right? So look at the value of 1/2 right here, right? So by the IVT, 1/2 must be between 1 and k right here, right? So then k in this situation must be less than 1/2 for the first one, right? Now second one, 1/2 right here must be between k and 2 right here, right? So again, k right here must be less than 1/2 for second time, right? So both times k must be less than 1/2, right? We look at the answer choice right here. A must be the correct answer, right? Now for answer choice B, we only have one solution right here, s equals 1, right? Because k equals 1/2. For answer choice C, D, and E, we have no solution because with this value, the function would stay above the line y equals 1/2, right? Now let's move on to question 5. Let g be the continuous function on the closed interval 0, 1, and let g of 0 equals 1, g of 1 equals 0. Which of the following is not necessarily true? Answer choice A. There exists a number h in the closed interval 0, 1, such that g of h greater than or equal to g of s for all s in the closed interval 0, 1. This one true by the extreme value theorem, right? This guy actually absolute maximum, right? Now answer choice B, for all a and b in the closed interval 0, 1. If a equals b, then g of a equals g of b. This is obvious, right? Now answer choice C. There exists a number h in the closed interval 0, 1 such that g of s equals 1/2. Look at 1/2 right here is between the output value right here, 0 and 1, right? So this is true by the IVT, right? Now answer choice D, there exists a number h in the closed interval 0, 1 such that g of s equals 3/2, right? So 3/2 is outside this guy right here, right? So this one is not necessarily true, right? You can consider the function g of s equals 1 minus s on the closed interval 0 and 1, and you will see that it's completely false, right? Now answer choice E, for all s in the open interval 0, 1, limit of the function g of s when s approaches h equals g of s. Yes, this is correct because the function is continuous, right? Now question 6, if f of s equals sine of s over 2, then there exists a number c in the interval pi over 2 to 3 pi over 2 that satisfies the conclusion of the mean value theorem. Which of the following could be the value of c? Alright, so remember we have the mean value theorem is given by the formula f prime of s equals f of b minus f of a over b minus a, right? Now we're gonna replace s with c, so we have f prime of c equals f of b is right here, a is right here, right? So you have f of 3 pi over 2 minus f of pi over 2 over 3 pi over 2 minus pi over 2, right? Now f of c, which means we're going to take the derivative of this one and we replace s with c, right? So we have f prime of s equals, we're going to use the formula sine u prime. It's going to be u prime cosine u, right? So u is going to be s over 2, right? So it's going to be 1 over 2, right? Cosine s over 2, right? So it turns out to be 1 over 2 cosine c over 2, right? Equals f of 3 pi over 2, substitute 3 pi over 2 over here, right? So we have f of 3 pi over 2 equals sine of 3 pi over 2 divided by 2, it could be 3 pi over 4, right? And it's going to be root 2 over 2, right? So I have root 2 over 2 here. Subtract f of pi over 2 equals sine of pi over 4. It's going to be root 2 over 2, right? So I have root 2 over 2 right here. Over 3 pi over 2, subtract pi over 2, it could be 2 pi over 2, and it could be pi, right? So it could be 0, right? So it's going to be cosine of c over 2 equals 0, right? So c over 2 equals pi over 2. And c equals pi, right? So the answer is D. Now let's move on to question 7. Which of the following theorems may be applied to the graph below? So this one is the graph of the absolute value function. Now, remember you have the sharp turn right here, which means the function is not differentiable at this point, right? So if the function is not differentiable at this point, the mean value theorem does not apply, right? The mean value theorem requires the function to be differentiable, right? So this one is not true, right? Intermediate value theorem could be right. Extreme value could be right. Because these two theorems right here require the function to be continuous only, right? So the answer should be 2 and 3, which is D. Now let's move on to question 8. The function f is defined by f equals 4s squared minus 5s plus 1. The application of the mean value theorem to the function f on the interval 0 to 2 guarantees the existence of the value of c, where c between 0 and 2 such that f prime of c equals, alright, so we have the formula f prime of c equals f of b minus f of a over b minus a, right? Now f of b is going to be right here, f of 2, right? Subtract f of 0 over 2 minus 0, right? Now f of 2 substitute over here, we have 7. F of 0 substitute over here, we have 1 over 2, and it's going to be 3. The answer must be B. Now question 9. A function f is continuous on the closed interval 2 to 5. F of 2 equals 17, f of 5 equals 17. Which of the following additional condition guarantees that the existing number c is in the open interval 2 and 5 such that f prime of c equals 0? This guy is actually the Rolle's theorem, right? Remember, the Rolle's theorem is the special case of the mean value theorem, right? So, in order to apply the mean value theorem, you need the function to be differentiable, right? Now, the question just gives you continuous, that's not enough, right? So the answer must be C, right? The function must be differentiable. Now let's move on to question 10. The table above gives values of a differentiable function f and its derivatives as selected values of s. If h is the function given by h of s equals f of 2s, which of the following statement must be true? Alright, so before we're gonna do this one, let's calculate the function h of s first, right? So we have s equals 0, 2, 4, and 8 right here, right? So we have h of 0 is actually f of 0, right? Because 2 times 0 equals 0. Now f of 0 equals 3, right? Now h of 2 equals f of 4, right? And this is going to be 9 right here. Now h of 4 equals f of 8, right? It could be 13 right here. We need to take derivative of this guy, right? So we have h prime of s. We're going to use the chain rule, right? So it could be 2 times f prime of 2s, right? So h prime of 0 equals 2 times f prime of 0 times 2, it could be 0, right? So f prime of 0 is 0 right here, so the answer is 0, right? Now h prime of 2 equals 2 times f prime of 4, right? F prime of 4 equals 1 right here, so the answer is 2, right? Now h prime of 4 equals 2 times f prime of 4 times 2, it could be 8, right? So f prime of 8 equals 2 right here, right? So it could be 4. Number 1. The function h is increasing on the interval 2 to 4. Alright, so in order for the function to be increasing on this interval 2 to 4, we need h prime of s should be greater than 0 for all s in this interval, right? Now, since we don't have information about the behavior of the function f prime of s between 4 to 8, right? Right here. Function h from 2 to 4. The function f must be from 4 to 8, right? If we look at the table of values right here, it's likely increasing. But because it's not guaranteed by the data provided, we cannot say it must be true, right? So number 1 could be true, could be false, right? So we need to eliminate this one. Now number 2, there exists the value of c where c between 0 and 4 such that h of c equals 12. This is true by IVT. Why? We look at this guy right here. Alright, there's number c between 0 and 4. So look at the input right here, 0 and 4, right? The output is 12. Yes, 12 between 3 and 13, right? There is it number c where c between 0 and 2 such that h prime of c equals 3. So we need to calculate h prime of c. It's gonna be equals h of 2 subtract h of 0, right? The interval right here, over 2 subtract 0 by the mean value theorem, right? Now h of 2 we get 9 right here. H of 0 we get 3 right here. Divide by 2, right? 9 subtract 3, it could be 6. 6 divided by 2, it could be 3. Exactly this value right here, right? So 2 and 3 correct, right? So the answer must be C. Now let's move on to question 11. The function f is continuous for s between -2 and 1 and differentiable for -2 to 1. If f of -2 equals -5, f of 1 equals 4, which of the following statement could be false? So we see that c between -2 and 1, which is between the input right here, and then the output 0 right here between -5 and 4, right? So this is true by IVT, right? Now B, there is a number c between -2 and 1 such that f prime of c equals 0. This one is the Ross theorem, right? Ross theorem is the special case of the mean value theorem, where f of b equals f of a, right? Now we look at this one, f of 1 and f of -2 right here, they are not the same. Look, -5 and 4, right? So B is wrong. Now C, there is number C where C between -2 and 1 such that f of C equals 3. This is true by IVT, right? because c between -2 and 1, right? And then f of c is between -5 and 4, right? So this one choose by IVT. Now D. There is a number c between -2 and 1 such that f prime of c equals 3. This is true by the MVT, right? Look, we have f prime of c equals f of b, which means f of 1, subtract f of -2, right? Divide by 1, subtract -2, right? So it's going to be f of 1 equals 4 right here. Subtract f of -2 equals -5, right? So it could be subtract -5 over 3. It's going to be 9 divided by 3. It's going to be 3. Exactly this value right here, right? So this one true. Now E. There is a number c between -2 and 1 such that f of c greater than or equal to f of s for all s on the closed interval -2 to 1. This is obviously true by the EVT, right? Extreme value theorem. So the answer must be B. Now let's move on to question 12. The table above shows selected values of a continuous function g for s between 0 and 11. What is the fewest possible number of times g of s equals 2? Now in order to do this problem, we're going to use the IVT, right? So we look at the first interval right here, right? Now there exists number c between the interval 0 and 2 such that g of c equals 2, right? 2 is between 1 and 2.8, right? So this is the first. Now second interval from 2 to 5, right? There is a number c in this interval such that g of c equals 2. 2 is between 2.8 and 1.7, right? So this one is the second value, right? Now the third one is going to be 9 to 11 right here. There is number c in this interval such that g of c equals 2. 2 is between 1 and 3.4, right? So g of s equals 2 at least 3 times, right? The answer must be C. Now let's move on to question 1. The graph of a piecewise linear function f of s for s between -3 and 2 is shown above. What is the value of the interval from -2 to 2 of f of s plus 2 ds? Alright, so this guy is the same thing as the interval from -2 to 2 of f of s ds, right? Plus the interval from -2 to 2 of 2 ds, right? Now the interval from -2 to 2 of f of s ds, -2 is right here, and 2 is right here, right? So observe that this guy and this guy cancel out, right? So you only have this one right here. This one actually the trapezoid, right? The base is 1, the base right here is 2, and the height is 2 right here, right? So it could be 1 plus 2 times the height is going to be 2, right? Divided by 2, right? Plus antiderivative of 2 is going to be 2s evaluated from -2 to 2, right? So this guy becomes 3 plus 2 times 2 minus -2, right? So it could be 3 plus 2 times 4, right? So it could be 11. The answer must be C. Now question 2. Let f of s be a continuous function using the substitution u equals 3s plus 1. The interval from 1 to 4 of f of 3s plus 1 ds is equal to which of the following? Alright, so we're going to take the derivative both sides. It's going to be du equals 3 ds, right? And then ds equals 1/3 du, right? Now we need to change the upper bound and lower bound, right? So the original one is going to be s equals 1 and s equals 4, right? And then u becomes, substitute 1 over here, I have 4, right? Substitute 4 over here, I have 13, right? So the new integral becomes integral from 4 to 13 f of u, right? Now ds equals 1/3 du, right? So I put du right here and I put 1/3 in the front, right? So the answer must be D. Now question 3. The antiderivative of 1 over s squared ds is the antiderivative of s to the negative 2 ds, right? So we can use the power rule, right? So it could be s power of negative 2 plus 1 over negative 2 plus 1 plus c, right? So it could be s power of negative 1 over negative 1 plus c, right? So it could be negative 1 over s plus c. Or you can write this one as negative s power of negative 1 plus c, right? Either this form or this form works, right? So the answer must be C. Now question 4. Which of the following integral expression is equal to this limit? Alright, so we're going to review a little bit about the limit definition of error, which you learn in unit 6. It's going to be right here. Alright, so the integral from a to b of ls ds equals limit of this guy where ci is a plus I delta s. Delta s equals b minus a over n, right? A and b right here, right? So we're going to go back over here. So we have the function right here. So we can say that the function ls equals 1 plus 2s squared, right? And the interval is going to be 0 to 1, which is a and b, right? So then you can calculate delta s, right? It's going to be b minus a over n. It's going to be 1 over n, right? And then you need to find ck. It's going to be a plus delta s times k, right? Now a equals 0 right here, plus delta s is going to be 1 over n times k, right? So it could be k over n. Now you need to find f of ck, right? So you substitute this guy right here for s into original function right here, right? So we have 1 plus 2 times k over n all together squared, right? So it could be 1 plus 2 k over n all together squared, right? And then f of ck times delta s is going to be this guy right here, 1 plus 2 k over n all together squared times delta s is going to be 1 over n right here. Alright, this guy right here actually, the one inside parentheses right here, and it's exactly the same thing, this one right here. They match, right? So the answer must be A. Now let's move on to question 5. Given the p square function ls, we need to calculate the integral of this one, right? So we have integral from negative 1 to 4 of f of s ds, right? We need to split this interval into two intervals where the midpoint is 2 right here, right? So we have integral from negative 1 to 2 of f of s ds plus integral from 2 to 4 of f of s ds, right? And then integral from negative 1 to 2, which is less than 2, we pick this one, right? So it could be integral from negative 1 to 2 of s ds, right? Plus integral from 2 to 4 greater than 2, we're going to pick this one, right? So 3 ds, right? So it could be s squared over 2 evaluated from negative 1 to 2 plus 3s evaluated from 2 to 4, right? So it's going to be 4 over 2 minus 1 over 2, right? Plus 3 times 4 minus 2, right? So it could be 3 over 2 plus 6, right? So it could be 15 over 2, right? So the answer must be B. Now, number 6, we need to calculate the integral of this one, right? Now, observe that the degree on the numerator is greater than the degree on the denominator. So we need to do long division, right? So we have s squared plus 4s plus 5 divided by s plus 3, right? Now, s squared divided by s could be s multiplied by s could be s squared plus 3s, right? So you do subtraction. It could be s plus 5, right? S divided by s could be 1. So it could be s plus 3. Subtract, you get 2 right here, right? So this one can be written as the integral from 0 to 3 of the quotient right here, s plus 1, right? Plus the remainder right here, right? Divided by the divisor right here, s plus 3 ds, right? So we can split this one. This could be integral from 0 to 3 of s plus 1 ds plus the integral from 0 to 3 of 2 over s plus 3 ds, right? So it's going to be s squared over 2, right? Plus s evaluated from 0 to 3, right? Now for this one right here, look, this is s plus 3. If I take the derivative of s plus 3, it's ds, right? So this one can be written as the integral from 0 to 3 of 2 over s plus 3 d of s plus 3, right? Because d of s plus 3 is the same thing as d of s, right? Now 2 over here I can bring to the front, right? So I put 1 right here. So this guy turns out to be, substitute 3 for s, it could be 9 over 2 plus 3, right? Substitute 0 for s, it could be 0, right? Now plus 2 ln absolute value of s plus 3, right? Evaluated from 0 to 3. So it could be 9 over 2 plus 3, it could be 15 over 2 plus 2 times. Substitute 3 for s, it could be ln 6, right? Substitute 0 for s, it could be minus ln 3, right? So it's going to be 15 over 2 plus 2 times ln of 6 divided by 3, right? So it's going to be 15 over 2 plus 2 ln of 2, right? So the answer must be C. We need to find the antiderivative of 1 over s squared plus s plus 13 ds, right? So we need to do complete square, right? So I have s squared plus 6s plus 13. Now, in order to do complete square, I need to take the middle term right here, 6 divided by 2 and square, right? 6 divided by 2 is going to be 3. 3 squared equals 9, right? So I have plus 9 right here. If you have 9, you need to subtract 9, right? So the first 3 terms right here becomes the complete square. It will be s plus 3 altogether square, right? Plus 13 subtract 9, it could be 4, right? So I will write this one as the antiderivative of 1 over s plus 3 altogether square plus 4 ds, right? Now again, ds I can replace with d of s plus 3, right? So I have the antiderivative of s plus 3 square plus 4, right? So this guy and this guy the same thing. I can apply the formula antiderivative 1 over u square plus a square d u, right? So it could be 1 over a arctangent of u over a plus c, right? Now u in this situation is s plus 3, right? So it's going to be 1 over 4 can be written as 2 squared, right? So a should be 2 arctangent of u is going to be s plus 3 over a, which means 2, right? 4 right here can be written as 2 square, right? Plus c. So the answer is A. Now let's move on to question 8. At time t, a population of bacteria grows at a rate of 5 times e to the 0.2 t plus 40 grams per day, where t is measured in days. By how many grams has the population grown from time t equals 0 to t equals 10? Alright, so basically we need to take the interval from 0 to 10 of 5 e to the 0.2 t plus 4t dt, right? And remember, we have the antiderivative of e to the as plus b ds is going to be 1 over a e to the as plus b plus c, right? I need to split this one into two intervals, right? So interval from 0 to 10. I put 5 in the front, right? So e to the 0.2 t dt, right? Plus 4 interval from 0 to 10 t dt, right? So antiderivative of this one, a in this direction is 0.2, right? So it will be 1 over a, which means 1 over 0.2, right? So it turns out to be 5 over 0.2, right? E to the 0.2 t evaluated from 0 to 10, right? Plus 4 times t squared over 2 evaluated from 0 to 10, right? So this guy turns out to be 5 over 0.2 times e raised to the 0.2 times 10 is going to be 2, right? Subtract 0.2 times 0 is going to be 1, right? Because e to the 0 equals 1, right? Plus 4 over 2 times t squared, which means 10 squared, subtract 0 squared, right? 25 e squared minus 25, right? 4 divided by 2 is going to be 2. 2 times 100 is going to be 200, right? So the final answer is 25 e squared plus 175, right? So the answer must be C. Now let's move on to question 9. This one similar to question 4, right? Now you have the interval a to b right here, so we have delta s equals b minus a divided by n. It's going to be 7 minus 3 divided by n is going to be 4 over n, right? And the function f of s is s cubed, right? Now you need to find c k. It's going to be a plus delta s times k, right? A equals 3 plus 4 over n for delta s, right? Times k. So it could be 3 plus 4k over n, right? So we need to calculate f of ck. It's going to be f of s equals this one, right? So it could be 3 plus 4k over n raised to the third, right? Now we look at the answer choice right here. We need to eliminate a, right? Because this is k over n. We need 4k over n, right? This guy wrong. This guy wrong because delta s is 1 over n. We need delta s is 4 over n, right? The answer must be D. Now question 11. We need to calculate this interval, right? So we need to use the u substitution, right? So let u equals square root of s, right? So we have u squared equals s, right? Take the derivative both sides with respect to s, so we have 2u du equals ds, right? So we need to change the new upper bound and lower bound, right? So we have s equals 1, s equals 9. Then u equals, substitute 1 for s is going to be 1. Substitute 9 for s is going to be 3, right? So then this integral right here becomes the integral form 1, 2, 3 sine of u over u. Now ds equals 2u du, right? So 2u du, right? This guy cancel out. So it could be the integral from 1, 2, 3 of sine u du. And don't forget 2 right here, right? So I'm going to put 2 in the front, right? So the answer must be C. Question 12. The right triangle shown in the figure represents the boundary of a town that is bordered by a highway. The population density of the town at the distance of S miles from the highway is modeled by this function, where d of S is measured in thousands of people per square mile. According to the model, which of the following expression gives the total population in thousands of the town? Now you know that the total population is given by the integral from A to B of the length times density ds, right? Now the length, which means this guy right here, right? We need to find the equation of this guy. So think about this one is the xy coordinate, right? So we have the y-intercept right here is 4, right? And the slope is going to be rise over run, right? The slope actually -1, right? Rise over run is going to be -4 over 4, right? Go down by 4, go to the right by 4. So it could be -1, right? So the equation should be y equals -s plus 4, right? So this guy actually the length. And then we need to take the integral from 0 to 4 right here, right? So it could be integral from 0 to 4. The length is going to be -s plus 4 times density is going to be square root of s plus 1 ds, right? So the answer must be D. Now let's move on to question 13. Given the piecewise function fs, we need to calculate this one, alright? So we need to remove the absolute value first, right? So we rewrite this one as f of s equals. Remember, if you have absolute value of s, it turns out to be as if the one inside the absolute value side right here greater than or equal to 0, and negative s if the one right here less than 0, right? So I'm going to remove this one. It's going to be s minus 1 over s minus 1. If you remove the absolute value side without changing anything, the one inside the absolute value must be greater than 0, right? So if s minus 1, the one inside right here, greater than or equal to 0. And then the second one, if I change this one to negative, which means negative s minus 1 over s minus 1. And then the one inside right here must be less than 0, s minus 1 less than 0, right? So I just simplify this one, so it will be this guy cancel out. 1 if right here s greater than or equal to 1. And then this one turns out to be -1 if s less than 1. So the integral from -1 to 4 of fs ds can be written as the integral from -1 to 1, right? Of f of s ds plus the integral from 1 to 4 of f of s ds, right? We're going to use the middle terms right here. Now the integral from -1 to 1, which is less than 1, right? We're going to fix this one right here. So it will be the integral from -1 to 1 of negative ds, right? Plus the integral from 1 to 4, which is greater than 1, right? We're going to fix this one right here. So it will be ds, right? So it will be negative s evaluated from -1 to 1 plus s evaluated from 1 to 4, right? So it could be negative parenthesis 1 minus negative 1, right? Plus 4 minus 1, right? So it could be 3 minus 2, it could be 1, right? So the answer must be A. Now question 14, the degree on the numerator is greater than degree on the denominator. We need to do long division, right? So we have s squared plus 6s plus 6 divided by s plus 1, right? So s squared divided by s could be s times this one is going to be s squared plus s, right? Subtract, it could be 5s, bring it down. 5s divided by s could be 5, right? Multiply back, it could be 5s plus 5. The remainder is 1, right? So this one can be written as the integral from 1 to 2 of the quotient is right here. S plus 5 plus the remainder is right here. Divide by divisor, it could be s plus 1 ds, right? Now we're going to take entire derivative of this one, it could be s squared over 2, right? Entire derivative of 5 could be 5s, right? Entire derivative of this one could be ln absolute value of s plus 1, right? Altogether evaluated from 1 to 2, right? So substitute 2 by s, it could be 2 squared equal 4. 4 divided by 2, it could be 2 plus 2 times 5 could be 10. 10 plus 2, it could be 12, right? Plus ln of 3, right? Subtract. Substitute 1 by s, it could be 1 half, right? Plus 5 plus ln 2, right? Now we're going to simplify 1 half plus 5, it could be 11 over 2. So 12 subtract 11 over 2, it's going to be 13 over 2, right? ln 3 subtract ln 2, it could be plus ln 3 half, right? So 13 over 2, it could be 6.5 plus ln 3 over 2, right? The answer must be C. Now let's move on to question 15. We're going to use U substitution, right? So let U be the bottom. S squared minus 4. Then du equals 2s ds, right? Now we only have s ds, right? So we have s ds equals 1 half du, right? So we substitute back over here, we have entire derivative of 1 half, and we'll bring to the front, right? We have du over u, right? So it could be 1 half ln absolute value of u plus c, right? Substitute u back, so it could be 1 over 2 ln absolute value of s squared minus 4 plus c, right? So the answer must be C. Now, question 16, we're going to do long division. Or we can split this one, so it could be integral from 1 to e s squared over s, right? Subtract integral from 1 to e 1 over s ds. Now we just simplify, so it could be integral from 1 to e s ds minus integral from 1 to e 1 over s ds, right? Now entire derivative of this one could be s squared over 2 evaluated from 1 to e minus this one ln of absolute value of s evaluated from 1 to e, right? So it could be e squared over 2 minus 1 half, right? Subtract ln of absolute value of e, subtract ln absolute value of 1, right? So we're going to simplify, it could be e squared minus 1 over 2. Subtract ln of e equals 1, right? 1 subtract 0, it could be 1, so it could be minus 1. Now we're going to simplify, so it could be e squared minus 1 subtract 2 over 2. So it could be e squared minus 3 over 2. Or e squared over 2 minus 3 over 2. The answer must be E. Now question 17, we're going to use U substitution, right? So let U be a tangent of S, and then du equals 1 over 1 plus S squared ds, right? So substitute over here. Now we need to change the upper bound and lower bound, right? So we have s equals 0 and s equals 1. Then u becomes, substitute 0 for s, tangent of 0 equals 0, right? Tangent of 1 equals pi over 4, right? So then this guy right here becomes the integral from 0 to pi over 4, right? U du, right? So it could be u squared over 2 evaluated from 0 to pi over 4, right? So it could be pi over 4 altogether squared over 2, right? So it could be pi squared over 32, right? So the answer must be B. Question 18. A rain barrel collects water off the roof of a house during 3 hours of heavy rainfall. The height of the water in the barrel increases at the rate of R of t is equal to 4t cubed times e to the negative 1.5t feet per hour, where t is the time in hour since the rain began. At time t equals 1 hour, the height of the water is 0.75 foot, so this one is the initial amount. What is the height of the water in the barrel at time t equals 2 hours, right? We need to find the final amount. Alright, so we just use the fundamental theorem of calculus, right? So it could be, alright, so we substitute initial amount is 0.75 plus integral from 1 to 2. The rate is right here. 4t cubed e to the negative 1.5 t dt, right? So we just bring up the calculator. Add calculator and then hit 0.75, right? Plus hit the button right here, the integral right here. From 1 to 2 of 4t cubed times e to the negative 1.5 t dt, and then press Ctrl Enter. It's going to be 2.111, right? So the answer must be D. Now let's move on to question 19. The function g is continuous on the closed interval 2 to 10. If the integral from 2 to 10 of g of s ds equals 63 and integral from 10 to 5 of 1 over 2 g of s ds equals negative 16, then we need to calculate the integral from 2 to 5 of 2 times g of s ds. So normally we're going to start from the larger bounds, right? So lower bound is 2, upper bound is 10, right? From 2 to 10 right here. So we have the integral from 2 to 10 of g of s ds equals, we put 5 in the middle, right? So integral from 2 to 5 of g of s ds plus the integral from 5 to 10 of g of s ds, right? Now, this is what we need to find, right? So we have the integral from 2 to 5 of g of s ds equals the integral from 2 to 10 of g of s ds subtract the integral from 5 to 10 of g of s ds, right? Now, this guy right here equals 63, right? Subtract. Now, we need to calculate this guy, right? So we're going to use this guy right here, right? So we just flip the upper bound and lower bound, and we change the sign right here. It turns out to be 16, right? So we have the integral from 5 to 10 of g of s ds. I put 1/2 in the front, right? 16, right? Now I'm going to multiply both sides by 2. So integral from 5 to 10 of g of s ds equals 32, right? So this guy equals 32. So 63 subtract 32 is going to be 31, right? Now, I go back over here, I need 2 times g of s, right? So, the integral form 2 to 5 of g of s ds equals 31, right? Now, I have 2 right here, so I need to multiply both sides by 2, right? So, it's going to be 62, right? The answer must be B. Now, question 20. A pizza heated to a temperature of 350 degrees Fahrenheit is taken out of an oven and placed in a 75 degree Fahrenheit room at time t equals 0 minutes. The temperature of the pizza is changing at a rate of negative 110 e to the negative 0.4 t degrees Fahrenheit per minute. Which of the following is the best interpretation of the integral from 0 to 30 of negative 110 e to the negative 0.4 t, right? The temperature of the pizza is changing at a rate, right? So remember, you have the fundamental theorem of calculus. The integral from a to b of the rate f prime of s ds is going to be f of b minus f of a. So the answer must be D. Now question 21. What is the average value of this function on the closed interval negative 1, 2, 3, right? So you have the average value is given by the formula. Now this is A and this is B. So it will be 1 over 3 minus negative 1, right? Integral form negative 1, 2, 3, f of s right here. It's going to be cosine s over s squared plus s plus 2 ds, right? Now this one is the calculator active problem, so we just bring up the calculator. Alright, 1 over 3 minus negative 1 is going to be 1 over 4, right? So we just hit the, put it right here, put the fraction right here, 1 over 4, right? Times. Now hit the, put it right here, pick the integral right here. From negative 1, 2, 3. Put the fraction. Should be cosine s over s squared plus s plus 2. And then put the s right here. Press Control Enter. It's going to be 0.1829, right? So it could be this one right here because we're going to round it up, right? Now let's move on to question 22. On the closed interval 2 to 4, which of the following could be the graph of the function f with the property that 1 over 4 minus 2 integral from 2 to 4 f of t dt equals 1, right? So this one actually the average value of the function, right? So we need to find the function f of t, right? So we're going to simplify this one. It's going to be 1 over 2 integral from 2 to 4 f of t dt, right? Equals 1. So then the integral from 2 to 4 f of t dt equals multiply both sides by 2. It could be 2, right? So technically you need to find the function where the error under the curve equals 2, right? Now we're going to check the answer. Normally you're going to check the answer C, D, and E first, right? So I'm going to check the answer choice C first, right? So I need to calculate the error of this guy over here. Right? They're both the same, right? I just calculate the error of 1 and multiply by 2, right? So I have the height right here is to the base 1, right? So 1 times 2 divided by 2, right? It's going to be 1, right? And I have this one, so I multiply by 2. It's going to be 2. It's exactly this one, right? The answer must be C. For this one, you just try it like this. Alright, it becomes a trapezoid. This guy right here becomes the rectangle. Now let's move on to question 23. If f is a continuous function, and if f prime of s equals f of s for all real number s, then the integral from 1 to 3 of f of 2s ds equals. Alright, so we just take antiderivative of this one. Remember, antiderivative of f of s equals f of s, right? So this guy becomes, now we're going to use the u substitution, right? So we let u equals 2s, then du equals to ds, right? So then ds equals 1/2 du, right? So this guy becomes the integral form 1, 2, 3, right? Of 1/2, right? F of u du, right? So it becomes 1/2 f of u evaluated from 1 to 3, right? So cái be 1/2 f of 2s, right? Evaluated from 1 to 3, right? So cái be 1/2 f of substitute 3 for s cái be 6 subtract f of 2, right? So the answer is equation 1. A particle moves along the x-axis so that at time t greater than or equal to 0, its position is given by s of t equals this guy. At what time t is the particle at rest? You know that the particle at rest when v of t equals 0, right? So we're going to take the derivative of this one. V of t equals s prime of t, right? So it could be 6t squared minus 42t plus 72, right? So we're going to let this one equal to 0, right? So it turns out to be 6t squared minus 42t plus 72 equal to 0, right? Divide both sides by 6. It's going to be t squared minus 7t plus 12 equal to 0, right? So if we factor this one, it turns out to be t minus 4 times t minus 3 equal to 0, right? And then t equals 3, t equals 4, right? Now t greater than or equal to 0, right? So the answer must be E. Now question 2. For time t greater than or equal to 0, the velocity of the particle moving along the x-axis is given by v of t equal this guy. At what values of t is the acceleration of the particles equal to 0? So you need to calculate a of t, right? So we need to take the derivative of this one. It's going to be a of t equals v prime of t, right? We're going to use the product rule, right? So the derivative of this one is going to be 1, right? So it's going to be t minus 2 squared, right? Plus derivative of this one is going to be 2 times t minus 2 times t minus 5, right? Now simplify this one, it's going to be t squared minus 4t plus 4 plus distribute this one, it's going to be, now simplify this one, it's going to be 3t squared minus 18t plus 24, right? Now we need to let this one equal to 0 right here, right? So divide both sides by 3. It's going to be t squared minus 6t plus 8 equal to 0. Factor this one is going to be t minus 4 times t minus 2 equal to 0, right? So t equals 4, t equals 2, right? So the answer must be C. Now let's move on to question 3. A particle moves along a straight line. The graph of the particle's position s of t at time t is shown above for t between 0 and 6. The graph has horizontal tangents at t equals 1 and t equals 5. So it's right here and right here, right? Now, and a point of inflection at t equals 2 is going to be right here, right? For what values of t is the velocity of the particle increasing, right? So velocity of the particles is increasing when the acceleration greater than 0, right? But acceleration actually has the problem of t greater than 0, right? So when the second derivative greater than 0, it tells us that the function s of t must be concave up, right? So we look at this one, the function is concave up from 0 to 2, right? So the answer must be A at time t equals 0. what is the position of the particle at time t equals 1. Alright, so basically we need to use the fundamental theorem of calculus, right? So we have the integral form t1 to t2 of v of t dt, right? It's going to be s of t2 minus s of t1, right? So s of t2, this is t2, this is t1, right? So we have s of 1 equals s of 0, right? Plus the integral form 0 to 1, right? Of v of t is right here, 3t squared plus 6t dt, right? Now s of 0 is 2, right? So it could be 2 plus antiderivative of 3t squared, it could be t cubed, right? Plus 3t squared, right? Evaluated from 0 to 1. It's going to be 2 plus substitute 1 for t, it's going to be 1 plus 3, right? Substitute 0 for t is going to be 0. The answer should be 6, right? So it could be B. Now you have the second way to do this one. Basically, you need to take antiderivative of the function v of t right here. 3t squared plus 6t dt, right? So it's going to be t cubed plus 3t squared plus c, right? Now we're going to use the initial condition right here, right? So this guy actually s of t, right? Because when you take antiderivative of v of t, it's going to be s of t, right? So you have s of 0, it's going to be 2, right? Right here. So substitute 0 for t, you get c equals 2, right? Substitute back over here. So s of t equals t cubed plus 3t squared plus 2, right? Now we need to find the position when t equals 1, right? So s of 1 equals 1 cubed plus 3, 1 squared, right? Plus 2. It's still 6. The answer is still B, right? Question 5. The velocity of the particle moving on a line at time t is v of t equals this guy, meters per second. How many meters did the particle travel from t equals 0 to t equals 4, right? So the question means you need to find the total distance, right? So we have s of t equals the integral from 0 to 4 of absolute value of v of t, right? dt. So it can be integral from 0 to 4 of absolute value of 3t power of 1/2 plus 5t power of 3/2, right? dt. Look at this one, from 0 to 4. The velocity always positive, right? So we can remove the absolute value side without changing anything, right? So it's actually integral from 0 to 4, 3t power of 1/2 plus 5t power of 3/2 dt, right? And then we're going to use the power rule, right? So it can be 3 over 3/2 times t power of 3 over 2, right? Plus 5 over 5/2 times t power of 5 over 2, right? Evaluated from 0 to 4. Now 3 divided by 3 over 2, it turns out to be 2, right? Substitute 4 for t, it's going to be 4 power 3/2. Now 5 divided by 5 over 2, it turns out to be 2 plus 2. Substitute 4, it's going to be times 4 power 5 over 2, right? Substitute 0, it's going to be 0, right? Now let's simplify this one. It's going to be 2 times square root of 4 cubed, right? Plus 2 times square root of 4 to the 5th, right? Now 4 cube, it could be 64, square root of 64 equal 8. 8 times 2, it could be 16, right? Plus, this guy right here turns out to be 2 square root of 4 power 4 times 4, right? So, bring this one outside, it turns out to be 16, right? 16 times 2, it could be 32, right? 32 square root of 4, it could be 2. So, it could be 64, right? So, 16 plus 64, it could be 80. So, the answer must be D. Question 6. If the position of the particle on the x-axis at time t equals negative t squared, then the average velocity of the particle between 0 and 3 is. Alright, so average velocity given by the formula delta s divided by delta t. It's going to be s of 3 subtract s of 0 divided by 3 subtract 0, right? So s of 3, substitute 3 for s, it turns out to be negative 5 times 3 squared, right? Minus negative 5 times 0 squared, right? Divided by 3 minus 0. So it could be negative 45 divided by 3. It's going to be negative 15. The answer is C. Now let's move on to question 7. A particle travels in a straight line with a constant acceleration of 3 meters per second per second. If the velocity of the particles is 10 meters per second at time t equal 2 seconds. So this guy right here tells us that v of 2 equals 10, right? Now how far, which means they ask you as, right? Does the particle travel during the time interval when its velocity increases from 4 meters per second to 10 meters per second? So from 4 meters per second, it means v of 0 equals 4, right? 2, this guy right here, v of 2 equals 10, right? So they're gonna ask you how far between t equals 0 and t equals 2, right? So you given 3 meters per second right here. This is acceleration, right? So you need to find the velocity function by taking antiderivative of 3 dt, right? So it could be 3t plus c, right? And then you given this guy right here, you need to use this condition to solve for c, right? So I have 10 equals 3 times 2 plus c. So c equals 4, right? So v of t equals 3t plus 4, right? Now we need to find the position, right? So we need to take integral from 0 to 2 of 3t plus 4 dt. And this guy actually s of t, right? So it's going to be 3 over 2 t squared plus 4 t evaluated from 0 to 2. Substitute 2 is going to be 6 plus 8. Substitute 0 is going to be 0. The answer is 14, right? So it could be B. Now let's move on to question 8. A particle moves along the x-axis. The velocity of the particle at time t is 6t minus t squared. What is the total distance traveled by the particle from t equals 0 to t equals 3? Alright, so you know that the total distance is given by the formula integral from 0 to 3 of absolute value of v of t dt, right? So it can be integral from 0 to 3 absolute value of 6t minus t squared dt, right? Now we need to find ways to remove the absolute value side right here, right? So we need to find the critical number of this one. So we have 6t minus t squared equals 0, right? Now factor t out, so it could be 6 minus t equals 0, right? So t equals 0 and t equals 6, right? So we're going to draw the number line. We need to place 0 and 6 right here, right? So the left hand side should be negative infinitive, the right hand side should be positive infinitive, right? Now we need to test an interval, right? So I'm gonna pick this interval right here, I pick 1. We did this interval, right? Substitute over here, right? So substitute 1 for t, I get the positive number, right? And then this guy must be negative. This guy must be negative. You keep changing the side, right? We look at the lower bound and upper bound right here. 0, 3. 0, 3 is inside this interval. It's going to be positive, right? So I just remove the absolute value side without changing anything, right? So it can be interval from 0 to 3 of 6t minus t squared dt, right? So it's going to be 3t squared minus 1 over 3t cubed evaluated from 0 to 3, right? Substitute 3 for t, it's going to be 27. Subtract 1 over 3 times 27, right? So it can be 18. The answer must be D. Now let's move on to question 9. A particle moves along the x-axis with its position at time t is given by this guy, where a and b are constants, and a not equal to b. For which of the following values of t is the particle at rest? It tells us that v of t equals 0, right? So you need to take the derivative of this one, right? So it turns out to be v of t equals, we're going to use the product rule, right? So the derivative of this one is equal 1. So it could be t minus b, right? Plus derivative of this one is equal 1. So it could be t minus a, right? Simplify, it could be 2t minus a minus b, right? So we just let this one equal to 0, right? So v of t equals 0 is the same thing as 2t equals a plus b, right? So t equals a plus b divided by 2, right? So the answer must be b. Now let's move on to question 10. The table gives selected values of the velocity v of t of a particle moving along the x-axis. At time t equals 0, the particle is at the origin. Which of the following could be the graph of the position s of t of the particle t between 0 and 4? Now, this one is the graph of the position s of t, right? This one is the function v of t, right? Now observe that at t equals 3, v of t equals 0, right? So we have v of 3 equals 0. But v of t actually the first derivative of the function s of t, right? It's gonna be s prime of 3 equals 0. It tells us that the function s of t has the horizontal tangent line at t equals 3, right? So we look at this one right here, horizontal tangent line at 1 point something, right? So this is not the right answer, right? This one 1 point something is not the right answer, right? This one 1 point something is not the right answer. This guy actually 3, right? This guy actually 3. So the answer could be C and E, right? Now we look at this guy right here. V of 1 equals 2. It's the same thing as s prime of 1 equals 2, which is greater than 0. It tells us that the function s of t is increasing at t equals 1, right? So right here at t equals 1, we have that the function is decreasing because the slope is negative, right? The function is increasing right here. Look, when you draw the tangent line, it's positive, right? So the answer must be C. Remember the Christmas tree trick. The tangent line is going up, the slope is positive. Tangent line is going down, slope is negative. Tangent line is horizontal, the slope is 0. And tangent line is vertical, the slope is undefined. Keep that in mind. Now let's move on to question 11. A particle moves along the x-axis so that anytime t greater than or equal to 0, its velocity is given by v of t equals 3 plus 4.1 times cosine of 0.9 t. What is the acceleration of the particle at time t equals 4, right? So acceleration is the first derivative of v of t, right? So we have a of t equals v prime of t, right? So it could be 4.1 times 0.9 sine of 0.9 t. Don't forget the negative sign, right? So then a of 4 equals negative 4.1 times 0.9 sine of 0.9 times 4, right? So we're gonna bring up the calculator. At calculator, negative 4.1 times 0.9 times sine of 3.6. Press Ctrl Enter. It's could be 1.633, right? So it could be C. Now let's move on to question 12. A particle moves along the x-axis so that anytime t greater than 0, its acceleration is given by this function. If the velocity of the particle is 2 at time t equals 1, it tells us that v of 1 equals 2, right? Then the velocity of the particle at t equals 2 is how much, right? So you will need to calculate v of 2 equals how much, right? So we need to use the fundamental theorem of calculus, right? So we have v of 2 is the final velocity equals initial velocity. It could be v of 1, right? Plus the integral from 1 to 2 of a of t, right? dt. So we just substitute value v of 1 is going to be 2 plus integral from 1 to 2 of ln of 1 plus 2 to the t dt, right? So it's going to be, we just bring up the calculator because this one is the calculator active problem, right? So we're going to add calculator. Now we need to hit the number 2 plus, hit the button right here, pick the integral right here. Integral from 1 to 2 of ln. So hit Control and e to the s right here. 1 plus 2 to the t, right? And then dt right here. Press Control Enter. It's gonna give you 3.346, right? So the answer must be E. Now let's move on to question 13. The velocity in feet per second of a particle moving along the x-axis given by the function v of t equal this guy. What is the average velocity of the particle from t equals 0 to t equals 3? So we need to use the average velocity formula, right? 1 over b minus a, which means 3 subtract 0, right? Integral from 0 to 3, right? Of e to the t plus t times e to the t dt, right? So we're gonna bring up the calculator. Now I'm gonna copy this one down. Now I'm gonna put the fraction in the front. So I'm gonna hit the button right here, put the fraction 1 over 3, right? And then the integral from 0 to 3. And then press Control Enter. It's gonna be 20.0855, right? So it could be 8 right here. Now let's move on to question 14. A particle moves along the x-axis over the time interval 0 to 6. The graph of the velocity of the particle is shown above. Over the time interval 0 to 6, the particle's displacement is 4, and the particle travels a total distance of 16. What is the value of this guy? Now you know that the particle displacement is given by the formula Integral form 0 to set of v of t dt equals error above the axis subtract error below the axis, right? Now I name the error above the axis as m, error below the axis n, right? So this guy becomes m minus n, right? The particle travels a total distance of 16, right? So it tells us that the integral form 0 to set of absolute value of v of t dt equals 16, right? And this guy actually total distance is going to be m plus n equals 16, right? Now this is m minus n equals 4 right here, right? So we have a system of equation, right? It's going to be m minus n equals 4, m plus n equals 16. We're going to solve the system of the equation for m and n. So I'm going to add them vertically. It turns out to be 2m equals 20, m equals 10. Substitute 10 for m, and then you have n equals 6, right? Now since n is the error of the regions below the axis, it could be right here, right? And n equals 6, right? So this guy actually the integral form 2 to 4 of v of t dt, right? So it could be n right here, right? And this guy below the axis, so it could be negative 6. The answer must be B. Now let's move on to question 1. Let f be the function given by Ls equals 4 to the s if 4 subintervals of equal length yields. What is the value of the left remain sum approximation for the integral form 1 to 3 of Ls ds? We need to find delta s is going to be b minus a over n, right? And right here is 4, right? Because you have 4 subintervals. So it's going to be b, which means 3, a, which means 1, right? So it's going to be 3 minus 1 divided by 4, right? So it's going to be 1/2, right? So you're going to draw the number line. You're going to start from 1, right? And you're going to end up at 3, right? Now we have 4 subintervals, right? So divide this one in half, and this one in half, this one in half, right? So this one is 1.5, this is 2, and this is 2.5, right? Now we're going to use the left remain sum, right? So the error is the sum of f of si, right, times delta s when I go from 1 to 3, right? Now left remain sum, we're going to start from 1, right? So s equals 1, substitute over here, you have f of 1, right? So it could be f of 1 times 1/2 plus f of 1.5 times 1/2, right? Plus f of 2 times 1/2, right? And f of 2.5 times 1/2, right? We stop right here, right? So we're going to factor 1/2 out, right? Now f of 1, substitute 1 for s over here. You have 4, right? Plus f of 1.5, substitute 1.5 for s, it could be 4 power 3/2, right? Plus 2, substitute over here, it could be 4 square, plus 2.5, which means 4 power 5 over 2, right? So it could be 1 over 2 times 4 plus 8 plus 16 plus 32, right? And it's going to be 30. The answer must be A. Now let's move on to question 2. The graph of the function f is shown above for s between 0 and 3 of the following which has the least value, right? Now we look at the graph right here. This one is the function f of s, and the function f of s is decreasing, right? So then the right remain sum less than the row from 1 to 3 of f of s ds less than left remain sum, right? Now ls is decreasing and concave down. It tells us that the right remain sum less than the midpoint remain sum and trapezoid remain sum, right? So the answer must be C. Now let's move on to question 3. If 3 equal subdivision of the interval from -4 to 2 are used, what is the trapezoidal approximation of this interval, right? So we need to find delta S. It could be b minus a over n, right? This is a, this is b, and n right here 3, right? So it could be 2 minus -4 divided by 3, right? It could be 2. So we draw the number line right here. A equals -4, B equals 2, right? You have 3 subintervals, right? So just divide this one into 3 subintervals, right? Now, delta S is 2, right? So -4 plus 2, it could be -2, and this is 0, right? Now remember, the area of the trapezoid is base 1 plus base 2 times height divided by 2, right? So in this situation, the height should be delta S, this is the height, right? And base 1 is f of -4 and f of -2 right here, right? So you have the interval from -4 to 2 of e to the -s over 2 ds equals, right? LOS is right here. So it's going to be base 1 -4, which means f of -4 plus f of -2 times the height. The height is that s right here is going to be 2, right? Divided by 2, right? Plus the second one, f of -2 plus f of 0 times 2 divided by 2 plus the last one, f of 0 plus f of 2 times the height 2 divided by 2, right? Now 2 and 2 right here cancel out, right? So you end up with f of -4 plus f of -2, f of -2 right here could be 2 f of -2, right? F of 0, f of 0, it could be 2 f of 0, right? And then plus f of 2, right? Now f of -4, the function f of s is right here, right? So it could be e to the 4 divided by 2 plus 2 times e squared divided by 2, right? Plus 2 times e to the 0 divided by 2 plus e to the -2 divided by 2, right? Now we just factor 1/2 out, right? So the answer must be E. Now let's move on to question 4. The function f is continuous on the closed interval 2 to 8 and has values that's given in the table above, using subintervals 2 to 5, 5 to 7, and 7 to 8. What is the trapezoidal approximation of the interval from 2 to 8 of f(s) ds, right? So the interval from 2 to 8 of f of s ds is approximately, now delta s right here is 3 and 2 and 1, right? The height is right here, right? So we have f of 2 plus f of 5, right? Times the height right here, 3 divided by 2, right? Plus the second one, f of 5 plus f of 7 times the height here 2 divided by 2. And the last one, f of 7 plus f of 8 times the height is 1 right here, so I don't need to write, right? Divided by 2. Now I'm going to factor 1/2 amps, right? So I have f of 2 right here equals 10, right? Plus f of 5 equals 30. Altogether multiplied by 3 plus f of 5 right here equals 30. f of 7 equals 40 times 2, right? Plus f of 7 equals 40. f of 8 equals 20, right? Now we're going to simplify 1/2. 40 times 3 is going to be 120. 30 plus 40 is going to be 70 times 2 is going to be 140, right? This one is 60. Now 120, 140 is going to be 260. Plus 60 is going to be 320. 320 divided by 2 is going to be 160, right? So the answer must be C. Now let's move on to question 5. Which of the following limits is equal to the row right here, right? So we see that A equals 3, right? B equals 5, right? And then delta S equals B minus A divided by N. It's going to be 5 minus 3 divided by N. It's going to be 2 over N, right? So we look at this one right here. We need to eliminate A and C, right? Because it doesn't have 2 over N, right? We have 2 over N right here. So F of CI. In this direction is K, right? So let's replace this one with K. It's going to be A right here, A equals 3. So it's going to be A plus K times delta S, right? So it's going to be F of A equals 3 plus K times 2 over N, right? So it's going to be F of 3 plus 2K over N. But F of S equals S to the 4 right here, right? So substitute this guy for S, so it could be F of 3 plus 2K over N equals 3 plus 2K over N altogether power of 4, right? So the answer must be D. Now let's move on to question 6. The graph of the function f prime of S, the derivative of the function f, is shown above. If f of 0 equals 0, which of the following must be true? Alright, so before we're gonna solve this problem, let's review definition of increasing function and decreasing function. Alright, so if the function f of s is increasing, then if you have s1 greater than s2, then f of s1 must be greater than f of s2, right? If you have the function f of s is decreasing, then if you have s1 greater than s2, then f of s1 must be less than f of s2, right? So we look at the function f prime of s right here. The interval from 0 to 1, right? And the function f prime of s is above the axis. It tells us that f prime of s greater than 0, right? So if f prime of s greater than 0, it tells us that the function f of s is increasing, right? So then we look at the value of s right here. S1 equals 0. S2 equals 1, right? So we have 0 less than 1. then f of 0 must be less than f of 1, right? But f of 0 right here greater than f of 1, so this one is false, right? Now, number 2, f of 2 greater than f of 1. Look at the interval from 1 to 2. So from 1 to 2, the function f prime of s still above the axis, right? So it tells us that f prime of s still greater than 0. Then the function f of s is increasing, right? So because the function f of s is increasing, you have s1 is 1, s2 is 2, right? So we have 1 less than 2, and then f of 1 must be less than f of 2, right? So this one is 2, right? Now number 3, f of 1 greater than f of 3, right? So from 1 to 3, the function has 2 portions, right? So we look at this one from 1 to 2. We have the larger positive error, right? And from 2 to 3, we have the small negative error, right? So the positive error is clearly larger than the negative error. So overall, you have f of 3 greater than f of 1, right? But it's f of 1 greater than f of 3, so this one is wrong, right? So the answer must be B. Now let's move on to question 7. If a trapezoidal sum over approximate the interval from 0 to 4 of fs ds and a right Riemann sum under approximate the interval from 0 to 4 of fs ds, which of the following could be the graph of the function fs? Now remember, if a trapezoidal sum over approximates, it tells us that the graph of the function f of s is concave up, right? Now, the right Riemann sum under approximates, it tells us that the graph of the function f of s is decreasing, right? So, the function f of s must be concave up and decreasing. The answer must be A. Now let's move on to question 8. The data for the acceleration a of t of a car from 0 to 6 seconds given in the table above. If the velocity at t equals 0 is 11 feet per second, the approximate value of the velocity at t equals 6 computed using a left-hand Riemann sum with 3 subintervals of equal length is. Alright, so we're going to use the left-hand Riemann sum t equals 0 to t equals 6. We start from 11 feet per second, right? So we have 11 plus, now the width right here is 2, this guy 2, and this guy 2, right? 3 subintervals. Now the left Riemann sum, you need to pick this guy right here, 5, 2, and 8, right? So you need to multiply 2 by 5, right? Plus 2 by 2 right here, plus 2 times 8. Alright, so it could be 11 plus 10 plus 4 plus 16, right? So it could be 11 plus 30, and it could be 41. The answer must be E. Now question 9. The table above gives selected values for a continuous function f. If the function f of s is increasing over the closed interval 0 to 2, which of the following could be the value of the interval from 0 to 2 of f of s ds? Now, since the function f is increasing, it tells us that the left Riemann sum is under approximated, right? And the right Riemann sum is over approximated, right? So it tells us that the left Riemann sum less than the interval from 0 to 2 of f of s ds less than the right Riemann sum, right? Now we need to calculate the error using the left remaining sum, right? So we look at this one right here, the width 0.5. This is 0.5. This is 0.5. And this one is 0.5, right? So it's going to be length times width, right? So the left is going to be 6 right here. 6 plus 14 plus 24 plus 28. And then times the same width, right? A factor 0.5 ounce, right? So I'm going to simplify. This is 20 plus 24 is going to be 44 plus 28 is going to be 72. 72 times 0.5 is going to be 36, right? Now the right remaining sum, I do exactly the same thing, right? So it's going to be 0.5 outside, right? Now we're going to pick 14, 24, 28, and 34. And this guy gives us 50, right? Now 36 less than the interval from 0 to 2 of f of s ds less than 50, right? Now we look for the values that between 36 and 50, which is 41. The answer must be B. Now question 10. A tank contains 35 gallons of water at time t equals 2 minutes. Water is flowing into the tank at a rate R of t, and where R t is measured in gallons per minute and t is measured in minutes. Selected values of R t is given in the table above, using a right remaining sum with 3 subintervals and data from the table. What is the approximation of the number of gallons of water that are in the tank at the time t equals 11, right? So question 10 is similar to question 8. Alright, so we need to use the right remaining sum right here, right? We start from here, 35, right? So we have 35 plus, now right remaining sum, the width right here, 5 subtract 2 is going to be 3. This is 4, and this is 2, right? Now right remaining sum, we're going to use this guy, and this guy as heights, right? So we have 5.1 times 3 plus 4.7 times 4 plus 4.4 times 2, right? 77.9, right? The answer must be D. Question 1. The interval from -2 to s of 4t cubed minus 2t equals, now we're going to take antiderivative of this one, right? So it could be t to the 4 minus t squared, right? Evaluated from -2 to s. So it could be s to the 4 minus s squared, right? Subtract -2 to the 4. Subtract -2 squared, right? So it's going to be s to the 4 minus s squared. This one simplified is going to be 12, right? So the answer must be B. Now let's move on to question 2. What is the average value of the function y for the part of the curve y equals 3s minus s squared, which is in the first quadrant, right? So we're going to sketch this one. Alright, so here's the graph of the function 3s minus s squared in the first quadrant, right? So this one is 0 and this one is 3, right? Look, you just let this one equal to 0 and then you find the s equal 0 and s equal 3, right? And we need to calculate the error of this region right here. So we have the interval from 0 to 3 of 3s minus s squared ds, right? So it could be 3 over 2s squared minus s cubed over 3, right? Evaluated from 0 to 3, right? Substitute 3 for s, so it could be 3 squared equal 9 times 3, 27, right? Over 2 minus 27 over 3, right? So it's going to be 27 over 6, right? Now, since we need to find the average value, right? So we're going to put 1 over b minus a, which means 3 minus 0, right? So it could be 3, right? So this one should be 1 over 3. And this one multiplied by 1 over 3, right? So it could be 27 over 18. Divide the top bottom by 9. So it could be 3 over 2, right? So the answer must be C. Now question 3. The graph of f prime, the derivative of f, is the line shown in the figure above. If f of 0 equals 5, then f of 1 equals how much, right? So we have f of 1 is the final values, right? Equals initial value plus the interval from 0 to 1 of f prime of s ds. Now f of 0 equals 5, so we have 5 plus interval from 0 to 1 right here of f prime of s right here. Actually the error of the right triangle right here, right? Base times height divided by 2, right? The base is 1, the height is 6, right? So it could be 1 times 6 divided by 2, right? So it could be 8, right? The answer must be D. Question 4. We need to calculate the derivative with respect to s of this guy, right? So we just print this one over here, right? So it could be sine of s square altogether cube, right? And since this one is composite function, right? We need to multiply by derivative of s square prime, right? So it could be 2s times sine s to the 6, right? So the answer must be E. Now question 5. Let f of s be this one. At what value of s is f of s a minimum, right? So when we talk about the minimum, maximum, increasing or decreasing of the function, think about f prime of s, right? So we need to take the derivative both sides with respect to s, right? So we have this guy becomes f prime of s equals, print this one over here, right? So we have e to the s square minus 3s altogether square, right? Times derivative of this one right here, right? So it could be 2s minus 3, right? Now we need to let f prime of s equals 0, right? So then 2s minus 3 equals 0. This guy equals 0. This guy always positive, right? So then you have s equals 3 over 2, right? Now we're gonna create the side chart, right? So put 3 in half right here, negative infinitive and positive infinitive right here, right? Now we're gonna test the interval, right? So I'm gonna pick 0 right here. I substitute 0 for s back to the f prime of s right here, right? So this one always positive, right? This one negative, right? So it could be negative right here. And this guy must be positive, right? So the function is decreasing right here and increasing right here. This one is the minimum, right? So the answer must be C. Now question 6. Find the interval from 0 to pi over 2 of cosine of theta over square root of 1 plus sine theta d theta. One of the best way to do u substitution is to let u be the radical right here, right? So I'm gonna let u be square root of 1 plus sine theta. I'm gonna square both sides, so I have u square equals 1 plus sine theta, right? Take the derivative both sides with respect to theta, so I have 2u du equals cosine theta d theta, right? Now I need to change the upper bound and lower bound, right? So I have theta equals 0 and theta equals pi over 2, right? Then I'm going to use this guy right here, right? So if theta equals 0, substitute over here, u equals 1. Theta equals pi over 2, substitute over here, u equals square root of 2. This guy becomes the integral from 1 to square root of 2 of cosine theta d theta equals 2u du, right? So we have 2u du over this guy actually u, right? So it could be integral from 1 to square root of 2 du, right? So it could be 2u evaluated from 1 to square root of 2, right? So it could be 2 square root of 2 minus 2. Now I'm going to factor 2 out, so I have 2 times square root of 2 minus 1, right? So the answer is D. Now let's move on to question 7. The graph of the function f shown in the figure above has horizontal tangents at s equals 3 and s equals 6. If g of s equals this guy, what is the value of g prime of 3, right? So we need to take derivative of g of s, right? It turns out to be f of 2s times derivative of 2s, which means 2. So I put 2 in the front, right? So then I need to calculate g prime of 3. It's going to be 2 times f of 6, right? Now this is the function f of f, right? So f of 6 is negative 1, right? So it could be 2 times negative 1 is going to be negative 2, right? So the answer must be C. Let's move on to question 8. Let h be the function defined by h of s equals 1 over square root of s to the 5th plus 1. If g is an antiderivative of h and g of 2 equals 3, what is the value of g of 4? Alright, so g of 4 is the final value. This one the initial value, right? So we have g of 4 equals g of 2 plus the integral from 2 to 4 of h of s ds, right? Because g is an antiderivative of h, right? So g of 2 equals 3 plus the integral from 2 to 4 of 1 over square root of s to the 5th plus 1 ds, right? Now we're allowed to use the calculator. So we're going to add calculator, hit the button right here, pick the integral right here. Integral from 2 to 4 of, hit the button right here, pick the fraction. 1 over square root s to the 5th plus 1 ds. Hit Control Enter, and don't forget to add initial amount, which means 3, right? It could be 3.1515, right? So the answer must be D. Now question 9. Which of the following is an equation of the line tangent to the graph of y equals this guy at the point where s equals 1? Alright, so we need to find the slope, right? So we have y prime equals derivative of this one equals 0, right? So it could be negative side right here, right? Bring s over here, so it could be e to the s squared, right? And then substitute 1 for s, so we have y prime of 1 equals negative e, right? Now we substitute 1 for s back over here to find the order pair, right? So we have y of 1 equals 2 minus the integral from 1 to 1 of e of t squared dt. This guy the same, it could be 0, so the answer must be 2, right? So y equals the slope negative e times s minus s1, which means 1, plus y1, which is 2, right? So the answer must be C. Now question 10. If f of s equals this guy for s greater than or equal to 1, and then f prime of 2 e. So basically we need to calculate f prime of s first, right? So it's gonna be 1 over 1 plus ln of s cubed, right? We just print this guy over here. And don't forget to multiply by derivative of this guy, right? Which is 3s squared, right? Now we need to calculate f prime of 2, right? So it can be 1 over 1 plus ln of 8, right? Because 2 cubed equals 8 times 3 times 4, it could be 12, right? So I put 12 right here, right? So the answer must be D. Now let's move on to question 11. If f prime of s equals this guy, f5 equals 8 and f3 equals how much, right? Again, we're going to use the fundamental theorem of calculus in context, right? So we have the final amount, which means f of 5 equals initial amount f of 3 plus the integral from 3 to 5 of f prime of s ds, right? So it could be f of 3 equals f of 5 subtract the integral from 3 to 5 of f prime of s ds, right? So it's going to be 8 subtract the integral from 3 to 5 of ln of s squared ds, right? So we're going to print up the calculator. Alright, so I'm going to copy this one down over here. So it should be the integral from 3 to 5 of ln of s squared ds. Press Ctrl Enter. It's going to be this guy. And don't forget to subtract it from 8, right? So I'm going to subtract 8. And then press Enter. So it could be 2.497, right? So the answer must be A. Now let's move on to question 12. Let g be the function given by g of s equals this guy for s between -1 to 3. On which of the following intervals is the function g is decreasing, right? So when the function g is decreasing, which means g prime of s must be less than 0, right? So we need to calculate g prime of this function first, right? So we have g prime of s equals print s over here, right? So it could be sine of s squared. Now we're going to use the calculator to grab this one, and we need to find the interval where g prime of s less than 0, right? Alright, so we're going to go to home screen and grab right here, hit sine of s squared, and then press enter. It's going to be right here. Now we need to restrict the domain from -1 to 3, right? So go to menu, number 4, window setting right here, -1, 2, 3, right? And y minimum is -1 and y maximum is 1, right? Because the range of the sine function always between -1 to 1. So it could be right here. Now the interval from -1 to 3 where g prime of s is negative is this guy right here, right? So you need to find the 0 of this one to find the interval, right? So hit menu, analyze graph, 0, go to the left, go to the right, it's right here. And menu, analyze graph, 0, go to the left, go to the right, it's going to be right here, right? So it's from 1.77 to 2.51. So the answer must be D. Now let's move on to question 13. If s between 0 to 4, of the following, which is the greatest value of s, such that the interval from 0 to s of t squared minus 2t dt greater than or equal to the interval from 2 to s t dt. So this guy is the same thing as t cubed over 3 minus t squared evaluated from 0 to s greater than or equal to t squared over 2 evaluated from 2 to s, right? So it could be s cubed over 3 minus s squared greater than or equal to s squared over 2 minus 2. Now we're going to find the LCD, right? So LCD of 3 and 2, it could be 6, right? So I multiply the top bottom by 2 for this guy. So I have 2s cubed minus 6s squared, right? Greater than or equal to 3s squared minus 12, right? I print every single thing to the left hand side. So I have 2s cubed minus 9s squared plus 12 greater than or equal to 0, right? Now to find the greatest value of s for s between 0 to 4 of this inequality right here, we need to graph the function f of s equals 2s cubed minus 9s squared plus 12, right? And then we need to restrict the domain from 0 to 4, right? And we need to find the greatest value where f of s greater than or equal to 0. In other words, f of s is above the x-axis. Add graph, input the function right here, and then press enter. It's gonna be right here, right? Now we need to restrict the domain. So press menu number 4, number 1. It should be from 0 to 4, right? Now to see the full graph, we need to restrict the range. It should be negative 20 to 20. Press OK. It's right here, right? So the greatest value of s, where the function f of s is above the axis, is the 0 of the function right here, right? So we're gonna press menu number set number 1. Go to the left, go to the right of 0. The answer is 1.39, right? So the answer must be B. Now let's move on to question 14. Let f of s equals the integral from a to s of h of t dt, where h has the graph shown above. Which of the following could be the graph of f? Alright, so we'll look at the initial value right here, a, right? So s equals a. Substitute a for s over here. So we have f of a equals the integral from a to a of h of t dt, right? This guy and this guy the same. So then f of a must be 0, right? So we look at the graph right here. F of a equals 0 right here. This one 0. This is not. This is not. This is not, right? So we need to eliminate C, B, and D, right? So A and E could be correct. Now we're gonna take derivative of this one. So we have f prime of s equals print s over here. We have h of s, right? So it tells us that the function f of s must be differentiable at s equals b, right? So look at b right here. This is a sharp turn. So the function is not differentiable, right? This is strong. This one, the function differentiable as s equals b right here. So the answer must be E, right? Another way to solve this problem is we're gonna start taking the second derivative of this one. It could be h prime of s. So look at the function h of s. The function h of s starts right here. So h prime of s is the slope of the tangent line right here, which is positive, right? So it tells us that f double prime of s must be positive, right? In other words, f of s is concave up, right? So the function f of s starts out concave up, right? This one is concave down, so this is wrong, right? This is concave up right here. So the answer must be E. Now let's move on to question 15. A pizza heated to a temperature of 350 degrees Fahrenheit is taken out of an oven and placed in a 75 degree Fahrenheit room at time t equals 0 minutes. The temperature of the pizza is changing at a rate of negative 110 times e to the negative 0.4 t degrees Fahrenheit per minute to the nearest degree. What is the temperature of the pizza at time t equals 5 minutes? Right? So we're going to use the fundamental theorem of calculus in context, right? So the final temperature of the pizza is T of 5 equals initial temperature of the pizza is T of 0 plus the integral from 0 to 5 of negative 110 e to the negative 0.4 t dt, right? T of 0 is 350 right here, right? Plus the integral from 0 to 5 of negative 110 e to the negative 0.4 t dt, right? So we're gonna print up the calculator. Go to the home screen, add calculator, hit the button right here, pick the integral from 0 to 5 of, and don't forget to add 350. Press Ctrl Enter. It's going to be 112.217. So the answer must be A. Now let's move on to question 16. For all values of s, the continuous function f is positive and decreasing. Let g be the function given by g of s equals the interval from 2 to s of f of t dt. Which of the following could be a table of values for the function g? We'll look at this one right here. It tells us that the function f is greater than 0, right? And the function f decreasing, which means f' of s less than 0, right? We have g of s equals this guy, right? So if we take the derivative of this one, it turns out to be g' of s equals f of s, right? But f of s is positive, then g' of s must be positive, right? Now if we take the second derivative of this one, it turns out to be f' of s, right? But f' of s is less than 0. It tells us that g' of s less than 0, right? So from these two guys right here, it tells us that the function g of s is increasing and concave down. This one tells us that the function is increasing. This guy tells us that the function is concave down, right? So either this one or this one. So if we combine these two guys right here, the function g of s should look something like this, right? Increasing and concave down. Now we look at the answer choice right here. All s values is increasing, right? Look. The y values right here is increasing for A, right? This one increasing for B. This one decreasing for C, decreasing for D, decreasing for E. So C, D, and E tells us that the functions are decreasing, right? So we need to eliminate C, D, and E, right? Now we need to find the rate of change of the function g of s for A and B right here, right? So look at this one right here. The change right here is plus 2, right? The change right here is plus 1, right? So the rate of change is decreasing, right? Look at this one right here. The change is right here plus 2. The change is right here plus 3, right? So the rate of change right here is increasing, right? So it tells us that for A right here, the function g of s is increasing at a decreasing rate, right? And the function g of s for the answer choice B right here is increasing at an increasing rate, right? Now you learn in AP Pre-Calculus, the function g of s is increasing at a decreasing rate. It's going to be something like this, right? It looks like this one right here. The function g of s is increasing at an increasing rate. It looks something like this, right? Now, how do we know that? We just draw two tangent lines. You will see it. Alright, the tangent line right here is steeper than this one, which means the rate of change is decreasing. The tangent line right here is steeper than this one, which means the rate of change is increasing, right? So finally, the answer must be A. Question 1. If dy over ds equals s squared y, then y could be. Alright, so we're going to separate this one. It turns out to be dy over y equals s squared times ds. Now take entire derivative both sides. So we have ln of absolute value of y equals 1/3 s cubed plus c, right? Now we're going to exponentiate both sides. So remember, you have a raised to the log base a of b equals b, right? In this situation, e raised to the ln of b is the same thing as e raised to the log base e of b, and it's still b, right? So it's going to be absolute value of y equals e raised to the 1/3 s cubed plus c, right? Remember, a raised to the m plus n is going to be a raised to the m times a raised to the n, right? So this guy turns out to be absolute value of y equals e raised to the 1/3 s cubed times e to the c, right? So I name e to the c as another constant c, right? So it's going to be absolute value of y equals c times e raised to the 1/3 s cubed. Now, we need to remove the absolute value side, so the big y equals plus and minus c times e raised to the 1/3 s cubed, right? Now, I'm going to name this constant c right here as a, right? So a equals plus and minus c, right? So the big y equals a times e raised to the 1/3 s cubed, right? So the answer must be c, right? When a equals 2. Now let's move on to question 2. Which of the following is the solution to the differential equation dy over dx equals 4s over y, where y of 2 equals -2, right? So we're going to separate the variable right here, right? It turns out to be y dy equals 4s ds, right? And take entire derivative both sides, right? So it could be 1/2 y squared equals 2s squared plus c, right? Now we're going to use this condition right here, which is s equals 2, y equals -2, right? So it's going to be 1/2 times 4 equals 2 times 4, right? Plus c. So it could be 2 minus 8 equals c. So c equals -6, right? So we substitute -6 for c back to this equation right here, right? So we have y squared over 2 equals 2s squared minus 6, right? So then multiply both sides by 2. Y squared equals 4s squared minus 12, right? Take square root both sides, so y equals plus and minus square root of 4s squared minus 12, right? Now, since the initial condition is negative, right? So we're going to pick the -1, right? So it could be y equals negative square root of 4s squared minus 12, right? Now, look at the domain right here. This guy actually the one under the radical side, right? So 4s squared minus 12 should be greater than 0, right? So 4s squared greater than 12. So s squared greater than 3, right? And s greater than square root of 3, or s less than negative square root of 3, right? That's why we got this one. So the answer must be C. Now let's move on to question 3. Which of the following is a slope field for the differential equation dy over dx equal s over y? Alright, so now first you need to check to see if s equal y, right? So if s and y the same, doesn't mean it's going to be 1, right? So the slope should be 1, right? We're going to check the diagonal line, right? Because when the slope equals 1, s equals y, right? So the diagonal line right here, the slope is not 1, right? So we need to eliminate this one right here. That's wrong, right? Eliminate A. C. That's still wrong, right? Look at this one. D. That's still wrong, right? And E. Yes, look at the diagonal line right here. So the answer must be E. Question 4. Shown above is a slope field for which of the following differential equations? Alright, so we're going to look at the first quadrant right here. Alright, observe that the first quadrant has the s value positive, right? Y values is positive. And look at the slope field right here. It's always positive, right? look at the Christmas tree trick. If the slope field going this way, it could be positive. This way, negative. This way, 0, and this way is undefined, right? Now we look at the answer choice right here. We need to eliminate the wrong answer, right? Now if s is positive, y positive, dy over ds right here positive, right? So this is good. This is positive, dy over ds positive. Yes, that's right. This guy, yes. This guy, yes. And this guy, yes. So all answer choice right here could be right? Now look at the fourth quadrant right here. S is positive, y is negative, right? But dy over ds still positive. Look at the trend of the line right here, right? For the quadrant for S positive, y is negative. This guy make dy over ds negative, right? But we need this guy to be positive, so answer choice A is wrong. Now answer choice B, S positive, and then S square positive. Y is negative, y square is still positive, right? So dy over ds right here is still positive. This guy match this guy, right? So good. Now C, S is positive, and then S cubed still positive. Y is negative, and then y right here should be negative. This guy makes dy over ds negative. So answer choice C is wrong, right? Now D, S is positive, S square positive. Y is negative, and then y is negative. So this guy makes dy over ds negative. But we need this one to be positive, right? So answer choice D is wrong. Now the last one, S positive, S cubed positive, right? Y is negative, y square positive, right? So this one makes dy over ds positive, which matches this guy, right? So answer choice E could be correct, right? So we just rule out A, C, and E, right? We have B and E left, right? Now look at the second quadrant right here. In the second quadrant, S is negative, right? Y is positive. And look at the trend of the line right here. Dy over ds is negative, right? So we look at answer choice B right here and answer choice D right here. If S is negative, S square is positive. Y is positive, Y square is positive, right? So dy over ds positive. But this guy doesn't match this guy, right? So answer choice B is wrong. Look at answer choice E. S is negative, S cubed should be negative, right? Y is positive, Y squared should be positive. So this guy makes dy over ds negative, right? So it matches this guy, right? So the answer must be E. Now let's move on to question 5. Which of the following is the solution to the differential equation with the initial condition y of pi over 2 equals 2? Alright, so we need to separate the variable, right? So we have dy equals 3 cosine of 2s ds, right? Now we need to take antiderivative both sides, right? So it could be y equals 3 over 2 sine of 2s plus c, right? Remember you have the formula antiderivative of cosine of as plus b ds equals 1 over a sine of as plus b plus c, right? Now we're going to use the initial condition right here, right? So you have 3 over 2 sine of 2 times pi over 2 plus c equals 2, right? So it could be 3 over 2, 2 and 2 cancel out, sine of pi equals 0, right? Times 0 plus c equals 2. Then c equals 2. Substitute 2 for c back over here, right? So we get the answer should be B. Now let's move on to question 6. Let y equals f of t be a solution to the differential equation dy over dt equals k times y, where k is a constant. values of f for selected values of t given in the table above. Which of the following is an expression for f of t? Alright, so from this equation right here, we need to separate the variable, right? So we have dy over y equals k dt, right? So we're going to take entire derivative both sides, right? So we're going to have ln of absolute value of y equals k times t plus c, right? And then we're going to exponentiate both sides, right? So we have absolute value of y equals e raised to the k times t times e raised to the c. So I'm going to name this one as another constant, right? So I call this a big C right here, right? Now, since the initial condition right here is positive, right? So I can remove the absolute value sign without changing anything, right? So I have y equals c times e raised to the k times t, right? And I need to use the initial condition right here to solve for c, right? For equals c times e raised to the 0, right? So then c equals 4. Substitute 4 for c back over here, right? So I have equation y equals 4 times e raised to the k times t, right? Now I'm going to use the second condition right here to solve for k, right? So I have 12 equals 4 times e raised to the 2k, right? So then e raised to the 2k equals 12 divided by 4 is going to be 3, right? Take natural of both sides, so I have 2k equals ln 3, right? K equals 1/2 ln 3, right? Now I'm going to substitute this guy for k back to this equation right here. Then I'm going to end up with y equals 4 times e raised to the 1/2 ln 3 times t, right? So the answer must be A. Now let's move on to question 7. The function y equals e to the 2x plus 6x minus 2 is a solution to which of the following differential equations? So we look at the answer choice right here. We see that we have y prime, we have y double prime, right? So we need to calculate y prime of this guy first, right? So it could be 2e to the 2x plus 6, right? And y double prime is going to be 4e to the 2x, right? Now we need to substitute this guy into each of the equations right here. If both sides the same, that is your solution, right? So I'm going to use question B first, right? So I have 4e to the 2x minus 2 times 2e to the 2x plus 6 plus 12 equals 0, right? So it's going to be 4e to the 2x minus 4e to the 2x minus 12 plus 12 equals 0. The left hand side is 0, the right hand side is 0, right? So it's matches, right? The answer must be B. Now let's move on to question 8. If dy over dx equals 2y squared and if y equals -1, x equals 1, then x equals 2, y equals how much, right? So we need to separate the variable right here, right? So it's going to be dy over y squared equals 2 dx, right? Now we're going to take entire derivative both sides. So it's going to be -1 over y equals 2x plus c. Now we're going to use the condition right here, right, to solve for c, right? So it could be 1 equals 2 plus c. So c equals -1. Substitute back over here. So you have equation -1 over y equals 2x minus 1, right? Now use the second one right here to solve for y, right? So x equals 2, substitute over here, -1 over y equals 2 times 2 minus 1, right? So negative 1 over y equals 3. Then y equals negative 1/3. The answer must be B. Now let's move on to question 9. Which of the following is the solution to the differential equation dy over ds equals e raised to the s minus y with the initial condition y of 0 equals ln 7, right? So we need to separate this one first, right? So we have dy over ds equals e to the s over e to the y, right? So it's going to be e to the y dy equals e to the s ds, right? Now we're going to take n-type derivative both sides, right? So it's going to be e to the y equals e to the s plus c, right? Now we need to use the initial condition right here, right? So s for 0, y for ln 7, right? So we have e to the ln of 7 equals e to the 0 plus c, right? So this guy equals 7 equals 1 plus c. Then c equals 6. Substitute 6 over here, right? So we have equation e to the y equals e to the s plus 6, right? Now we need to solve for y, right? So we're going to take ln both sides, right? So we have y equals ln of e to the s plus 6, right? So the answer must be C. Now let's move on to question 10. The slope field for a certain differential equation is shown above. Which of the following could be a specific solution to that differential equation? Alright, so use the Christmas tree trick. The lines going this way, the slope is positive. Lines going this way, slope is negative, 0 and undefined, right? So normally we're going to check for the 0 slope first, right? So look at the y-axis right here, right? So it tells us that y equals something, right? But s equals 0. dy over ds right here always equals 0, right? Now we're going to take derivative of this one with respect to s, right? So we have dy over ds equals 1 over s. This guy dy over ds equals 3 over 4 s squared. This guy dy over ds equals cosine s. dy over ds equals negative sine s. And dy over ds equals 4s, right? Now when s equals 0, dy over ds equals 0, right? So this one is wrong, right? This is undefined. This guy could be correct. This guy cosine of 0 equals 1, so this one is wrong. This guy could be right, right? For question E, this guy could be right, right? Now next one, we need to eliminate answer joint D because the sign of the slope of the sine or cosine function always alternating, right? Now we look at the diagram of the slope field right here. We observe that dy over ds always greater than or equal to 0, right? No matter the s value is, right? Now look at the second quadrant right here. If s is negative, the slope field is still positive, right? But answer choice E right here, s is negative, the slope is negative, right? So E is wrong, right? Only B correct. No matter s value is positive or negative, you still get the slope field positive, right? Now let's move on to question 1. The region enclosed by the s-axis, the line s equals 3, and the curve y equals square root of s is rotated about the s-axis. What is the volume of the solid generated? Alright, so we're going to sketch the figure. Now, we're going to rotate this one about the s-axis. So, we're going to get the solid something like this. So, to find the volume of this one, we're going to use this method, right? The radius is the distance between the function y equals square root of s and the s-axis, right? So, the volume equals pi, the integral from 0 to 3, right? Of square root of s subtract 0, right? Because x-axis, which means y equals 0, right? Square dx. So it could be pi, the interval from 0 to 3 s dx, right? So it could be pi s square over 2, evaluated from 0 to 3, right? So it could be pi over 2 times 9 subtract 0. It could be 9 pi over 2. The answer must be C. Now question 2. What is the error of the region in the first quadrant bounded by the graph y equals e to the s over 2 and the line s equals 2? Alright, so we're gonna graph this one. So the error is the interval from 0 to 2. Y top subtract y bottom. Y bottom is the x-axis, which means y equals 0, right? Y top is right here, right? So it could be e to the s over 2 dx, right? Now remember, you have the formula antiderivative of e to the as plus b dx is could be 1 over a e to the as plus b plus c. So keep that in mind. A in this situation is could be 1/2, right? So 1 over 1/2 is could be 2, right? E to the s over 2 evaluated from 0 to 2, right? So it's going to be 2 times e to the 2 divided by 2, it could be 1, right? Substitute 0, it could be e to the 0, right? So it could be 2 times e minus 1, right? Or 2e minus 2, right? The answer must be A. Now let's move on to question 3. What is the error enclosed by the curve y equals s cubed minus 8s squared plus 18s minus 5 and y equals s plus 5, right? So we're going to bring up the calculator to graph these two guys, right? Add graphs right here. Input the first function. Enter. It's going to be right here. The second one, you just hit tab. Input s plus 5. Press enter. Now you need to adjust the windows, right? So go to menu number 4, number 1, right? S minimum, S maximum is good. Y minimum good, but Y maximum right here. We need to set this one to 20. And then press OK. It's right here. Alright, so the intersection between these two graphs is the guy right here and the guys right here, right? So we need to find the intersection. We have 3 intersections right here, and right here, right? So you're going to hit menu, number 6, number 4, go to the left, go to the right. We have the first one right here, 1, right? Menu, analyze graph, intersection. The second one is right here, as well 2. And the third one, menu, analyze graph, number 4. And the third one is 5, right? So we have 3 intervals, right? From 1 to 2, the cubic function is above the linear function, right? But from 2 to 5, the cubic function is below the linear function, right? So the error is the interval from 1 to 2. This guy right here, subtract this one, right? Plus the interval from 2 to 5. This guy above this guy, right? So it could be s plus 5. Subtract this guy right here. We need to change the sign, right? So s cubed plus 8s squared minus 18s plus 5 dx, right? So we're gonna print up the calculator. Alright, the best way for you to do it is to store the function, right? So I'm gonna go to home screen, hit calculate. Now I need to input the function FOS first, right? FOS is the first one and GOS is the second one. Hit Control and the button right here. Input the function right here. and then press enter. Now you do exactly the same thing for G of S right here, right? Now you're gonna hit the button right here, input the in row form 1, 2, 2. F of S subtract G of S, right? Plus the second one is gonna be in row form 2 to 5. G of S subtract F of S, and then press Ctrl Enter. It's gonna be 11.833. The answer must be B. Question 4. The region bounded by the x-axis and the part of the graph of y equals cosine x between x equals negative pi over 2 and x equals pi over 2 is separated into two regions by the line x equals k. If the area of the region for negative pi over 2 less than or equal to x less than or equal to k is 3 times the area of the region for k less than or equal to x less than or equal to pi over 2, then k equals how much? Now let's sketch the graph of the function y equals cosine x. You know that the function y equals cosine x has the period 2 pi, right? So this is 0, this one is 2 pi. Half of 2 pi is pi. Half of pi is going to be pi over 2. And half of this one should be 3 pi over 2, right? And you know that the function cosine starts from the maximum is going to be 1, right? The minimum right here should be negative 1. It starts from here, go down to the midline, go down to the minimum, back up to the midline, and go back to the maximum, right? So it's going to be something like this. Now we're going to duplicate this one to the left, and we have this one. So the region should be this guy right here, from negative pi over 2 to pi over 2, right? And the line s equals k should be somewhere right here. This is k, right? Where the area of the regions for negative pi over 2 to k, right, is 3 times the area of the regions for s between k and pi over 2, right? So which is the yellow one equals 3 times the green one right here, right? So we have the integral form negative pi over 2 to k of cosine x dx equals 3 times the integral form k to pi over 2 cosine x dx, right? Now antiderivative of cosine should be sine x evaluated from negative pi over 2 to k equals 3 times sine x evaluated from k to pi over 2, right? So it's going to be sine k subtract sine of negative pi over 2 equals 3 times sine of pi over 2 subtract sine k, right? Now sine of negative pi over 2 equals negative sine of pi over 2. Sine pi over 2 equals 1, right? So this one turns out to be sine k plus 1 equals 3 times sine pi over 2 equals 1. So it could be 3 minus 3 sine of k, right? So it's going to be 4 sine of k equals 2, right? Sine of k equals 1/2, right? Then k equals pi over 6. So the answer must be C. Now let's move on to question 5. Let R be the region in the first quadrant bounded above by the graph of y equals square root of x and below by the graph of y equals x squared. R is the base of a solid whose cross-section perpendicular to the y-axis are squares. Which of the following gives the volume of the solid? Alright, so let's get the figure. The region R is the base of the solid whose cross-section perpendicular to the y-axis, right? So the radius is going to be like this, and the cross-section is the square, right? So it could be something like this. Now, since the cross-section perpendicular to the y-axis, then your integral must be in terms of y, right? So we need to eliminate a and b, right? Now you need to find the error of the square, right? Now the side length is the difference between y equals s squared and y equals square root of s. We need to rewrite two functions right here in terms of y, right? So square both sides to be y squared equals s, right? So s equals y squared, right? And this is s left, right? Now for this one, we need to solve for s. We're gonna take square root both sides, right? So we have s equals plus and minus square root of y, right? But in the first quadrant, s is positive, right? So s should be equals square root of y, right? And this one is s right? Look at this one right here. Now we need to find the intersection between two graphs right here, right? So we just let this guy right here equals this guy, right? So we have s squared equals square root of s, right? We're going to square both sides, so we have s to the 4 equals s, right? We're going to subtract s both sides, so we have s to the 4 minus s equals 0. Factor s out, so we have s times s cubed minus 1 equals 0. Then each of this one must be equals 0, right? So s equals 0 and s equals 1, right? So this one is 1 right here, right? Now we substitute 1 for s into one of the equation right here, right? So we have y equals 1, right? Substitute 0 for s into this one right here. We have y equals 0, right? So this one is 0, this one is 1. We have the integral from 0 to 1, right? S right subtract s left, right? S right is right here. So we have square root of y subtract s left is right here, y squared, right? dy. And this one right here is the side of the square right here. We need to find the error of this one, so we need to square the side, right? The answer must be C. Now let's move on to question 6. Let R be the regions in the first and second quadrants bounded above by the graph y equals 20 over 1 plus s squared and below by the horizontal line y equals 2. R is the base of a solid whose cross-section perpendicular to the x-axis and semicircle. What is the volume of the solid? We are allowed to use the calculator, right? So we're going to graph this guy on the calculator. We're going to hit on, go to home screen, hit graph, input the function right here, right? So we're going to hit the button right here, put the fraction. Analyze y equals 2. So we're going to hit tab, put 2, hit enter. It's going to be right here. Now we need to find the intersection. So we're going to hit menu, number 6, number 4. Go to the left, go to the right. It's going to be -3, right? We're going to do exactly the same thing for the second one, right? The answer is 3 right here, right? So we're going to grab this one right here. Now the cross section perpendicular to the axis. So diameter should be the difference between two graphs right here, right? So we're going to draw the semicircle. It's going to be like that, right? Now we need to find the radius of the semicircle in order to find the area of the semicircle, right? Now the distance from here to here actually the diameter, right? So diameter equals 20 over 1 plus s squared subtract 2, right? So we're going to divide both sides by 2 to get the radius, right? So this one I'm going to multiply by 1/2, right? And this guy actually the radius, right? So the radius square equals 1 over 4 times 20 over 1 plus s squared minus 2, right? And the volume equals the integral from -3 to 3, right? Times a of s ds, right? A of s is the area of the semicircle, right? So it could be v equals the integral from -3 to 3 of pi r squared divided by 2, right? So I have pi divided by 2 in the front, right? Now r squared right here is actually 1 over 4 times 20 over 1 plus s squared minus 2 altogether squared, right? This one must be square. I'm gonna bring up the calculator. Now we're gonna go to home screen, hit calculate, hit the button right here, pick the integral from -3 to 3 of 1 over 4 1 over 4 times pi over 2, it could be pi over 8, right? So I'm going to put pi over 8 here times and press Control Enter. It's going to be 174.268. The answer must be B. Now let's move on to question 7. The function f and g is given by f of s equals 2 square root of s and g of s equals s minus 3. Let R be the region bounded by the s-axis, the graph f and g. The graph of f and g intersect in the first quadrant at the point 9, 6. Which of the following gives the volume of the solid generated when R is revolved about the s-axis? Alright, so we're gonna sketch two functions right here first, right? Alright, so here's the graph of the region R after revolving about the x-axis, right? The yellow one is the initial one, and then after you revolve this one about the x-axis, you get the green one right here, alright? Alright, so in order to calculate the volume of this solid, we need to separate this guy into two portions. The first one, the integral from 0 to 3. This one is the solid one. We need to use the disk method, right? Because we don't see the hole right here, right? And the second one, from 3 to 6 right here, we need to use the washer method because we have the hole in the middle right here, right? Alright, so I need to calculate the volume using the disk method first, right? So V1 equals pi times the integral from 0 to 3 of radius square. The radius is the distance from the function y equals 2 square root of s to the x-axis right here, right? This is the radius. So it's going to be 2 square root of s subtract 0. It's going to be 2 square root of s, and then you square this one, ds, right? So it's going to be 4 pi times the integral from 0 to 3 square root of s squared is going to be s ds, right? So we're done with this one. Now the second one is going to be the integral from 3 to 6. We need to use the washer method, right? So we put pi right here, the outer radius, which means the bigger one right here, right? So it could be the difference between y equals 2 square root of s and the x-axis, right? So it could be 2 square root of s square. Subtract the inner radius, it could be right here, right? So it could be the function right here, s minus 3 subtract 0, right? The x-axis is y equals 0 altogether square. Then we put ds outside, right? I'm gonna simplify this one. It's gonna be pi integral from 3 to 6 for s subtract s minus 3 altogether square ds. right? Finally, v equals v1 plus v2, right? So the answer must be A. Now let's move on to question 8. The function f is given by fs equals lns. Which of the following limits is equal to the error between the graph of fs and the x-axis from s squared 1 to s squared 3? So you know that the integral from a to b of the function f of s ds equals limit when n approaches infinity of the summation k goes from 1 to n of f of s k times delta s k, right? Where delta s k is the width of the rectangle, right? And this one is the height or the length, right? So in this situation, we need to calculate the integral from 1 to 3 of ln s ds, right? So the function f of s is right here, right? Now delta s is given by the formula b minus a over n, right? b equals 3, a equals 1 over n, right? So it could be 2 over n, right? Now f of sk is calculated as f of a plus delta sk times k, right? So it's going to be f of 1 plus 2 over n times k, right? Or f of 1 plus 2k over n. Function fs is lns, right? So it's going to be ln of 1 plus 2k over n, right? So we substitute this guy right here and this guy right here into this guy right here, right? So the integral from 1 to 3 of ln s ds equals limit when n approaches infinity of summation notation k goes from 1 to n of f of sk is going to be right here. ln of 1 plus 2k over n times delta s, which is 2 over n. So the answer must be A. Now let's move on to question 1. A particle moves along the x-axis. The velocity of the particle at time t is given by v of t, and the acceleration of the particle at time t is given by a of t. Which of the following gives the average velocity of the particle from t equals 0 to t equals 8? Alright, so we're going to use the average value theorem for integrals to determine the average velocity of the particles. Alright, so we have average velocity is 1 over b minus a times the integral from a to b of v of t dt, right? So a is 0, b is 8, right? So it could be 1 over 8 minus 0, which is 8. Integral from 0 to 8, v of t dt, right? So the answer must be B. Question 2. Let f prime of s is ln s over e to the s minus cosine s for s between 1 and 6. On what intervals is the function f concave down? So, if the function f is concave down, you know that f double prime of s less than 0, right? Now, if the second derivative less than 0, it tells us that the function f prime is decreasing. So, we're going to print up the calculator. We're going to graph this one. Add graphs. We're going to input this function, right? So, you're going to hit the button right here. Pick the fraction. It's gonna be ln s, right? So press Control E to the s right here. Pick s over e to the s, right? Minus cosine s, right? And press Enter. It's gonna be right here. Now you need to restrict the domain from 1 to 6. Press menu number 4, number 1. S minimum 1. S maximum 6. Press OK. It's gonna be right here. So observe that the function f prime of s is decreasing on this interval, right? So you need to find the maximum of this guy right here. So you're gonna press menu number 6, number 3. Go to the left, go to the right. You get this one right here. 3.11. Right? And the endpoint right here should be 6, right? So the answer must be C. Now let's move on to question 3. Water is pumped into a tank at a rate of RT equals 30 times 1 minus e raised to the negative 0.116 t gallons per minute, where t is the number of minutes since the pump was turned on. If the tank contained 800 gallons of water when the pump was turned on, so this one is the initial amount, right? How much water to the nearest gallon is the tank after 20 minutes, right? So when the pump turns on, t equals 0 minutes, right? So this is t1 and this is t2. So we're going to use the fundamental theorem of calculus in the context, right? So we have the final amount equals initial amount plus interval from t1 to t2 of the rate in the t, right? So it's gonna be 800 plus interval from 0 to 20, right? Of this function right here. Alright, 800 plus, hit the button right here, input the interval from 0 to 20 of 30 times 1 minus e raised to the negative 0.16 ask ds, and then press Control Enter. It's gonna be 1220.1429, right? So this is nearest gallon, which means 1220 gallons. The answer must be D. Now let's move on to question 4. Two particles start at the origin and move along the x-axis for t between 0 4. Their respective position functions given to be s1 equals ln t squared and s2 equals t minus 5 squared. For what value of t does the acceleration of s1 equals the velocity s2? Alright, so basically you just calculate the velocity of this one, right? So velocity equals the first derivative of the position, right? So we're gonna apply the formula ln of u prime. It's gonna be u prime over u, where u equals t squared, right? So it's gonna be 2t over t squared, right? And it's gonna be 2 over t, right? Now a of t equals s double prime of t, right? So it could be negative 2 over t squared, right? Remember, derivative of 1 over t is going to be negative 1 over t squared, right? So keep that in mind. Now for S2, we need velocity only, right? So we have V2 of t equals S2 of t prime, right? So it could be 2 times t minus 5, right? We're going to use the power rule, right? Now, what we need to do is to let this one right here equal this guy, right? So we have A of t, right, equals V2 of t, right? And name this one A1 and name this one V1, right? So this should be A1 equals V2, right? So it's going to be negative 2 over t squared equals 2 times t minus 5, right? Now, we're going to print up the calculator. Put these two guys right here on the same x and y coordinate plane, right? So go to home screen, hit graph right here. The first function is going to be negative, hit the fraction, input 2 over s squared, enter. The second one, hit tab, it's going to be 2 times s minus 5, hit enter. It's going to be right here. Now you need to restrict the domain from 0 to 4, right? So press menu number 4, number 1, 0, 2, 4, press OK. Now you need to adjust the window so that you're going to see the bottom one right here, right? That is your intersection. So press menu number 4, number 1. Now for the y minimum right here, I put negative 16, right? Press OK. It's going to be right here, right? So you need to find the intersection right here. So press menu number 6, number 4. Go to the left, go to the right. The answer is 0.47, right? So it's going to be B. Question 5. The average value of the function fs equals cosine s squared on the closed interval 0 to is. Alright, so again, we have the average value of this function is 1 over b minus a times integral from a to b of f of s ds, right? This is a and this is b. So it's going to be 1 over 2 integral from 0 to 2 cosine of s squared ds, right? So we're going to print up the calculator. Go to home screen, hit calculate. Alright, I'm going to copy this one down over here. Alright, so it should be 1 over 2, right? Press the button right here. Input the fraction 1 over 2. Integral from 0 to 2 of cosine s squared, right? Then press Control Enter. It's going to be 0.2307, right? So it's going to be A. Now remember, cosine of s squared different from cosine square of s, right? But this guy and this guy, same thing. So keep that in mind. Now let's move on to question 6. A person whose height is 6 feet is walking away from the base of a straight line along a straight path at a rate of 4 feet per second. Alright, so the distance from here to here is going to be 6 feet, right? And the distance from here to here, I call this one s, right? So then I have ds over dt equals 4 right here, right? If the height of the straight line is 15 feet, so I have 15 feet right here, right? What is the rate at which the person's shadow is lengthening? So, which means this guy right here, and name this guy as y, right? So the question wants you to find dy over dt equals how much, right? Now we're going to use the similarity in the right triangle, so we're going to connect this guy right here. Alright, so we have what? 6 over 15, right, equals y over s plus y. Now I'm going to cross multiply, so I have 6s plus 6y equals 15y, right? So then I'm going to subtract 6y both sides, right? So I have 6s equals 9y, right? Now I'm going to take derivative both sides with respect to t, right? So I have 6 ds over dt equals 9 dy over dt, right? But ds over dt equals 4, so I have 6 times 4 equals 9 times dy over dt, right? So dy over dt equals 24 divided by 9, right? So I'm going to print up the calculator. 24 divided by 9. Press Ctrl Enter. It's going to be 2.667, right? So the answer must be B. Let's move on to question 7. If C satisfies the conclusion of the mean value theorem for f of s equals inverse sine of s on the interval 0 to 1, then C is. So the first thing you need to do is to take the derivative of this one, right? So f prime of s equals 1 over square root of 1 minus s squared. Now, the mean value theorem say f prime of c equals f of b minus f of a over b minus a, where a equals 0, b equals 1. Now I'm going to substitute c for s into this formula, right? So I have 1 over square root of 1 minus c squared, right? Equals f of b. I have the function f right here, right? B equals 1 right here, right? So I have inverse sine of 1, right? Subtract inverse sine of 0 over 1 minus 0, right? So it's going to be 1 over square root of 1 minus c squared equals inverse sine of 1 is going to be pi over 2, right? Inverse sine of 0 is going to be 0 over 1, right? So it's going to be pi over 2, right? So this guy is the same thing as square root of 1 minus c squared equals 2 divided by pi, right? I just flip both sides, right? And then I'm going to square both sides. So it turns out to be 1 minus c squared equals 4 divided by pi squared, right? And then c squared equals 1 minus 4 over pi squared, right? And then c equals square root of 1 minus 4 over pi, right? Remember, c must be between 0 and 1, right? So actually this guy has two values, positive and negative. We need to take the positive value, right? So we're going to print up the calculator. Press Ctrl and the button right here. It's going to be 1 minus 4 divided by pi square, right? Press Ctrl Enter. It's going to be 0.771, right? So the answer must be B. Let's move on to question 8. A particle moves along a line so that its acceleration for t greater than or equal to 0 is given by a of t equals t plus 3 over square root of t cubed plus 1, right? If the particle's velocity at t equals 0 is 5, what is the velocity of the particle at t equals 3? Alright, so we're going to use the fundamental theorem of calculus in context, right? So we have the final velocity, which means v of 3 equals v of 0, right? Plus the interval from 0 to 3 of v prime of t dt. Now v prime of t actually I of t right here, right? So we just substitute value, right? V of 0 equals 5 right here. plus integral from 0 to 3 of t plus 3 over square root of t cubed plus 1 dt, right? So we're gonna print up the calculator, press the button right here, hit the integral right here, right? It's gonna be from 0 to 3 of this guy, right? Hit the button right here, input the fraction. It's gonna be s plus 3 over square root of s cubed plus 1 ds. And don't forget to add 5, right? Press Ctrl Enter. It's gonna be 11.71, right? So it's gonna be E. Now let's move on to question 9. Given fs equals this guy, we need to find the second derivative of f at s equals 1, right? So before we're gonna calculate the second derivative, we need to calculate the first derivative, right? So we have f prime of s. You just print s over here, right? So we have, so then we need to calculate f double prime, right? And then we calculate f double prime of 1, right? So we just print up the calculator. You're gonna press menu, calculus, derivative at the points right here, right? Variable should be s, the value should be 1, right? Press OK, right? So I just input s squared, Control Enter. It's gonna be 0.2. The answer must be B. Now let's move on to question 10. The area of the region bounded by the curves y equals e to the negative s, y equals ln s, and the line s equals 1. Alright, so we're gonna print up the calculator. We're gonna grab these two guys, right? So we're gonna go to home screen, hit graph right here, hit tab, go back to the first function right here, clear this one. Now I'm going to put e to the negative s, press enter, right? And the second one, I'm going to hit tab, go to F2 right here. I hit clear this one. It should be LNS, right? So hit control and the button right here, input as, press enter. It's going to be right here, right? Now I need to find the intersection right here and I'm done, right? So I hit menu, number, set number 4, go to the left, go to the right, it's going to be 1.31, right? Here's the graph, this is 1, right? So the line s equal 1 should be right here, right? And the area of the region we need to calculate is right here. And this guy is on the top, this guy on the bottom, right? So the area should be the integral from 1 to 1.31 of y top, which means e to the negative s, subtract y bottom, which is this guy right here, ds, right? So we're gonna print up the calculator, go to home screen, hit calculate, right? Hit the button right here, input the integral from 1 to 1.31, right? Of, and then press Control Enter. It's gonna be 0.0543, right? So the answer must be B. Now let's move on to question 11. Let g of s be the function given by g of s equals this guy. Which of the following must be true? Number 1, g is decreasing on 0, 1. Number 2, g is decreasing on 1, 2. Number 3, g of 2 greater than 0. Alright, so when it's come to increasing or decreasing, take derivative of this one, right? So g prime of s equals print s over here, right? So we have e to the s times s squared minus 1, right? Now we're going to graph this one to see if the function is increasing or decreasing within this interval, right? Add graphs. So it's going to be e to the s, it's going to be right here. Remember, this one is the function of G', right? So the interval 0 to 1 is right here. So within this interval, you see that the function G' is below the axis, right? It tells us that G' less than 0 within this interval. So the function G is decreasing. So this is right? Now G is decreasing on 1, 2. That's incorrect, right? 1 right here. 2 is right here. Right? It's above the axis. It should be increasing. So that's wrong, right? So number 2 wrong. Number 3, you have 2 different ways to do it. So you calculate G of 2, right? Which means S equal 2, right? It's going to be integral from 0 to 2, right? E of t times t squared minus 1 dt, right? You put this on the calculator, it's actually positive, right? Or you can do this way. You look at the portion above the axis right here. G of 2 is right here, right? And the portion below the axis right here. You see that? The portion above the axis is bigger than the portion below the axis, which means G of 2 is positive, right? So the answer must be D. Now let's move on to question 12. Let R be the region in the first quadrant enclosed by the graphs y equals x to the 4 plus 1 and y equals x plus 16. The volume of the solid generated by revolving R about the x-axis is. Alright, so we're going to graph these two guys on the graphing calculator, right? So we're going to hit tab, go back to the F1, clear this one, input the new one, which is x to the 4 plus 1, right? Press enter. It's going to be right here. And the second one, y equals x plus 16. So hit tab, x plus 16, press enter. It's going to be right here, right? Look at this one right here. The region in the first quadrant only, right? So this one is what we need to focus on. Alright, so when we revolve this one about the x-axis, this is axis of revolution, right? It's gonna be something like this. Now we have the hole right here, so then we need to use the washer method. Outer radius is this guy. Subtract inner radius is this guy right here, right? So we need to find the intersection right here first, right? This guy is 0 already, right? So we're gonna print up the calculator, press menu number 6, number 4, go to the left, go to the right. It's gonna be 2.03, right? So it should be the integral from 0 to 2.03, right? Upper function, which is y equals x plus 16. Subtract the lower function. The lower function is the axis of revolution right here, which is y equals 0, right? So subtract 0 altogether square. This is the outer radius. Subtract the inner radius, which is the function right here, x to the 4 plus 1, right? So it can be x to the 4 plus 1, subtract the lower function, which means subtract 0 altogether square ds, right? Don't forget to multiply by pi, right? This guy actually the volume of the solid using the cross section, where the cross section is the circle, right? Hit calculate, right? I'm gonna copy this one down over here. And then press Ctrl Enter. It's gonna be 1594, right? The answer must be D. A function f is continuous on the closed interval 2 to 5. And f of 2 equals 17, f of 5 equals 17. Which of the following additional condition guarantees there is a number C in the open interval 2 to 5 such that f prime of c equals 0. Now we look at this guy right here. If this guy different from this guy, we think about the mean value theorem. But this guy and this guy, the same thing, think about the Rolle's theorem. Right? The Rolle's theorem is the special case of the mean value theorem, where f of a equals f of b. Right? So in order for this guys right here to occur, the function must be differentiable on the open interval, right? The mean value theorem or the Rolle's theorem say that the function must be differentiable, right? So the answer must be C. Now question 8. The function f is continuous on this closed interval. The graph of f shown above consists of 5 line segments. What is the average value of the function f on the interval -4 to 4? So remember the average value formula is given by, so this one is A, this one is B, right? So it should be 1 over 4 minus -4, which is 8, right? Interval from -4 to 4 of f of s ds, right? So it's going to be 1 over 8, right? So basically, we need to calculate the error under the curve of the function f of s, right? So from -4 to -2, we have the triangle, right? Base times height divided by 2, right? So it's going to be 2 times 1 divided by 2, right? Now for this guy right here, it's going to be 2 times 3 divided by 2, right? But this guy below the axis, so it should be negative, right? From 1 to 3, this is a right triangle, right? And it's above the axis, right? So base is 2, height is 2, right? So plus 2 times 2 divided by 2. And the last one is going to be the trapezoid, right? The base is 1 right here, the base 2 is 2 right here, and the height is 1 right here, right? So the answer should be 3 over 16. So should be B. Question 9. Given f of s equals 2 over s, then we need to calculate f prime of s, right? So remember you have the formula derivative of e to the u. It's going to be u prime times e to the u, right? U in this situation is going to be 2 over s, right? So if you take derivative of 2 over s, it's going to be -2 over s squared, right? So this guy turns out to be -2 over s squared times e to the 2 over s, right? So the answer must be D. Now let's move on to question 10. Let g be a continuous function of the closed interval -1 to 3. If g of -1 equals -10, g of 3 equals 6, which of the following are guaranteed? Alright, so look at this one. We're going to think about the intermediate value theorem, right? Because the function only continuous, we need to eliminate the wrong answer, right? It should be B and C right here wrong because the IVT does not deal with the derivative, right? Answer choice A. G of 0 equals 0, we don't know it, right? It's not given. Now answer choice D. G of C equals 4 for some C in the interval -1 and 3. Yes, that's correct, right? C is inside the domain right here, and the output right here must be between -10 and 6, right? So the answer must be D. Now let's move on to question 11. The polynomial function f has selected values of its second derivative given in the table above. Which of the following statement must be true? A. The function f is increasing on the interval 0 to 2. Alright, you know that the increasing or decreasing function depends on the first derivative, not the second derivative, right? So look at the table right here. We only have the second derivative, so we have no conclusion, right? Similar, B is wrong, right? Now answer choice C. The function f has a local maximum at s equal 1, right? So we need f prime of 1 equals 0, right? And we need f double prime of 1 should be less than 0, right? We only know f double prime of 1 equals 0. So this information alone tells us nothing about the maximum, right? So answer choice C, not true. Now answer choice D, the graph of f has a point of inflection at s equal 1, right? A point of inflection at s equal 1 requires that concavity actually changes at s equal 1, right? Now, although f double prime of 1 equals 0, right? But we not guarantee the size change occurs exactly at 1, right? It could occur elsewhere between 0 and 2. So keep that in mind. The answer choice D is wrong. Now answer choice E, the graph of f changes concavity in the interval 0 to 2. Alright, now we're going to check f double prime of 0 equals 5 right here, which is positive, right? And f double prime of 2 equals negative 7 right here, which is negative, right? So since the second derivative of the function f is continuous and changes from positive to negative between 0 to 2, then the intermediate value theorem guarantees the function f double prime must change size somewhere in the interval 0 to 2. That means the graph of the function f changes concavity on that interval. So the answer choice E must be true. Now question 12. We need to calculate the antiderivative of 3s plus 1 to the fifth ds. Alright, so we can apply the formula antiderivative of u to the n du. It's going to be u to the n plus 1 over n plus 1 plus c, right? Make sure this guy and this guy must be the same. Now we look at this one. This is 3s plus 1. This is s. We cannot apply, right? So we just rewrite this one as antiderivative of 3s plus 1 to the fifth, right? And instead of s, we put d of 3s plus 1, right? If we take derivative of this one, actually is 3, right? So we just multiply by 3. We need to divide by 3 right here, right? Now this guy and this guy, the same thing. We can apply the formula right here, right? So we have 1 over 3 times 3s plus 1 to the 6 over 6, right? So it could be 3s plus 1 to the 6 over 18, right? Don't forget to add constant c. The answer must be A. Now you could solve this problem using the second way, that is use equals 3s plus 1. Alright, I'm going to leave this one for you to practice. Now question 13. Which of the following definite intervals has the same values as this guy? Alright, so basically you just use substitution, right? So let's use be this guy right here. 3 minus s. Check derivative both sides, so it could be du equals negative ds, right? So then ds equals negative du, right? Now for this one right here, we need to change the upper bound and lower bound. The new one, u equals, substitute 1 for s over here, we have 2. U equals 1, right? So this guy right here becomes the integral form 2 to 1, right? Of 1 over u du. And don't forget the negative side right here, right? So I just flip the upper bound and lower bound, and then this guy becomes positive, right? So the answer must be E. Now let's move on to question 14. The temperature of a room in degrees Fahrenheit is modeled by the function H a differential function of the number of minutes after the thermostat is adjusted. Of the following, which is the best interpretation of h' of phi equals 2? Answer choice A. The temperature of the room is 2 degrees Fahrenheit 5 minutes after the thermostat is adjusted. Now, when we talk about the first derivative, we talk about the rate. The rate is increasing or decreasing, right? So answer choice A is wrong, right? Because it doesn't mention the rate, right? Now answer choice B. The temperature of the room increases by 2 degrees Fahrenheit during the first 5 minutes after the thermostat is adjusted. No, right? We need to say that the temperatures of the room is increasing at a rate of 2 degrees Fahrenheit per minute, right? So answer choice B is wrong. Answer choice C, the temperatures of the room is increasing at a constant rate. 2 over 5, this is wrong, right? Answer choice D, the temperature of the room is increasing at a rate of 2 degrees Fahrenheit per minute. 5 minutes after the thermostat is adjusted. The answer must be D. Now let's move on to question 1. We need to calculate the integral from 1 to e of s squared plus 1 over s, right? So, because degree on the numerator is greater than degree on the denominator, we just do long division, or we just separate this one, right? So it's going to be the integral from 1 to e of s plus 1 over s ds, right? So it's going to be s squared over 2 plus ln absolute value of s evaluated from 1 to e, right? So it's going to be e squared over 2 plus ln absolute value of e subtract 1 over 2 plus ln of absolute value of 1, right? So it's going to be e squared over 2 plus 1, right? Minus 1 half. This guy equals 0, right? So it's going to be e squared plus 1 over 2, right? So the answer must be B. Now question 2. We need to calculate the integral from 1 to infinity of s times e to the negative s squared ds. So this guy, we can use the u substitution, right? So we have u equals negative s squared. Then du equals negative 2s ds. Then s ds equals negative 1 half du. So then the antiderivative of s e to the negative s squared ds becomes negative 1 half antiderivative of e to the u du, right? So this guy becomes negative 1 over 2 e to the u, right? So substitute this guy back for u, right? So it could be negative 1 half e to the negative s squared, right? This guy right here becomes limit of the integral from 1 to a of s e to the negative s squared ds when a approaches positive infinitive equals limit of negative 1 over 2 e to the negative s squared evaluated from 1 to a. So it's going to be limit of negative 1 over 2 e to the a squared plus 1 over 2 times e when a approaches infinity. Now when a approaches infinity, this guy approaches 0, right? So we only have 1 over 2e left, right? The answer must be B. Now question 3. We need to use u substitution, right? So we're gonna let u be s cubed. Then du equals 3s squared ds, right? And then s squared ds equals 1 over 3 du, right? So this guy becomes the antiderivative of cosine u du, and don't forget to put 1/3 right here, right? So it's gonna be 1/3 sine u plus c, right? But u equal this guy, right? So it could be 1/3 sine of s cubed plus c, right? The answer must be B. Question 4. The graph of a piecewise linear function f is given. What is the value of this guy, right? So we just separate this guy. It's going to be the integral from -1 to 9 of f of s ds. Don't forget to put 3 in the front. Plus 2 times the integral from -1 to 9 ds, right? Now, the integral from -1 to 9 is going to be the error under the curve, right? So we need to calculate the error of this trapezoid. The error of the right triangle right here, right? So it's going to be 3 times base 1 is 1, 2, 3. Base 2 is 1, 2, 3, 4, right? So 3 plus 4 times the height is going to be 1 right here, divided by 2. Plus this one, the height is 2. The base is 1, 2, 3, 4, 5, 6, right? So it could be 6 times 2 divided by 2. Plus 2s evaluated from -1 to 9. So it's going to be 27.5. Now question 5. If dy over dt equals this guy, if y equals 12, t equals 0, what is the value of y when t equals 10? Alright, so this guy actually y prime of t equals e to the 0.2 t, right? So we need to use the fundamental theorem of calculus, right? The final amount equals initial amount plus the integral from t1 to t2 of f prime of t dt, right? So the final amount, which means y of 10, right, equals y of 0 plus the integral from 0 to 10 of y prime of t dt, right? So we substitute value y of 0 equals 12 right here, plus integral from 0 to 10 of e to the 0.2 t dt, right? So previously we have the antiderivative of e to the a s plus b ds is going to be 1 over a e to the a s plus b plus c, right? So it's going to be 12 plus 1 over 0.2 e to the 0.2 t evaluated from 0 to 10, right? So it's going to be 12 plus 1 over 0.2 times e to the 0.2 times 10. Subtract e to the 0.2 times 0, right? So we're going to simplify this one. It's going to be 12 plus 1 divided by 0.2 is going to be 5, right? Times e squared minus 1, right? So it's going to be 5e squared plus 7. This one is the final answer. The answer must be C. Now question 6. Which of the following limits is equal to this guy? Alright, so we know that the function f of s is e to the s, right? The interval a, b equals -3, 1, right? So we have delta s equals b minus a over n. It's going to be 1 minus -3 over n, right? So it could be 4 over n, right? So we need to eliminate b and c, right? Delta s is right here. Now we need to calculate the length of the rectangle. It's going to be f of ci, right? And this guy actually f of a plus k delta s, right? Now it's going to be f of a equals negative 3 plus k times 4 over n, right? So we're going to simplify. It's going to be f of negative 3 plus 4k over n, right? So the function f of s is right here. It's going to be e to the negative 3 plus 4k over n. We need to rewrite this guy as the limit notation, right? So it will be limit when n approaches infinity, put the summation notation right here. K goes from 1 to n of the length times the width, right? The length is right here. E to the negative 3 plus 4k over n, right? Times the width is going to be right here. 4 divided by n, right? So the answer must be D. Now let's move on to question 7. If the integral from 1 to 3 of f of s plus 5 dx equals 7, then what is the value of this guy, right? So first we need to find the integral from a to b of f of s first, right? So we look at this one right here. We have two different ways to do it. The first way we can use substitution, u equals s plus 5, right? The second one, we can do this one faster by adding 5 into this guy right here. And this guy go back to f of s, right? So it's going to be the integral from 5 plus 3 is going to be 8. 5 plus 1 is going to be 6. And this guy becomes f of s, right? And it's still 7, right? Now this guy right here can be written as the integral from 6 to 8 of f of s ds plus 2 integral from 6 to 8 ds, right? But this guy right here equals 7 right here, right? So 7 plus 2s evaluated from 6 to 8, right? So it could be 7 plus 2 times 8 minus 6 is going to be 11. The answer must be D. Now let's move on to question 8. A rain barrel collects water off the roof of a house during 3 hours of heavy rainfall. The height of the water in the barrel increases at a rate of RT equals this guy feet per hour, where T is the time in hours since the rain began. At time T equals 1 hour, the height of the water is 0.75 foot. Which of the following is the best interpretation of the integral from 1 to 2 of this guy? So this guy is actually the fundamental theorem of calculus, right? Remember we have the integral from a to b of f prime of s ds is going to be f of b minus f of a, right? The left hand side the integral from a to b of the rate. The right hand side should be the change, right? So the change in height, right? So we look at the answer choice right here. Only B correct, the change in height of the water in barrel, right? Now let's move on to question 9. We need to use u substitution, right? So u equals s squared minus 3. Then du equals 2s ds, right? Then we have s ds equals 1/2 du, right? We need to create a new upper bound and lower bound, right? So the old one s equals -1, s equals 4. The new one u equals substitute -1 for s over here. It's going to be -2. Substitute 4 for s over here. It's going to be 13, right? So this guy becomes the integral from -2 to 13, right? S ds equals 1/2 du. I put 1/2 in the front, right? And this guy is going to be u to the 5th du, right? So the answer must be C. Question 10. For what value of k, if any, is this guy equals 1, right? So we look at this one, we need to use the integration by part. So remember we have L, I, A, T, E, right? Now we look at this expression over here. We don't see log, right? So we eliminate this one. We don't see the inverse strict, right? Eliminate this one. But we have the algebraic right here, s, right? So we have let u equals s, then du equals ds, right? dv equals e to the negative 2s ds, right? And then v equals negative 1/2 e to the negative 2s. So then this guy right here becomes limit of the integral from 0 to b of k s e to the negative 2s ds when b approaches infinity equals limit when b approaches infinity of, we have the formula antiderivative of u dv equals u times v minus antiderivative of v du, right? So we have u times v, this guy times this guy, right? So it could be negative 1 over 2 s e to the negative 2 s evaluated from 0 to b, right? Minus the integral from 0 to b of v du, right? So it could be this guy times this guy. So we have negative 1/2 right here. It becomes positive 1/2, right? E to the negative 2s ds, right? So it's going to be limit when b approaches infinity of k times substitute b for s, right? It's going to be negative 1 over 2 b times e to the negative 2b, right? Now for this guy, take antiderivative of this one. It's going to be negative 1/2, and 1/2 right here is going to be negative 1 over 4, right? E to the negative 2s evaluated from 0 to b, right? And it's going to be limit when b approaches infinity of k times negative 1 over 2 b e to the negative 2b minus substitute b for s is going to be 1 over 4, right? Times e to the negative 2b minus e to the 0, right? So it's going to be limit when b approaches infinity of k times negative b over 2 times e to the 2b, right? Minus 1 over 4 e to the 2b plus 1 over 4. So we have limit when b approaches infinity of negative b over 2 e to the 2b equals limit when b approaches infinity of negative 1 over 4 e to the b, right? So when b approaches infinity, this guy approaches 0, right? Similarly, this guy approaches 0, right? So we only have 1 4 left, right? So this guy becomes k times 1 4, which means k over 4, right? But this guy equals 1, right? So we have k over 4 equals 1. Then k equals 4, right? So the answer must be C. Question 11. We need to find the integral from 1 to e of ln(s) over sq ds, right? So this guy is the same thing as integral from 1 to e of s to the negative 3 ln s ds, right? So we need to use the integration by part. ln s, right? Then du equals 1 over s ds, right? dv equals s to the negative 3 ds, right? Then v equals negative 1 over 2s squared, right? So this guy right here becomes u times v. It's going to be this guy times this guy, right? evaluated from 1 to e minus v du, right? So you have negative side here becomes positive, right? Du right here. So it's going to be integral from 1 to e 1 over 2 s cubed ds, right? So it's going to be negative ln e over 2e squared. Subtract right here becomes positive, right? ln 1 over 2 times 1 squared, right? Plus the integral from 1 to e. Now I'm going to bring 1/2 to the front. And this one right here I bring to the top. I'm going to use the power rule, right? ln 1 equals 0, right? ln e equals 1, right? So the first one becomes negative 1 over 2e squared, right? Now this one becomes 1/2 times negative 1 over 2s squared evaluated from 1 to e, right? So it's going to be negative 1 over 2e squared minus 1 over 4 times 1 over e squared minus 1 over 1, right? Now I'm going to simplify this guy. So it could be negative 1 over 2e squared minus 1 over 4e squared plus 1 over 4. Now the LCD is 4e squared, right? So I have 4e squared. The top should be negative 2 minus 1 plus e squared. So it could be e squared minus 3 over 4e squared. This one is the final answer. The answer must be B. Question 12. Let f be a differentiable function such that which of the following could be LS? Alright, so we're going to use the integration by part, right? Again, right over here, L I A T E, right? Let u equals f of s, then du equals f prime of s ds, right? dv equals sine s ds, then v equals negative cosine s, right? So it's going to be this guy times this guy, right? So it could be negative cosine s f of s minus v du, right? This guy times this guy. So you have plus cosine s f prime of s ds. The first guy right here and this guy right here the same, right? Now this guy right here we have cosine s ds, it could be right here. So f prime of s equals 4s cubed, right? Take anti-derivative both sides with respect to s, right? So we have f of s equals 4s to the 4 over 4, right? So then it's going to be s to the 4, right? The answer must be E. Question 13. Which of the following statement about the integral from negative 1 to 1 of 1 over s squared ds? Alright, so observe that within the interval negative 1 to 1, the function f of s is 1 over s squared is undefined at s equals 0, right? So then the function f of s right here has the vertical asymptote at s equals 0, right? This guy can be written as the integral from negative 1 to 0 of 1 over s squared ds plus the integral from 0 to 1 of 1 over s squared ds, right? So we're going to use the limits, right? So limit of the integral from negative 1 to a when a approaches 0 minus, right? Of 1 over s squared ds plus limit of the integral from b to 1 of 1 over s squared ds when b approaches 0 plus, right? So it's going to be limit when a approaches 0 minus of negative 1 over s evaluated from negative 1 to a. plus limit when b approaches 0 plus negative 1 over s evaluated from b to 1, right? Limit when a approaches 0 minus negative 1 over a subtract 1, right? Plus limit when b approaches 0 plus negative 1 plus 1 over b. So when a approaches 0 minus, this guy right here does not exist, right? This guy right here does not exist, right? So the answer must be D. Now let's move on to question 14. The table above gives value of f prime, g prime for selected value of s. If we have this guy, then this guy equals how much, right? So basically, we need to use the integration by part. Let u be f of s, then du equals f prime of s ds, right? dv equals g prime of s ds, then v equals g of s, right? This guy right here becomes u times v is going to be this guy and this guy, right? f of s, g of s evaluated from 0 to 1 minus v du, this guy times this guy, right? So it can be in row form 0 to 1 of f prime of s times g of s ds, right? Now we need to substitute 1 for s, right? So we have f of 1 times g of 1 subtract f of 0 g of 0, right? This guy right here actually 5 right here, right? Subtract 5, so it could be f of 1 is going to be 4, g of 1 is going to be 3, 4 times 3 equals 12. Subtract f of 0 to g of 0 negative 4, so it could be plus 8 minus 5, so it could be 15, right? The answer must be E. Now let's move on to question 15. We need to calculate the integral from 1 to 3 of this one, right? Observe that the degree on the numerator is bigger than the degree on the denominator. We need to do long division, right? So we're going to put this one on the side. So 3s cubed divided by s is going to be 3s squared multiplied that. So it will be 3s cubed, right? 3s squared times 5 is going to be 15s squared, right? You subtract, it's going to be 0, right? Bring s plus 9 down. S divided by s could be 1, right? So it could be s plus 5. Subtract, it could be 4, right? So this one can be written as the integral from 1 to 3 the quotient right here. 3s squared plus 1 plus the remainder is 4 divided by the divisor right here. S plus 5 altogether ds. Right? So antiderivative of this one is going to be s cubed plus s, right? This guy right here is going to be 4 times ln of absolute value of s plus 5, right? Altogether evaluated from 1 to 3, so it could be 3 cubed, it could be 27 plus 3 it could be 30, right? So we have 30 plus 4 ln of 8 subtract 2 plus 4 ln of 6. So it could be 30 subtract 2 could be 28 plus 4 ln 8 subtract 4 ln 6. So it could be 28 plus 4 times ln 8 subtract ln 6, right? So the answer must be 8. Now question 16, we're going to use partial fraction decomposition. So we have 7s over 2s minus 3 times s plus 2 equals, look at the bottom right here, we have two linear factors, right? So the top should be a over 2s minus 3 plus b over s plus 2, right? So the LCD is 2s minus 3 times s plus 2, right? So this guy can be written as the same LCD, right? 2s minus 3 times s plus 2, a times s plus 2 plus b times 2s minus 3, right? Now look at this guy, the bottom, the same, right? We just equate the numerator, right? So we have a times s plus 2 plus b times 2s minus 3 equals 7s, right? Now, to solve for a, we just let s equals 3 over 2, right? So that b is gone, right? So we substitute 3 over 2 for s into this guy, so we have a times 3 over 2 plus 2 equals 7 times 3 over 2. So it's going to be 7 over 2 times a equals 21 over 2. So a equals 3, right? Now to solve for b, we just let s equals negative 2, right? So then we have negative 7, b equals negative 14, b equals 2. Alright, so we go back over here, a equals 3, b equals 2. Now we're going to take anti-derivative both sides. 3 times antiderivative of 1 over 2s minus 3 antiderivative of du over u equals absolute value of u plus c, right? Make sure this guy must be the same. Now the bottom is 2s minus 3. This is ds, right? So I can rewrite ds as d of 2s minus 3, right? So if I take the derivative of this one, I get 2, right? So I need to divide by 2 right here, right? Plus, I do the same thing for this guy, right? So it's going to be 3 over 2 ln of absolute value of 2s minus 3 plus 2 ln absolute value of s plus 2, right? Plus c. So the answer must be A. Now let's move on to question 17. We need to use u substitution, so we let u equals sine s, du equals cosine s ds, right? Look at the top right here, right? Now we need to change the upper bound and lower bound, right? So s equals 0, s equals pi over 2, then u equals sine of 0 equals 0, sine of pi over 2 equals 1. So this guy right here becomes the general form 0 to 1 of du over 1 plus u squared, right? So it's going to be arctangent u evaluated from 0 to 1. It's going to be arctangent of 1 subtract arctangent of 0. Arctangent of 1 equals pi over 4. Arctangent of 0 equals 0. So it could be pi over 4. The answer must be B. Question 18. We need to find the integral from 0 to 4 of f(s) ds, where f(s) is the b square function from 0 to 4, right? So this guy actually the error under the curve, right? So it could be, look at the s value right here, 0, right? And the discontinuous point is 2 right here, and the final one is 4 right here, right? So it could be integral from 0 to 2 of f of s ds plus the integral from 2 to 4 of f of s ds, right? The integral from 0 to 2, actually the trapezoid right here, right? Base 1 is 1, base 2 is 5, the height right here is 2, right? And since this one is above the axis, so it's going to be positive, right? So it will be 1 plus 5 times 2 divided by 2. The second one is going to be the rectangle right here, right? The length is 3, the width is 2. And since this one is below the axis, so it will be negative, right? So subtract 3 times 2 is going to be 0. The answer must be B. The question 19. We need to calculate the integral of this one, right? So basically, this one can be written as, look at the bottom right here, I have e to the 2s, right? So I can rewrite the top as 1 plus e to the 2s subtract e to the 2s, right? Over 1 plus e to the 2s ds. So it's going to be the antiderivative of 1 plus e to the 2s over 1 plus e to the 2s subtract the antiderivative of e to the 2s over 1 plus e to the 2s ds, right? Now the first one is going to be antiderivative of ds, right? Minus antiderivative of e to the 2s over 1 plus e to the 2s ds, right? So for this one, it's going to be s, right? Now e to the 2s ds, I can rewrite this one as d of 1 plus e to the 2s, right? Over 1 plus e to the 2s, right? Now if I take the derivative of this one, actually I get 2 e to the 2s ds, right? But I only have e to the 2s ds right here, so I need to divide by 1/2 right here, right? So I put 1/2 in the front, so things doesn't change, right? So then I can apply the formula du over u is going to be ln absolute value of u plus c, so keep that in mind. So it's going to be s minus 1 over 2 ln absolute value of 1 plus e to the 2s, right? Plus c, so the answer must be D. Or you can use substitution for this guy right here, right? You just let u equals 1 plus e to the 2s, and then you still get the same answer, right? Question 20. The antiderivative of 1 over s squared minus 10s plus 34, right? So if you see the quadratic on the bottom, the first thing you need to do is to factor this one, right? So we need to find two numbers multiply equals 34 add up to negative 10. It is impossible, right? The second one you need to think is to do complete square, right? So this guy can be written as antiderivative of ds over s squared minus 10s, right? Plus, put a blank right here, plus 34, right? Now remember, you have a squared minus 2ab plus b squared is to be a minus b altogether square, right? So in order to find the third term right here, you're gonna take 10 right here, the middle term, divide by 2 and square is to be 5 square, right? So you just literally add 5 square, you need to subtract 5 square right here, right? So it's going to be antiderivative of ds over the first three terms right here becomes a complete square. S minus 5 altogether square, right? Plus 34 subtract 25 is going to be 9, right? But 9 is 3 squared, right? So antiderivative of du over u squared plus a squared is going to be 1 over a, right? Arctangent of u over a plus c, right? So look at the bottom right here and look at the top right here. This guy right here and this guy right here must be the same, right? So I can rewrite ds as the antiderivative of d of s minus 5 over s minus 5 square plus 3, right? Make sure this guy and this guy must be the same, so be careful. Alright, so it's going to be 1 over 3, right? Arctangent of s minus 5 over 3 and then as c, right? So the answer must be C. Question 21. Alright, degree on the numerator is less than degree on the denominator. Think about fraction decomposition, right? Now we need to find two numbers multiply equal to add up to 3, so it will be 5s plus 8 it turns out to be 1 and 2, right? And then it's going to be a times s plus 2 plus b times s plus 1, right? Now you just equate the numerator because denominator both the same, right? So I'm gonna let s equals negative 2 to eliminate a, right? So then I substitute negative 2 for s over here, I solve for b, right? So I have negative b equals negative 2, and then b equals 2. Now I'm gonna let s equals negative 1 to eliminate b, right? And to solve for a, right? So we have a equals 3, right? So I'm gonna go back over here. Now I'm gonna take the integral from 0 to 1 of this one ds. It's gonna be the same thing for this guy, right? Now d of s plus 1 actually ds, right? So this guy becomes 3 ln of absolute value of s plus 1 evaluated from 0 to 1 plus 2 ln of absolute value of s plus 2 evaluated from 0 to 1, right? Substitute 1 for s is going to be 3 ln 2. Substitute 0 for s is going to be ln 1 is going to be 0. Substitute 1 for s is going to be plus 2 ln 3. Substitute 0 for s is going to be minus 2 ln 2, right? So it's going to be ln 2 plus 2 ln 3. Now we look at the answer chart right here, we don't see it. So we need to manipulate the log a little bit, right? So we have ln 2 plus ln of 3 squared. You can bring 2 back over here, right? Remember we have a log base b of c. You can bring a back over here. So it could be log base b of c power of a, right? So it could be ln 2 plus ln 9, right? Now you have log base a of b plus log base a of c. It's going to be log base a of b times c. So it's going to be ln of 2 times 9. It's going to be ln of 18, right? The answer must be C. Question 22. We need to use the fundamental theorem of calculus, right? This one is the initial one. This one is the final one, right? So f of 2 equals f of negative 1 plus the integral from negative 1 to 2 of f prime of s ds, right? So it's going to be 2.4 plus the integral from negative 1 to 2 of square root of 9 minus s square ds, right? Now since we are allowed to use the calculator, so we're going to print up the calculator. Add calculator 2.4 plus, hit the button right here, input the integral from negative 1 to 2 of, hit the square root 9 minus s squared ds. Press Ctrl Enter. It's going to be 10.863. The answer must be D. Let's move on to question 1. Let y equals fx be the solution to the differential equation dy over ds equals x plus y with the initial condition f of 1 equals 2. What is the approximation for f of 2? If Euler's method is used starting at s equals 1 with step size h equals 0.5, right? Now we just get the table. Alright, initial condition is right here, s equals 1, y equals 2. So we just place 1 and 2 over here, right? Now the step size h equals 0.5 and the final value of s should be 2, right? So you just keep adding 0.5 to s value until you get 2, right? So 1 right here, 1.5 right here, and 2 right here. We stop right here, right? Because we need to calculate f of 2, right? Now, dy over ds equals this formula right here, s plus y, right? So you just add 1, 2, it's going to be 3, right? Now, you need to find the equation of the tangent line, right? So we know that y minus y1 equals m times s minus s1, right? Or y equals m times s minus s1 plus y1, right? So I have y equals m equals 3 right here, right? This one is the slope times s minus s1, s1 is right here, and plus y1 is going to be right here, right? Now we substitute 1.5 for s into this equation to find the new y value right here, right? So we have 3 times 1.5 subtract 1 is going to be 0.5, right? Plus 2. So it's going to be 3.5, right? So right here I just put 3.5. Now the new slope is 1.5 plus 3.5 is going to be 5, right? Equation of the tangent line y equals 5 times s minus s1 is 1.5 plus y1 is going to be 3.5, right? Now substitute 2 for s over here. We have 5 times 2 minus 1.5 is going to be 0.5, right? Plus 3.5, right? So it could be 2.5 plus 3.5, it could be 6. We put 6 over here. The answer must be C. Now let's move on to question 2. Question 2 is similar to question 1, right? So I'm going to leave this one for you to practice. The answer is D. Now let's move on to question 3. Alright, question 3 similar to question 1 and 2. We just get the table. The initial condition is right here, x equals 0, y equals 1, right? And look at the step side right here. 2 steps of equal sign, starting from s was 0, and then ending as negative 0.6, right? So this guy must be negative 0.3, and this guy should be negative 0.6, right? Now dy over dx, we're going to use the formula right here, right? S plus 2y, right? So it could be 2. Equation of the tangent lines, y equals, the slope is going to be 2 times s minus s1 is going to be 0, right? Plus y1, which is 1, right? Substitute negative 0.3 for s over here. So we have 2 times negative 0.3 is going to be negative 0.6 plus 1 is going to be 0.4, right? Put 0.4 over here, right? Now dy over dx is going to be s plus 2y, right? So it could be negative 0.3 plus 0.8, right? So it could be 0.5 right here, right? So y equals 0.5 times s minus negative 0.3, which means at 0.3, right? Plus 0.4. Substitute negative 0.6 right here. So we have negative 0.3 times 0.5 is going to be negative 0.15 plus 0.4 is going to be 0.25, right? So we put 0.25 over here. This one is the final answer. The answer must be D. Now let's move on to question 4. Assume that f and f prime have the values given in the table. Use Euler's method with 2 equal steps to approximate the value of f of 4.4, right? So 4.4 is the final values right here, right? Remember, we have f of s equals the slope times s minus s1 plus f of s1, right? F of 4.2 equals the slope is negative 0.5 right here, right? Times s minus s1, but s1 equals 4, right? Plus f of s1 actually 2 right here, right? So f of 4.2, substitute 4.2 per s over here, we have negative 0.5 times 0.2 plus 2, right? So it could be 1.9, right? Now f of 4.4 is going to be, the slope is right here, right? Negative 0.3 times s minus s1 right here, 4.2 plus the values right here, right? 1.9. So it could be negative 0.3 times, substitute 4.4 for s over here, we have 0.2 plus 1.9, right? So it's going to be 1.84. The answer must be C. Now let's move on to question 5. Question 5 similar to question 1, 2, 3, 4, right? So I'm going to leave this one for you to practice. The answer is C. Now let's move on to question 6. Consider the differential equation dy over dx equals ax squared plus 4 over y, where a is a constant. Let y equals fs be the particular solution to the differential equation with initial condition f of 0 equals 2. Euler's method starting from s equals 0 with step size of 2 is used to approximate f of 4. Steps from this approximation shown in the table above. What is the value of A? Now we have the equation of the tangent line is going to be f of s equals the slope times s minus s1 plus f of s1, right? Now we have f of s equals, we need to calculate f of 4, right? So we need to use the previous s and y values right here, right? So the slope is given by this formula, right? So we have a times s squared, s equals 2 right here, so it could be 4, right? Plus 4 divided by the y value actually sits right here, times s minus s1, which means 2, plus f of s1, which means 6, right? Now f of 4 actually 10 right here, right? And it's going to be substitute for s over here, we have 4a plus 4 divided by 6 times 2, right? Plus 6, right? So it's going to be 4a plus 4 divided by 3 plus 6 equals 10, right? It's going to be 4a plus 4 plus 18 subtract 30 equals 0, right? So 4a equals 8. Then a equals 2, right? The answer is B. Now let's move on to question 11. The number of moves in a national park is modeled by the function m that satisfies the logistic differential equation dm over dt equals 0.6 m times 1 minus m over 200, where t is the time in years, and m of 0 equals 50. What is the limit of m of t when t approaches infinity? So when t approaches infinity, this guy approaches L, which is carrying capacity. Carrying capacity is right here, 200. Right? The answer must be B. Now let's move on to question 12. Which of the following differential equations for a population P could model the logistic growth shown in the figure above? Alright, so observe that this figure has the carrying capacity 200, right? Now remember, we have the differential equation of a logistic growth model given by dy over dt equals k times y times 1 minus y over L, where L is the carrying capacity. Now look at the answer choice right here. Y in this situation is P, right? So I just replace y with P, right? So I have dP P over dt equals K times P times 1 minus P over L, right? Now I'm going to expand this one, so it could be dP over dt equals Kp minus A over L times P squared, right? So this formula, we're going to come up with a conclusion. A correct logistic equation must have a positive linear terms Kp, right? This guy positive. A negative quadratic term, this one is negative right here, right? And level of at the carrying capacity L right here, right? So we look at the answer choice right here. We need to eliminate C, D, and E because they all have the positive quadratic term, right? Now for the first one, we need to factor P out. So we have 0.2 minus 0.001 P, right? So we're going to set this one equal to 0, right? So we have 0.2 minus 0.001 P. So it's going to be P equals 200, right? Which is the maximum value right here, right? So the answer is A. Now look at answer choice B. We factor P out, right? So we only end up with 0.1 minus 0.001 P. Set this one equals 0. So P equals 100, which is not the right one, right? So answer choice B is wrong. Now let's move on to question 13. Let K be a positive constant. Which of the following is a logistic differential equation? We know that the logistic differential equation is given by the formula dy over dt equals K times y times 1 minus y divided by L, right? So we look at the answer choice right here, only E correct, right? So this problem very simple, you just recognize the logistic differential equation, right? Now let's move on to question 14. The number of fish in a lake is modeled by the function P that satisfies the differential equation dP over dt equals 0.003 P times 1000 minus P, where T is the time in years. Which of the following could be the graph of y equals P of T, right? So basically, you just recognize the logistic growth differential equation. That's it, right? So actually, answer choice is A. Now let's move on to question 1. The position of a particle moving in the xy plane is given by parametric equations. S of t equals this guy, y of t equals this guy. What is the slope of the tangent line to the path of the particle at the point where t equals 2? So we need to calculate dy over ds and then evaluate it. This one as t equals 2, right? So in order to do this one, we need to borrow dt, right? So we have s prime of t equals ds over dt, right? It's going to be 6 times t plus 1 subtract 6t over t plus 1 altogether squared, right? So it's going to be 6 over t plus 1 altogether squared, right? Y prime of t equals dy over dt. It's going to be minus 2t times negative 8 over t squared plus 4 altogether squared, right? So it could be 16t over t squared plus 4 altogether squared, right? We're going to evaluate this one as t equals 2. So it's going to be 6 over 9, right? It's going to be 2 over 3. Evaluate this one as t equals 2. It's going to be 32 over 64 is going to be 1 over 2, right? So finally we have dy over ds equals dy over dt divided by ds over dt. So it's going to be 1 over 2 times 3 over 2 is equal to 3 over 4. The answer is C. Now let's move on to question 2. At time t greater than equal to 0, a particle moving in the xy plane has velocity vectors given by this guy. What is the total distance the particle travels between t equals 1 to t equals 3? Alright, so we just calculate it in row form 1, 2, 3 of square root of 4 e to the negative t altogether square plus sine of 1 plus square root of t altogether square, right? dt. Now we're gonna bring up the calculator. We're gonna add calculator, hit it, put on right here, input it in row. In row form 1, 2, 3. Press Control Enter. It's gonna be 1.860. Now question 3. A curve is defined by the parametric equation s of t equals this, y of t equals this. What is the second derivative in terms of t? We have dy over dx equals dy over dt divided by dx over dt, right? Now we're going to take derivative of this one is going to be 3e to the 3t divided by 6e to the 2t. And if we simplify, it's going to be 1 over 2e to the t. Now we're going to take the second derivative. So we have d squared y divided by dx squared. It's going to be d over dt of dy divided by dx divided by dx over dt. Now the derivative of this one with respect to t is going to be itself, right? So we have 1 over 2 e to the t divided by derivative of s with respect to t is going to be 6e to the 2t, right? Now we're going to simplify this one. It's actually 1 over 12 e to the t, right? So the answer must be A. Question 4. For time t greater than or equal to 0 seconds, the position of an object traveling along a curve in the xy planes is given by the parametric equation s of t, y of t, where dx over dt equals t squared plus 3. dy over dt equals t cubed plus t. At what time t is the speed of the object 10 units per second. Alright, so we know that the speed is, so it's going to be square root of t squared plus 3 altogether square plus t cubed plus t altogether square equals 10, right? Now we're going to bring up the calculator. We just graph these two guys on the same xy coordinate planes and we're going to find intersection, right? So we're going to go to home screen, hit graph right here. f1 of s should be square root of, enter. It's going to be right here. Alright, now press tab. Number 2, we're going to hit 10, right? Press enter. It's going to be right here. You know that t is greater than or equal to 0 seconds, right? So basically, the intersection should be on the right hand side right here, right? Press menu, number 6, number 4, go to the left, go to the right. It's going to be 1.81. Now question 5. A particle moving in the xy planes has velocity vectors given by v of t equal this one. For time t greater than or equal to 0, what is the magnitude of the displacement of the particle between t equals 1 to t equals 2? Alright, so we need to calculate delta s is going to be in the row form 1 to 2 of s prime of t dt, right? Integral from 1 to 2 s prime of t is given by right here, right? Now delta y is integral from 1 to 2 y prime of t dt. It's going to be integral from 1 to 2 of 5t squared dt, right? Absolute value of delta r equals square root of delta s altogether square plus delta y altogether square, right? So we're gonna print up the calculator. Alright, so we're gonna hit the square root side first, right? Delta s square, but delta s equal this one, right? So we're gonna hit the put it right here, input the integral from 1 to 2 of e to the sine t. We hit Control Enter. It's going to be 11.953. Now question set the position of the particle moving in the xy planes given by the parametric equations s of t equals this, y of t equals this, at which the following points s and y is the particle at rest. So you know that when the particle is at rest, it means the velocity vector is s prime of t, y prime of t equals 0, 0, right? So s prime of t is 3t squared minus 6t equals 0, right? So then t equals 0 and t equals 2, right? Y prime of t is 12 minus 6t, and then t equals 2. Now look at the common thing between s prime and y prime. It's going to be t equals 2, right? So at t equals 2, then s of 2 is 2 cubed minus 3, 2 squared, right? And it's going to be negative 4. Now y of 2 is 12 times 2 minus 3 times 2 squared, right? So it's going to be 12. Then finally sy is negative 4, 12. The answer must be A. Question 7. A particle moves on a parametric curve described by the parametric equation s of t equals 3t plus 1, y of t equals 2 plus t cubed, which of the following gives the length of the particle from point 1 to 2, 7, 10. So from this point right here, which means s of t equals 1, it tells us that 3t plus 1 equals 1, right? And then t equals 0. Y of t equals 2, right? And then 2 plus t cubed equals 2. And then t equals 0. Now the second one, s of t equals 7 right here. Then 3t plus 1 equals 7, and then t equals 2. Y of t equals 10, and then 2 plus t cubed equals 10, and then t equals 2. So finally, you have the interval from 0 to 2 to move from this point to this point, right? Now to find the length of the particle, we need to find the first derivative, right? So we have s prime of t equals 3, right? Y prime of t equals 3t squared, right? So the length is the interval from 0 to 2 of square root of s prime t squared, right? So it could be 3 squared plus y prime of t squared. It's going to be 3t squared altogether squared dt, right? So we're going to simplify this one. It's going to be integral from 0 to 2 square root of 9 plus 9t to the 4 dt. So the answer must be A. Now let's move on to question 8. If S equals ln 2t and y equals t cubed plus 1, what is the second derivative of this guy in terms of t? Alright, so we have dy over dx is going to be dy over dt divided by ds over dt, right? Dy over dt is going to be 3t squared. ds over dt is going to be 2 over 2t, right? If we simplify, it's going to be 3t cubed, right? Now we're going to take the second derivative, right? So we have d squared y divided by ds squared is going to be d over dt of dy divided by ds over dt, right? Now we're going to take the derivative of this one with respect to t, so it could be 9t squared, and ds over dt is going to be 2 over 2t, right? So if we simplify this one, it's actually 9t cubed. The answer must be D. Now question 9. The position of a particle moving in the xy plane is given by the parametric functions ft and y of t, for which s prime equal this, y prime equal this. What is the rate of change of y with respect to s when t equals 2? So it's the same thing as we need to calculate dy over ds at t equals 2. So we're going to divide the top bottom by dt, right? So we have dy over dt divided by ds over dt, right? At t equals 2. So it could be dy over dt is right here. ds over dt is right here. Evaluated at t equals 2, right? So we're going to bring up the calculator. Hit the button right here. Input this fraction. Press Ctrl Enter. It's going to be negative 1.802. So the answer must be A. Question 10. The position of the particle moving in the xy plane is given by the parametric equation. S of t equals this, y of t equals this, where n is a positive constant. If the line s plus 2y equals 6 is parallel to the line tangent to the path of the particle at t equals 4, what is the value of n? Alright, so you need to find the slope, right? So we have s prime of t is n times e to the n t, right? Y prime of t equals negative 3 over t minus 1 altogether square, right? So this one, derivative of 1 over u is going to be negative 1 over u square. So you have dy over ds equals dy over dt divided by ds over dt. So it could be negative 3 over t minus 1 altogether square over n times e to the n t, right? Now you need to evaluate this one at t equals 4, right? So it's going to be negative 1 over 3 times n e to the 4n, right? And this tangent line parallel to this line, right? So they have the same slope, right? The slope of this guy is negative 1/2, right? So we're going to let this one equals negative 1 over 2. This guy is the same thing as 3n times e to the 4n equals 2. Now we're going to wrap these two lines on the calculator. So we're going to go to home screen, hit graph right here, hit tab, go up to F1. I'm going to clear this one. Put 3s times e to the 4s. Press enter. The second one, you're going to hit tab, go to the second function, press 2, hit enter. It's going to be right here. Alright, now we need to find the intersection right here, right? So press menu number, set number for go to the left, go to the right. It's going to be 0.248. The answer is B. Now let's move on to question 11. A particle moves in the xy plane with precision given by this guy. In which direction is the particle moving as it passes through the point 11, 6? Now, in order to find the direction the particle moving, we need to find the first derivative, which is velocity, right? So we have s prime of t equals 3, right? Y prime of t equals negative 4t, right? Now we need to solve for t given this coordinate point, right? Substitute this guy over here to solve for t, right? So we have 3t plus 5 equals 11, right? And 14 minus 2t squared equals 6. So t equals 2, right? So then we have x prime of t equals 3 and y prime of t. Substitute 2 over here, we have negative 8, right? This guy is positive, this guy is negative, right? Now look at the x and y coordinate right here, right? The y-axis, the x-axis. This guy is positive, this guy is negative, this guy positive, and this guy negative. S prime positive is moved to the right. Y prime is negative is moved down. So the answer must be B. Now let's move on to question 12. A particle moves on a plane curve so that anytime t greater than 0 its s coordinate is t cubed minus t and its y coordinate is 2t minus 1 cubed. The acceleration vector of the particle at t equals 1 is. Alright, so basically we need to find the second derivative of this guy, right? So we have s of t equals t cubed minus t, right? And then s prime of t equals 3t squared minus 1, right? So s double prime of t equals 6t, right? And then you need to evaluate this one at t equals 1, right? So it could be 6. Now y of t equals 2t minus 1 cubed, right? And then y prime of t is 3 times 2t minus 1 squared times 2, right? So it's going to be 6 times 2t minus 1 squared, right? Then y double prime of t is 12 times 2t minus 1 times 2, so it could be 24. Now we need to evaluate this one at t equals 1. So it's going to be 24, right? So the acceleration a of t is 6, 24. So the answer must be E. Now let's move on to question 13. A curve in the plane is defined parametrically by the equation s and y. An equation of the line tangent to the curve at t equals 1 is. Alright, so we need to calculate dy over ds at t equals 1 is how much, right? This one is the slope of the tangent line. And then we need to use the point slope formula to write equation, right? So first I need to find the coordinate of the point, right? So I have s, y is, substitute 1 for t over here. It's going to be 2, right? Substitute 1 for t over here. It's going to be 3, right? We have s prime of t is 3t squared plus 1, right? And y prime of t is 4t cubed plus 4t, right? So dy over ds is the same thing as dy over dt divided by ds over dt, right? Now dy over dt is going to be 4t cubed plus 4t divided by ds over dt is going to be 3t squared plus 1. Evaluate this one as t equals 1, right? So substitute 1 for t is going to be 8 over 4 is going to be 2, right? So the slope is 2, so equation should be y equals 2 times s minus 2 plus 3, or 2s minus 1. Now let's move on to question 14. In the xy plane, a particle moves along the parabola y equals s squared minus s with a constant speed 2 square root 10 units per second. If ds over dt greater than 0, what is the value of dy over dt when the particle is at a point 2 and 2? Alright, so we have dy divided by ds by taking the derivative of this one, right? So it's going to be 2s minus 1. Now we're going to divide the top bottom by dt, right? So we have dy over dt divided by ds over dt equals 2s minus 1, right? And dy over dt equals 2s minus 1 times ds over dt. Then ds over dt equals 1/3 dy over dt. Now we're going to use the speed right here. So the speed is the square root of s prime of t altogether square plus y prime of t altogether square equals 2 square root 10, right? Now we're going to square both sides and we substitute ds over dt, dy over dt over here, right? So we have, so it's going to be 10 over 9 dy over dt altogether square equals 40, right? So then dy over dt equals 6. The answer must be D. Now let's move on to question 15. The position of a particle moving in the xy plane is given by the parametric equations s and y. For what values of t is the particle at rest, which means velocity equals 0, right? Velocity is going to be s prime of t, y prime of t, right? So when I take the derivative of this one, it's going to be s prime of t equals 3t squared minus 6t, right? Let this one equal to 0, right? So then you have t equals 0 and t equals 2. Now y prime of t is 6t squared minus 6t minus 12, right? And then you're going to factor 6 out. So we have t squared minus t minus 2, right? It's going to be 6 times t minus 2 times t plus 1, right? Now we're going to let this one equal 0, so t equals 2 and t equals -1, right? Look at the common term right here, t equals 2 and t equals 2 right here, right? So the answer must be C. Now question 16. If f is a vector value function defined by this guy, then the second derivative of this one. So we need to find the first derivative, right? It's going to be negative e to the negative t, negative sine t, right? Second derivative is going to be e to the negative t, comma, negative cosine t, right? So the answer must be E. Now let's move on to question 17. A particle moves in the xy plane so that its position at any time t is given by s of t equals t squared, while t equals sine 4t. What is the speed of the particle when t equals 3? Remember, absolute value of v of t equals square root of s prime of t altogether square plus y prime of t altogether square, right? So we need to calculate s prime of t equals 2t, right? and evaluate this one as t equals 3. So it could be 6, right? Y prime of t is 4 cosine 4t. And then you need to evaluate this one as t equals 3. So it could be 4 cosine 12, right? Now, the magnitude of the velocity is going to be the speed. It's going to be square root of 6 square plus 4 cosine of 12 altogether square. So we're going to bring up the calculator. Let's control enter. It's going to be 6.884. The answer must be C. Now question 18. What is the slope of the line tangent to the polar curve r equals 1 plus 2 sine theta at theta equals 0? Alright, so we have dy divided by ds is the same thing as dy over d theta divided by ds over d theta, right? We have s equals r cosine theta, but r equals this one, so it could be 1 plus 2 sine theta times cosine theta, right? Y equals r sine theta. So then it's going to be 1 plus 2 sine theta, right? So it's going to be 2 cosine theta times sine theta plus cosine theta times 1 plus 2 sine theta, right? Over 2 cosine theta times cosine theta minus sine theta times 1 plus 2 sine theta. Alright, we're going to evaluate this expression at theta equals 0, right? So, sine of 0 equals 0, right? Sine of 0 equals 0. Cosine of 0 equals 1, so the top is 1. The bottom, cosine of 0 equals 1, so it's going to be 2. So it could be 1/2, right? So the answer must be B. Now let's move on to question 19. The figure above shows the graphs of the polar curves r equal 2 cosine 3 theta and r equal 2. What is the sum of the errors of the shaded regions? Alright, so the error of the shaded region equals the error of the circle. Subtract the error of the rows, right? Since the rows passes the origin, which means the radius equals 0, right? So we're gonna let 2 cosine 3 theta equals 0. It's the same thing as cosine 3 theta equals 0, right? 3 theta equals n pi over 2, right? And could be positive, could be negative integers, right? So theta equals n pi over 6, right? So if n equals negative 2, we have negative pi over 3. N equals negative 1, it's going to be negative pi over 6. N equals 0, it could be 0. And n equals 1, it's going to be pi over 6. N equals 2, it's going to be pi over 3, right? So this guy actually pi over 6 and negative pi over 6, right? The error of the rows equals 1/2. Then row from negative pi over 6 to pi over 6 of 2 cosine 3 theta altogether square d theta, right? Since number 19, we are allowed to use the calculator, but you could solve this one without using the calculator. Remember, you have the cosine square theta is going to be 1 plus cosine 2 theta divided by 2, right? So this one is 3 theta. This guy must be 6 theta, right? So keep that in mind. You have sine square theta is going to be 1 minus cosine 2 theta divided by 2. So keep that in mind. Now I'm going to hit the button right here, input the interval from negative pi over 6 to pi over 6. and then press Ctrl Enter. It's going to be 1.047. Now, since this one is just the error of one pedal, right? We have 3 pedals, so we need to multiply by 3, right? So the error of the shaded equals the error of the circle, which is pi r squared when r equals 2 right here. So it could be 4 pi subtract 1.047 times 3, right? So we're going to bring up the calculator, press Ctrl Enter. It could be 9.425. So the answer is D. Now we have the second way to calculate the error of the rose curve right here. And I believe that most of you will make a mistake. You're going to do like this. Error equals 1/2 the integral form. You see that this is 0 and then it's go back to the full circle. So it could be 0 to 2 pi of 2 cosine of 3 theta altogether square d theta. Unfortunately, this is not the case. If you integrate from 0 to 2 pi, you are technically calculating the error of the rows twice. This is why for any rows, r equals a cosine of n theta, where n is r, we use the interval 0 to pi to capture the error exactly once. Why? We look at this one right here. We start from the angle theta equals 0 to pi over 6 right here. Right? We trace the top half of the first pedal. Right? Now, from pi over 6 to pi over 2, it's going to be right here. Right? We get this guy. So then, observe that if the radius is negative, you're going to plot the point in the opposite way, right? So you don't see anything right here, which means the radius is negative. You're going to trace the second bevel in the lower left quadrant, right here, right? Now, next, from pi over 2 to 5 pi over 6, it's going to be right here. The radius is still positive, right? Because it's still right here. We're going to trace the third bevel in the upper left quadrant. So the error of the shaded region equals the error of the circle, which is 4 pi subtract the error of the rows right here. It's going to be 1/2 the integral from 0 to pi of 2 cosine 3 theta altogether square d theta. We don't need to multiply by 3 because you already calculate the whole thing, right? So the answer is still 9.425. You can check with calculator, right? By the way, I'm going to compare between rose curve with the odd end and the even end. Now for this one, we have 3 pedals. This one we have 4 pedals. This one full trace from 0 to pi. This one full trace from 0 to 2 pi. The error is calculated by this formula. 1/2 times integral from 0 to pi the radius square d theta. This guy 1/2 times the integral from 0 to 2 pi r square d theta. So keep that in mind. For this one right here, you can calculate the error of one pedal using the formula 1/2 integral from negative pi over 4 to pi over 4 times 2 cosine 2 theta altogether square d theta. Then you're going to multiply by 4, right? Because you have 4 pedals, right? Move on to question 20. The function f of theta equals this guy. Satisfy f of theta greater than equal to 0 for theta greater than equal to 0 during the time interval t between 0 to 2 pi seconds. A particle moves along the polar curve r equals f of theta so that at time t seconds, theta equals t. On what intervals of time t is the distance between the particle and the pole increasing? So when it's come to increasing or decreasing, we're going to take the first derivative, right? We have r of theta equals to theta cube minus 20 theta square plus 50 theta, right? And then we're going to find dr over d theta. It's going to be 6 theta square minus 40 theta plus 50. Now we're going to factor 2 out. So we have 2 times 3 theta square minus 20 theta plus 25. Right? Now we're going to factor this trinomial. So it could be 2 times 5. 2 number multiply equals 75. Add up to negative 20. Negative 15 and negative 5, right? So we have theta minus 15 times theta minus 5, right? Now, since the coefficient right here is 3, you need to divide this guy by 3, divide this guy by 3, right? So we're going to simplify this one. It's going to be 2 times theta subtract 5 multiply this one because you cannot simplify it, right? 3 theta minus 5. This one is the final factor form, right? Now we're gonna let dr over d theta equals 0 and then theta equals 5. Theta equals 5 over 3, right? We're gonna draw the number line. We're gonna put this guy on the number line. So I'm gonna pick 2 right here. I substitute 2 for theta into this equation right here, right? So I have 6 times 4 is going to be 24 plus 50 is going to be 74 subtract 80 is going to be negative, right? So this interval is negative. This guy is positive and this guy must be positive, right? Now the distance between the particle and the pole is increasing. It tells us that dr over d theta greater than 0, right? So it's going to be this interval right here and this interval right here, right? So the answer must be D. Now let's move on to question 21. Which of the following is equal to the area of the region inside the polar curve or equal to cosine theta and outside the polar curve or equal cosine theta? Alright, we need to graph these two guys on the polar coordinate. Alright, now we need to calculate the area of this region. And you know that the circle of the form R equals A cosine theta is fully traced as theta goes from negative pi over 2 to pi over 2. So we have the formula area equals 1/2 the integral from negative pi over 2 to pi over 2 of outer radius is going to be 2 cosine theta altogether square. Subtract the inner radius, it could be cosine theta altogether square d theta, right? So it's going to be 2 times 1/2 integral from 0 to pi over 2 of 3 cosine square theta d theta. We're going to simplify this one. It's going to be this guy gone, bring 3 to the front. 3 times integral from 0 to pi over 2 cosine square theta d theta, right? So the answer must be A. Now question 22. The area of the region inside the polar curve R equal 4 sine theta. This guy actually equation of the circle, right? And it's going to be vertical circle. And outside the polar curve R equals 2 is given by. Now since calculator is not allowed, you're supposed to know how to graph this guy. Alright, so please check out the link in the description below to learn how to graph this polar curve, right? Now if you graph it, it's going to be something like this. Now we need to find the intersection right here. right? So we just equate this guy and this guy. So we have 4 sine theta equals 2, sine theta equals 1/2, right? And theta equals pi over 6, 5 pi over 6, right? This one is 5 pi over 6, this one is pi over 6, right? So the error equals 1/2 in the form pi over 6 to 5 pi over 6 of the outer radius. The outer radius is this guy right here, right? So we have 4 sine theta altogether square. Subtract the inner radius, it's gonna be right here, 2 square d theta. So it's gonna be 1/2 in the form pi over 6 to 5 pi over 6, 16 sine square theta. Subtract 4 altogether d theta. So the answer must be D. Now question 23. Which of the following expression gives the total error enclosed by the polar curve R equals sine squared theta shown in the figure above? When the polar curve at the origin, the radius equals 0, right? So we have sine squared theta equals 0 is the same thing as sine theta equals 0, right? And theta equals 0 and pi. The error is 1/2 times the integral from 0 to pi of sine square theta altogether square d theta. This guy is just the upper half, right? We have this guy symmetric about the x-axis, so we need to multiply by 2, right? So the final answer is integral from 0 to pi of sine to the 4 theta d theta, right? So the answer must be D. Now let's move on to question 24. What is the error of the region enclosed by the lemniscate r squared equals 18 cosine 2 theta shown in the figure below? Alright, so again, when the radius is 0, the polar curve at the origin, right? So we're gonna let 18 cosine 2 theta equals 0, cosine 2 theta equals 0, right? And 2 theta equals n pi over 2, right? Theta equals n pi over 4, right? So you know that n is the integer, right? If n equals 1, we get pi over 4. N equals -1, we get negative pi over 4. So this guy right here actually negative pi over 4. And this guy actually pi over 4, right? So we just calculate the error of this guy right here and we multiply by 2, right? So we have A equals 1/2 integral from negative pi over 4 to pi over 4 of this guy square. So we already have square right here. So it's going to be 18 cosine 2 theta d theta. Now you need to multiply by 2 to get the left hand side, right? And then I need to convert this one to 0 to pi over 4, right? So I put 2 in the front, right? So 2 and 2 cancel out. I have another 2, right? 2 times 18 could be 36, right? So I have 36 integral from 0 to pi over 4 cosine of 2 theta d theta, right? So remember, antiderivative of cosine of as plus b ds is going to be 1 over a sine of as plus b plus c. So keep that in mind. So 1 over 2 it could be 36 divided by 2 it could be 18, right? Times sine of 2 theta, right? Evaluated from 0 to pi over 4, right? So it could be 18 times sine. Substitute pi over 4 over here, it could be pi over 2, right? Substitute 0 over here, it could be sine of 0, right? So the answer is 18, right? The answer must be C. Question 25. Which of the following gives the error of the region enclosed by the loop of the graph of the polar curve R equals 4 cosine 3 theta shown in the figure above? When the polar at the origin, the radius equals 0, right? So we let this guy equals 0. to solve for theta, right? So cosine 3 theta equals 0. 3 theta equals n pi over 2. Theta equals n pi over 6. When n equals 1, we get pi over 6. When n equals -1, we get negative pi over 6. This guy actually negative pi over 6. This guy actually pi over 6, right? So the error is 1/2 integral from negative pi over 6 to pi over 6, right? Of the radius square, which is 4 cosine 3 theta altogether square d theta. Alright, this could be 1/2 integral from negative pi over 6 to pi over 6 of 16 cosine square 3 theta d theta. Now 16 divided by 2 is going to be 8, right? So we have 8 integral from negative pi over 6 to pi over 6 cosine square 3 theta d theta. The answer must be E. Now let's move on to question 26. Which of the following represent the graph of the polar curve r equal to secant theta? We have S equals R cosine theta, right? But R equals this one, right? So it could be 2 secant theta times cosine theta, right? So it's going to be S equals 2 secant theta is going to be 1 over cosine theta times cosine theta. This cancel out, so S equals 2, which is the vertical line. The answer must be D. Now let's move on to question 1. What is the interval of convergence of the power series right here? Alright, so the best way for you to do MCQ is to eliminate the wrong answer immediately. Now look at the center right here. The center is C equals 4. Technically, you just let S minus 4 equals 0. And then you will have C equals 4 right here. I just replace S with C. Alright. So the center is C equals 4. You look at the interval right here. You put 4 in the middle, right? So this is negative 3. This is 3. This guy 4. It doesn't make sense, right? So you need to eliminate A and B, right? Only C and D, correct, right? Because you put 1 here, 7 right here, and 4 in the middle. Yes, makes sense because the radius of convergence is 3. Now, next one, you need to check the endpoints, right? This one doesn't have endpoint. This guy has the endpoint right here, right? So you're going to let S for 7. Substitute 7 for S over here. So you're going to end up with 7 subtract 4 is going to be 3. So I have 3 to the end right here. Now 3 to the end and 3 to the end cancel out, right? So I have the series ends go from 0 to infinity of -1 raised to the n times n plus 2 over n, right? Now we're going to take the limit of n plus 2 over n when n approaches infinity. Alright, so it's going to be limit of n over n when n approaches infinity, right? Because n much larger than 2, right? So it's actually 1, right? So this guy is different from 0, right? So by the n term test, this series diverges, right? So S equals 7 is excluded, right? Because we need the interval of convergence. The answer must be C. Now let's move on to question 2. Which of the following series are convergent? Alright. Now, number 1 right here. Look at the general terms right here. This guy actually the P series, right? Remember the P series. P greater than 1, the series converges. If P greater than 0, less than equal to 1, the series diverges. Right? Now P equals 2 greater than 1, so the series converges right here, right? So 1 is correct. Now number 2, look at the general terms right here. This guy actually harmonic series, right? Harmonic series, the series diverges because P equals 1 right here, right? So this one is wrong. Now number 3, this guy actually geometric series, right? Look at the first term and the second term right here, and the second term and the third term right here, right? you see that the common ratio is negative 1/3, right? You're going to take the absolute value of the common ratio. It's going to be absolute value of negative 1/3, and it's going to be 1/3, which is less than 1. The series converges, right? So number 3 correct. So the answer must be 1 and 3, right? The answer must be C. Now let's move on to question 3. The Taylor series for a function f about s equals 0 converges to f for s between -1 and 1. The n-degree Taylor polynomial for f about s equals 0 is given by p sub n of s equals this guy. Of the following, which is the smallest number m, for which the alternating series error value guarantees this guy. Alright, so we need to rewrite the full Taylor series at s equals 1, right? So we have f of 1, substitute 1 for s over here, right? So we have, so this guy actually the alternating series, right? With the terms a sub k equals 1 over k squared plus k plus 1, right? Let's generate this one when k starts from 1 to infinity, right? So if k equals 1, we have 1 over 3, right? K equals 2, we have 1 over 7, right? K equals 3, we have 1 over 13. K equals 4, we have 1 over 21. K equals 5, we have 1 over 31, etc. Right? Now observe that each of these terms right here are positive. Right? And then the terms is decreasing, right? And finally, when you take the limit of this one, when k approaches infinity, it's going to be 0, right? So we can use the alternating series error value, right? So it's going to be absolute value of r sub n always less than or equal to the next omitted terms, which is a sub n plus 1, right? We have the error value is right here, right? So this guy less than or equal to m. M is the next omitted terms, which is a sub 5, right? Look at 4 right here. So a sub 5 is 1, 2, 3, 4, 5. The answer is 1 over 31. The answer must be C. Now let's move on to question 4. Which of the following statements about the series is true? Alright. So we're gonna let the whole thing right here be a sub n, right? So this guy actually alternating series. We need to find the limit of 1 over 1 plus square root of n when n approaches infinity, right? It's actually 0. Second one, don't worry about this guy, right? If n equals 1, you have 1 over 1 plus square root of 1 is going to be 2. N equals 2 is going to be plus 1 over 1 plus square root of 2. N equals 3, 1 over 1 plus square root of 3. The series has decreasing terms, right? Every single time it's going down, right? Because the denominator greater than the numerator. By the alternating series test, the series a sub n converges. Now, you need to determine if this guy converges absolutely or conditionally. The series of absolute value of a sub n becomes 1 over 1 plus square root of n. Remember, the whole thing right here is a sub n, right? So when you take absolute value, this guy right here gone, right? So you only have this guy. Now I'm going to use the limit comparison test. I need to find the limit of a sub n over b sub n when n approaches infinity. Now I'm going to compare this guy with 1 over square root of n, right? So I'm gonna have limit of a sub n over b sub n. When n approaches infinity, it's gonna be same thing as limit when n approaches infinity of 1 over 1 plus square root n times square root n over 1, right? So it's gonna be limit when n approaches infinity of square root n over 1 plus square root n. Now when n approaches infinity, this guy much larger than 1, right? So it turns out to be limit of square root n over square root n when n approaches infinity equals 1, which is greater than 0, right? Look at this one, greater than 0. Now, if the bottom diverges, then the top diverges, right? So, I'm going to look at this guy right here, the bottom, which is this guy right here, right? But the bottom right here is divergent by the P series, right? You have the series 1 over square root n is the same thing as series 1 over n power 1 half, right? P equals 1 over 2 less than 1. The series diverges by the P series, right? This one diverges. Now, originally, you have this one converges by alternating series test, which is the whole thing right here. Now, we're going to look at this one right here, absolute and conditional convergence. This guy right here. If absolute value of a sub n diverges, which is this guy right here, right? But the series a sub n converges. This guy converges right here, right? Then the series a sub n is said to converge conditionally, right? So the answer must be B. Now let's move on to question 5. Which of the following series can be used with the limit comparison test to determine whether the series converges or diverges? Alright, so when you use the limit comparison test, you're going to check the quotient of the leading terms on the numerator and denominator. Numerator is right here, denominator is right here. So n divided by n cubed is going to be 1 over n squared, which is right here. The answer must be B. Now question 6. Which of the following series are conditionally convergent? Alright, so remember conditionally convergent means the series right here, I name this one as a sub n, right? This guy as a sub n, and this guy as a sub n. The series conditionally convergent if this guy converges, but the absolute value of a sub n diverges. Now we're going to check to see if the first one right here converges, right? So we're going to use the alternating series test, right? They are alternating series test, right? So we're going to find the limit of, ignore this guy, it's going to be 1 over n to the 4. When n approaches infinity, it's going to be 0, right? And we're going to populate the series, right? So if n equals 1, we have 1 over 1, right? N equals 2, we have 1 over 2 power 4, right? N equals 3, we have 1 over 3 power 4, right? And observe that the terms are decreasing. By the alternating series test, this series converges, right? Now we do exactly the same thing for number 2 and number 3. They all converge by the alternating series test, right? Now we need to check the absolute value of this guy, right? So absolute value of this guy turns out to be 1 over n to the 4, right? Now we need to prove if this one is convergent or divergent, right? So of course this one is the P series where P equals 4 greater than 1, right? The series converges. So number 1, convergent. Now number 2, the series becomes 1 over n power 2 over 3, right? So this guy actually the P series, right? Where P equals 2 over 3 less than 1, right? The series diverges. Number 3. The series becomes 1 over n, right? This guy actually the harmonic series, right? And harmonic series diverges, right? This guy diverges, right? Satisfy this, right? So the answer must be C. Now question 7. Which of the following series is absolutely convergent? So we're going to review this one. When the series is absolutely convergent. If the absolute value of a sub n converges, then the series a sub n also converges, right? Now we're gonna let this guy right here as a sub n, right? And if we take absolute value of a sub n, it becomes 1 over 2 n, right? Similarly, this guy becomes 1 over n power 1 half, right? This guy becomes n over n plus 1, and this guy becomes 1 half to the n. Now this guy can be written as 1 half the series 1 over n, right? So this guy actually the P series where P equals 1, right? P equals 1. So this guy actually harmonic series, right? So it could be divergent. Now the second one right here, P equals 1 half, right? Less than 1. So the series diverges. So we need to eliminate A and B, right? Because we need the series A sub n and the series of absolute value of A sub n converges. Now for C right here, we need to find limit of n over n plus 1 when n approaches infinity. It's going to be limit of n over n when n approaches infinity, and it's actually 1, right? Different from 0. So by the end term test, the series diverges, right? So we need to eliminate this one, right? This one converges by the geometric series test, right? Where common ratio is 1 half less than 1, right? And original one is right here, converges by the alternating series test, right? I'm going to leave this one for you to check. So the answer must be D. Question 8. Which of the following series converge? Now number 1, this guy actually diverges by the n-term test, right? Because when you take the limit of n over n plus 2, when n approaches infinity, it's actually limit of n over n when n approaches infinity and equals 1, right? Not equal to 0. So by the n-term test, this series diverges. We substitute 1 for n. We're going to have cosine pi over 1, right? Substitute 2 for n. We have cosine 2 pi over 2, right? Substitute 3 for n. It's going to be cosine 3 pi over n, right? And if we simplify, it's actually cosine pi equals negative 1, so it could be negative 1 over 1. Cosine 2 pi equals 1, so it could be 1 over 2. Cosine 3 pi is going to be negative 1, so it could be negative 1 over 3. Right? Remember, cosine of odd pi is going to be negative 1. Cosine of even pi is going to be 1, right? So this guy actually alternating series. This series right here is the same thing as negative 1 raised to the n over n, right? So we're going to find the limit of 1 over n when n approaches infinity. It's going to be 0, right? And you look at the terms right here. Take absolute value of each terms right here. And you see that the absolute value of each terms is decreasing, right? So by the alternating series test, this series converges, right? And the last one right here, this guy actually harmonic series where p equals 1, right? This guy diverges, so the answer is B. Question 9. If the limit of this guy is finite, then which of the following must be true? So this guy actually the integral test, right? So we need to eliminate C, D, and E, right? Because this guy matches this and this only, right? Now, since the limit of this one is finite, it tells us that this series converges, right? So the answer must be A. Question 10. What is the value of the series 2 to the n plus 1 over 3 to the n? Alright, so we rewrite this one as 2 over 3 altogether raised to the n times 2, right? So the first term is when n equals 1, right? So n equals 1, substitute over here, we have a sub 1 equals 2 times 2 over 3. It's going to be 4 over 3, right? And the common ratio is 2 over 3, right? Since 2 over 3 less than 1, right? So this guy actually the geometric series, and it's going to be converges to s sub infinitive equals a1 over 1 minus r. And it's going to be 4 over 3 over 1 minus 2 over 3. So it's going to be 4 over 3 over 1 over 3. Multiply the top bottom by 3. So the answer must be 4. The answer is C. Question 11. What are all values of p for which the infinite series converges? Alright, so we need to use the direct comparison test. Alright, now we're going to take the leading terms on the numerator and denominator and divide them, right? So it's actually n over n to the p. So it could be 1 over n to the p minus 1, right? So we're going to compare this guy right here with this guy right here. Now observe that this guy is a sub n, this guy is b sub n, and a sub n less than or equal to b sub n, therefore greater than 0, right? So if series b sub n converges, then series a sub n must be convergent, right? In order for this guy to be convergent, and this guy actually the p series, right? P minus 1 must be greater than 1, right? So p greater than 2, right? So the answer must be E. Now let's move on to question 12. Which of the following series diverges? Number 1. Observe that sine s always less than or equal to 1, greater than or equal to negative 1, right? And pi right here actually 3.14, etc., right? So then sine 2 divided by pi always less than 1, right? And this guy actually geometric series, right? Where the common ratio is sine 2 over pi less than 1, right? And then the series converges by geometric series test, right? This guy actually the series 1 over n raised to the 1/3. Now this guy actually the p series, right? Where p equals 1 over 3 less than 1, right? Then the series diverges by the p series test. Now number 3, we're going to take the limit of e to the n over e to the n plus 1 when n approaches infinity. It's actually limit of e to the n over e to the n when n approaches infinity by relative growth rate, right? So this guy cancel out, the answer is 1, which is not equal to 0, right? So by the n term test, this series diverges. So the answer must be 2 and 3, which is D. Now question 13. Consider the series e to the n over n factorial. If the ratio test is applied to the series, which of the following inequality result implying that the series converges? right? So we're going to use the ratio test. So basically, the ratio test say limit of a sub n plus 1 over a sub n when n approaches infinity. It's actually limit of e to the n plus 1 over n plus 1 altogether factorial. Divide by a sub n, which is multiplied by its reciprocal, right? So it could be n factorial over e to the n. Now we're going to simplify this guy cancel out. We have e on the top, right? The bottom right here, you have n plus 1. Now when n approaches infinity, this guy approaches 0, right? Which is less than 1, right? So the answer must be D. Now let's move on to question 14. Which of the following series converges? For all real numbers s, right? Which means s could be anything, right? So now we're gonna test s equals 1 to see what happens. So this guy becomes the series 1 over n, and this guy diverges by harmonic series test, right? So answer choice A is wrong. Now this guy turns out to be the series 1 over n squared. This guy actually p series, right? Where p equals 2 greater than 1. So this guy converges. C is going to be 1 over n power 1 half, right? And this guy actually p series where p equals 1 half less than 1 diverges, right? So this guy wrong. Remember, B could be right, could be wrong, because we just check s equal 1. It says all real numbers s, so be careful. Now we're gonna let s equals e to check B. So the series B becomes e to the n over n squared. Now we're gonna find the limit of e to the n over n squared when n approaches infinity. The top is exponential function. The bottom is quadratic function. Exponential function grows much faster than quadratic function. So when n approaches infinity, this guy approaches infinity, which is not equal to 0, right? So the series diverges by n-term test, right? We need converges, so this one is wrong. Now we're going to test D using the ratio test, right? So we have limit of a sub n plus 1, which is e to the n plus 1 times s to the n plus 1 over n plus 1 factorial. Divide by a sub n, which is n factorial over e to the n s to the n when n approaches infinity. Now we're going to simplify this one, so to be limit when n approaches infinity of this guy cancel out, so we have e, right? This guy cancel out, we have s right here, right? This guy cancel out, so we have. Now since n approaches infinity, s not related, so we put s in the front, right? So it can be absolute value of s limit of e over n plus 1 when n approaches infinity. Alright, so the bottom much larger than the top, right? So this guy actually absolute value of s times 0 is going to be 0, which is less than 1. So by ratio test, this series converges, right? For all real number s, right? Because s times 0 is going to be 0, the answer must be D. Now let's move on to question 15. What are all values of s for which the series converges? Observe that this guy actually geometric series, right? Where the common ratio is 2 over s squared plus 1, right? So in order for this series to be convergent, we need absolute value of this one should be less than 1, right? Now observe that the one inside the absolute value side right here always positive, right? So I just remove the absolute value side, right? So it's gonna be 2 over s squared plus 1 less than 1, right? Take reciprocal both sides, so it could be s squared plus 1 divided by 2 greater than 1, right? Multiply both sides by 2, so it could be s squared plus 1 greater than 2. Subtract 1 both sides, so s squared greater than 1, right? So then s greater than 1 or s less than -1, right? So the answer must be D. Question 16. For what values of P will both series converge? Alright, so the first one right here actually the P series, right? Where P equals 2P, right? So in order for this series to be convergent, we need 2P right here greater than 1, right? So P greater than 1, right? Now, this guy actually geometric series, right? Where the common ratio is P over 2, right? So in order for this series to be convergent, we need P over 2 less than 1, right? So then P less than 2. We combine this guy and this guy. It should be from 1/2 to 2. The answer must be C. Now let's move on to question 17. For s greater than or equal to 1, the continuous function g is decreasing and positive. A portion of the graph of g is shown above. For n greater than or equal to 1, the n terms of the series a sub n is defined by this guy. If the interval from 1 to infinity of g of s ds converges to 8, which of the following could be true? Alright, so this guy actually the integral test, right? So remember we have the formula. So when this guy converges to 8, then the series right here must be convergent to a number that bigger than this guy, right? So which is greater than 8. The answer must be C because we have 10 right here. Now let's move on to question 18. The power series b sub n s plus 2 to the n converges conditionally at s equals 1. Which of the following statement about the convergence of the series at s equals -6 is true? Alright, so observe that the series center at s equals -2, right? And the series converges at s equals 1, right? So we just draw the number line right here. Alright, the center is -2 and the series converges at s equals 1. So 1 is the endpoint. Radius of convergence is 1 minus -2, which is 3, right? So this is the radius of convergence. We're gonna count 3 units to the left from the center, right? So it could be -3, -4, and -5 right here. The interval of convergence is -5 to 1 right here, right? Now we look at this one right here, s equals -6 is outside of the interval of convergence, which is it's gonna be divergent, right? So the answer must be B. Now question 19. The Markov series for the function f is given by fs equals this guy. What is the value of f of 3? So we have f of 3 equals the sum n goes from 0 to infinity of -3 over 4 raised to the n. And this guy actually geometric series where common ratio is -3 over 4, right? And absolute value of common ratio is equals 3 over 4, which is less than 1, right? Then the series converges to s sub infinity equals a sub 1 over 1 minus common ratio. The first term is when n equals 0, right? It's actually 1 over 1 minus common ratio, which is -3 over 4. So it could be plus 3 over 4, right? So it could be 1 over 7 over 4, and it could be 4 over 7. The answer must be C. Question 20. If the series a sub n converges and a sub n positive for all n, which of the following must be true? So if you have 0 less than b sub n less than or equal to a sub n, right? Now, if the bigger converges, then the smaller converges. The bigger right here, a sub n, then this one, b sub n. If the smaller diverges, then the bigger diverges. Now we look at this one right here, a sub n right here converges, right? A sub n greater than this one. So if this one converges, this one must be convergent, right? So we look for the answer right here. Which one smaller than a sub n? Actually, this guy right here. Because we divide the series a sub n by a positive number, so it could be less than this one, right? So the answer must be E. Because a sub n converges, the smaller one converges by direct comparison test right here. Question 21. The infinite series a sub k has n partial sum a sub n equals n over 1 minus 4 times n for n greater than or equal to 1. What is the sum of the infinite series? So remember, the sum of an infinite series is the limit of its partial sums when n approaches infinity, right? So we need to find the limit of s sub n when n approaches infinity equals limit of n over 1 minus 4 n when n approaches infinity, right? So when n approaches infinity, this guy grows faster than 1, right? So it can be limit of n over negative 4 times n when n approaches infinity, right? So we can cancel out this one. The answer is negative 1 over 4, right? So the answer must be C. Now let's move on to question 22. Find the sum of the series right here. Alright, so observe that the power right here are even, right? The factorial right here also even. Think about the Taylor series of cosine, right? So remember, cosine s equals 1 minus s squared over 2 factorial plus s to the 4 over 4 factorial minus s to the 6 over 6 factorial plus s to the 8 over 8 factorial minus s to the 10 over 10 factorial, etc. Right? Let s equals pi, so we get this guy right here, right? So we have cosine of pi equals 1 minus, substitute pi for s, so we have pi squared over 2 factorial plus pi to the 4 over 4 factorial minus pi to the 6 over 6 factorial plus pi to the 8 over 8 factorial minus etc. Right? So the right hand side right here, actually what we need to calculate right here, right? So we need to calculate cosine of pi, actually negative 1, right? So the whole thing right here, actually negative 1, right? The answer must be A. Now let's move on to question 1. Select the values of a function f and its first three derivatives are indicated in the table above. What is the third degree Taylor polynomial for f about s equals 1? The question wants you to find the third degree Taylor polynomial. Alright, so we're gonna stop right here, right? And the center at s equals 1 is tells us that a equals 1, right? So we have p3, right? Because we start at 3. Of s equals f of 1 plus f prime of 1 times s minus 1 over 1 factorial plus f double prime of 1 times s minus 1 square over 2 factorial plus f triple prime of 1 times s minus 1 cube over 3 factorial. Now f of 1 is 2, right? Plus f prime of 1 is going to be negative 3 times s minus 1 plus f double prime of 1 is going to be 3, right? 2 factorial is going to be 2, so we have 3 over 2 times s minus 1 square plus f triple prime of 1 is going to be negative 2, right? And 3 factorial is going to be 6, right? So we have negative 1 over 3, right? Times s minus 1 cubed. So the answer must be B. Now let's move on to question 2. The third degree Taylor polynomial for the function f about x equals 0. It tells us that the center equals 0, right? T of x equals this guy. Which of the following table gives the value of the function f and its first three derivatives at x equals 0? Right? T3 of s equals f of a plus f prime of a times s minus a plus f double prime of a over 2 factorial times s minus a squared plus f triple prime of a over 3 factorial times s minus a cubed, right? Now, center at s were 0, which means a equals 0, right? Substitute 0 for a, we have this guy right here equals f of 0 plus f prime of 0 times s plus f double prime of 0 over 2 factorial times s squared plus f triple prime of 0 over 3 factorial times s cubed, right? Now we given this guy right here, so we just put this guy down over here. Now we just match this guy up. F of 0 equals 3, right? Next one, f prime of 0 equals negative 4, right? F double prime of 0 over 2 factorial equals 2. So f double prime of 0 should be 4, right? And f triple prime of 0 over 3 factorial equals negative 3. So f triple prime of 0 equals 3 factorial times negative 3 is going to be negative 18, right? So all this is match this guy. Now let's move on to question 3. What is the radius of convergence of the series s minus 4 to the 2n over 3 to the n? Alright, so again, we're going to use the ratio test, right? So we have limit of absolute value of a sub n plus 1 over a sub n when n approaches infinity, right? This guy right here, actually a sub n, right? So we have limit when n approaches infinity of absolute value of s minus 4 raised to the 2 parentheses n plus 1. Be careful. If you write 2n plus 1 like this, that's completely wrong, right? Over 3 raised to the n plus 1. Divide by this one, we're going to multiply by its reciprocal, right? So 3 raised to the n over s minus 4 raised to the 2n, right? So we're going to simplify this one. This guy actually 2n plus 2, right? So we have limit when n approaches infinity. Absolute value of s minus 4 raised to the power of 2, right? Over 3, right? Because 3 raised to the n and 3 raised to the n cancel out. Absolute value of s minus 4 square over 3, right? And we need this guy to be less than 1, right? So it's going to be absolute value of s minus 4 square less than 3. Now check square root both sides. Absolute value of s minus 4 less than root 3, right? So it's going to be negative root 3 less than s minus 4 less than root 3, right? Now we just draw the number line, right? Now observe that the center right here, s equals 4, right? So we put 4 right here. Now if we solve this one, it's actually s less than 4 plus root 3, right? And this guy greater than 4 minus root 3, right? So right here, 4 plus root 3, and right here, 4 minus root 3, right? And the distance right here is greatest conversion, which is root 3, right? The answer must be C. Let's move on to question 4. For x greater than 0, which of the following is the function of this power series, right? You know that the cosine function, the power right here should be even, right? The bottom must be even, so this is odd, this is not the case, right? Now B, the top should be odd, right? The bottom should be odd, but the top is even, so it's not the case. C, sine s over s, this one could be, right? Remember we have sine s is, so if I take sine s divided by s, and then this guy divided by s could be 1. This guy divided by s could be negative s squared over 3 factorial plus s to the 4 over 5 factorial minus s to the 6 over 7 factorial plus etc. So the answer must be C. Now let's move on to question 5. What is the coefficient of s to the 4 in the Taylor series for cosine square of s above s equals 0, right? So when s equals 0, it tells us that this guy is the Markov series, right? So we have cosine of s equals. So if we need cosine square of s, this guy actually cosine s times cosine s, right? So does that mean this guy multiplied by itself, right? But I don't recommend you doing this way because it's time consuming, right? So let's do this way. We have cosine of s equal this one, right? So what happened to cosine of 2s, right? So we just replace s with 2s as the big one minus 2s altogether square over 2 factorial plus 2s altogether to the 4 over 4 factorial minus 2s to the 6 over 6 factorial, etc. I'm going to simplify this one. It's going to be 1 minus 2 squared over 4 divided by 2, it could be 2, so 2s squared, right? 2 to the 4 could be 16 divided by 24. It's going to be 2 over 3 s to the 4, right? Now, since we only need the coefficient of s to the 4, we stop right here, right? But this is cosine 2s, right? We need cosine square of s. Now, remember, we have cosine square of s equals 1 plus cosine 2s over 2, right? Also, sine square of s equals 1 minus cosine 2s over 2, right? So, I have cosine square of s equals 1 plus cosine 2s is actually this one right here, right? Divided by 2. 1 plus 1 is going to be 2 divided by 2 is going to be 1. Negative 2 divided by 2 is going to be negative s squared, right? And 2 thirds divided by 2 is going to be plus 1 third s to the 4, right? Now, the answer must be 1 third, right? Coefficient of s to the 4. The answer must be C. Now, let's move on to question 6. The function f has derivatives of all orders for all real numbers. And the fifth derivative of the function f is e to the psi s. If the 4-degree Taylor polynomial for the function f above s were 0 is used to approximate the function f on the interval 0 to 1, what is the Lagrange error bound for the maximum error on the interval 0 to 1? Alright, so since this one is the non-alternating series, we're going to use the formula right here, right? And observe that this is the 4-degree Taylor polynomial for the function f above s equals 0. And then n plus 1 right here must be 5, right? So I'm going to copy this formula over there. Now note that n plus 1 right here actually 5 right here, right? And n equals 4 right, 4-degree Taylor polynomial, right? So I'm going to substitute. Now remember C equals 0, right? Center at 0. So we need to find the maximum of this guy right here within this interval, right? Now e to the side s is maximum when sine s is maximum when s equals 1, right? The largest value of this interval, right? So we substitute 1 for s, and we have. Now we're gonna print up the calculator. Hit this button right here, input the absolute value side right here. Hit this button, input the fraction e to the sine of 1 over 5 factorial. Hit control and the button right here, input the factorial, and then press control enter. It's gonna be 0.019. So the answer must be B. Question 7. Let f be the function given by Ls equal ln of 3 minus s, the third degree Taylor polynomial for the function f about s equal to is. So this guy is the center, right? So the center a equals 2, right? So we have the Taylor polynomial is given by the formula. Now you given the function f of s right here, right? So we need to calculate f prime of s first, right? So it could be, we're going to use the formula ln of u derivative. It could be u prime over u, right? So it could be negative 1 over 3 minus s, right? So then f prime of a, but a equals 2 right here. So f prime of 2 equals negative 1 over 1, right? So it could be negative 1. Now f double prime of s equals negative 1 over s minus 3 altogether squared, right? So then f double prime of 2 is negative 1. Now f triple prime of s is 2 over s minus 3 cubed, right? So then f triple prime of 2 equals negative 2, right? Now don't forget to calculate f of 2, right? So it could be ln of 1 is to be 0, right? So we substitute this value into this formula and substitute 2 for a, right? Then we're going to end up with the answer B. Question 8. What is the polynomial approximation for the value of sine of 1 obtained by using the fifth degree Taylor polynomial about s equals 0 for the function psi s? Alright, this is very simple, right? So we have psi s is given by the formula. Now we only need fifth degree, right? So we stop right here, right? So we have psi s is approximately s minus s cubed over 3 factorial plus s to the fifth over 5 factorial. Now we need to approximate psi of 1, right? So we have psi of 1 approximately 1 minus 1 over 3 factorial plus 1 over 5 factorial, right? And it's gonna be 1 minus 1 over 6, right? Plus 1 over 120, right? So the answer must be E. Now let's move on to question 9. What is the coefficient of s squared in the Taylor series for 1 over 1 plus s squared about s equals 0? Alright, so remember we have the Taylor series. It's going to be given by the formula. Now note that a equals 0, right? Substitute 0 for a over here. And we need the coefficient of s squared, right? So s squared, which means right here. So the coefficient is right here, right? So we have the function f of s is given by 1 over 1 plus s altogether square is actually 1 plus s altogether raised to the negative 2, right? So we have f prime of s is going to be negative 2 times 1 plus s raised to the negative 3, right? F double prime of s is going to be 6 times 1 s raised to the negative 4, right? Now s equals 0, substitute over here, so we have f prime of 0 equals 6, right? So we print it over here. So we have the coefficient f double prime of 0 over 2 factorial equals 6 over 2 is going to be 3. The answer must be D. Now let's move on to question 10. If f(s) equals s times sine 2s, which of the following is the Taylor series for f above s equals 0? We have sine s is given by, now we have sine of 2s, just replace s with 2s, multiply both sides by s. So we have s sine of 2s equals, so the answer must be E. Now let's move on to question 11. A function f has Markov series given by this guy. Which of the following is an expression for the function f(s)? Alright, so look at the answer choice A, B, C, D, E right here. Answer choice A, B, C related to sine and cosine. Answer choice D and E related to e to the s, right? So remember the sine function is given by, and the cosine function is given by, the given one right here has 2 factorial, 3 factorial, 4 factorial, right? So it cannot be A, B, C, right? Because you have 3 factorial, 5, 7, or 2, 4, 6 only, right? Now we have e to the s is given by, now look at D right here, we can factor s squared out. So we have e to the s minus 1, right? So I'm going to subtract s and subtract 1 both sides, right? So I'm going to end up with e to the s, subtract s, subtract 1, and then this guy gone. I'm going to have s squared over 2 factorial plus s cubed over 3 factorial plus s to the 4 over 4 factorial plus etc. Right? I'm going to multiply both sides by s squared, right? So I have s squared times e to the s minus 1 equals s to the 4 over 2 factorial plus s to the 5th over 3 factorial plus s to the 6th over 4 factorial plus etc. Right? So the answer must be D. Now let's move on to question 12. Let P of s equals 3s squared minus 5s cubed plus 7s to the 4 plus 3s to the 5th be the 5th degree Taylor polynomial for the function f above s. What is the value of f triple prime of 0? The coefficient of s cubed is given by f triple prime of 0 over 3 factorial in the Taylor polynomial expansion, right? Now we just match this guy up, negative 5 s cubed and this guy right here, right? So we have the coefficient f triple prime of 0 over 3 factorial equals negative 5, right? So f triple prime of 0 equals negative 5 times it equals negative 30, right? The answer must be A. Question 13. Let f be the function f of 3 equal to f prime of 3 equals negative 1, f double prime of 3 equals 6, and f triple prime of 3 equals 12. Which of the following is the third degree Taylor polynomial for the function f above s equals 3? So the center A equals 3, right? So we have P3 of s equals f of 3 plus f prime of 3 over 1 factorial s minus 3, right? plus f double prime of 3 over 2 factorial s minus 3 square plus f triple prime of 3 over 3 factorial s minus 3 cube, right? We substitute values, right? So we have p3 of s equals f of 3 equals 2 plus f prime of 3 equals negative 1, right? So it could be negative of s minus 3. F double prime of 3 equals 6, so 6 divided by 2 could be 3, so plus 3 times s minus 3 square. F triple prime of 3 equals 12, so it could be 12 divided by 6, it could be 2 s minus 3 cube, right? So the answer must be A. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young, it has just begun as she puts her hand in mine.